Yeah, so we're ready. So good morning once again. Welcome to this 171st edition of the Zak World of Façade conference series. My name is Ahmed. I'm part of the organizing team here at Zak. I just quickly want to introduce the Zak World of Façade conference series with you guys, for those who are attending for the first time around. So we've been doing this event since 2012. This is our 5th edition in Hyderabad. So we first came to Hyderabad, I think, back in 2015. A lot has changed in Hyderabad. 2016, a lot has changed in Hyderabad from then until now. There's lots of construction happening. The city is always changing. Every time it's a pleasant surprise to see it being more modernized. So which means that you have to take care of the buildings. You need to build them better. You need to build them more sustainable, more safe. And I think facades are also playing a major role in designing and shaping cities. So I think today's event will showcase storytelling from our speakers and from our sponsors in terms of how to design safe and sustainable facades. And of course, this conference series we've been doing all across the globe. We've got almost 36 events in 23 countries alone this year, all across the globe, right from New Zealand up until Canada. The way facades are designed, engineered, installed in different countries are completely different. In the Western world, it's more about carbon reduction. I think in India, in Asia Pacific, it's more about value engineering, cost, which will obviously change as the market evolves, as complex projects come in. So for us, every event is different. We need to curate to the local market and put forward storytelling from our speakers, which is unique and bespoke for that market. These events are courtesy our event partners. I'd like to thank all of them. They all have an exhibiting booth outside there, so please network with them in the networking breaks. We start with Shuko. So Shuko is a global leader in aluminum door, window, and curtain wall systems. They are a presenting partner of this event and many of our events globally. Our powered by partner is Aluplex. Aluplex is one of the leading in facade engineering, contracting, installation out of India, based, the factory is based around 100 kilometers from here. Alu Decor is again one of the leaders in aluminum composite panel or metal composite panel cladding products. Started as an ACM company, and they have a wide range of cladding products now. Assa Abloy is automatic door division is participating with us. Assa Abloy, again, a big Swedish company, a lot of products. This is their door automation division, which is participating with us over here. Blick Systems have stone cladding systems. They've got other solutions for the facade. They are participating with their Indian distributor, which is DEC Diamond Engineering Corporation. Cotswold is from the UK. It's from a town called Cotswold. So they've got hardware solutions for doors, windows, and facades. Dow, again, one of the world leaders in sealing and bonding solution, earlier known as Dow Corning in India, the brand is Dowsil in the market, which we sell. Which they sell. Eminent International is one of the facade testing laboratories here. They have a very nice, interesting water penetration mock-up outside. So they're also based here. The testing lab is based here in Hyderabad. Euromax is a coil coating company from Belgium. They are also represented by the local partners, Diamond Engineering Corporation. FG Glass is one of the leading value-added glass processing companies based out of Mumbai, operating nationally and internationally. Fundamax, again, global leaders in high-pressure laminate solutions. I think they were the first to bring this solution to India. It's now picked up a lot. One of most popular products for residences. It's there in my own residence. I love the product. The senior management team is here from Austria also, gracing us with their presence today. GE Silicons into sealing and bonding solutions. They are with their local partner, Diamond Engineering Corporation. Jotun, again, one of the world leaders in powder coating solutions. So you need to coat your aluminum profiles, and Jotun have super durable solutions for longevity on your aluminum profiles. Kinlong is, again, a global leader in glass hardware, fitting, custom-made stainless steel solutions. Anything to do with the building envelope, they've got a solution. They keep on adding companies year by year, so their product range is very long. Kurare, again, is the mother company of the laminated glass interlayers, Throcifol and Sentry Glass. So they help in making your glass stronger. Q-Tone is an Indian manufacturer of, I would like to say, sintered stone, which is a ceramic-based non-combustible cladding product. Again, we still are very dependent on traditional aluminum composite panel. I think we need to move, as the market grows, we need to move to more different metals, ceramics and other cladding materials. So I think a market correction will come. These materials are recyclable and are sustainable. So ceramic cladding, sintered stone, tile-based, slab-based is also another alternate option to the conventional cladding products. Ramco Industries, again, one of the leaders in fiber cement board cladding. So now they've got an external system which can be used on the external facade. Viva Metal Composite Panel started off as an aluminum composite panel manufacturer and has now progressed to solid metal panels and a lot of other metal composite panels. So again, aluminum composite panel company making innovations into different cladding materials. So that's a sign of an evolving market. I think 10 years down the line, it was only aluminum composite panel companies, but now there's a lot of variety in cladding materials which people can choose depending on the project and all the stuff. That's very nice to see that our market is changing. Of course, the basis of these events are our mother events of the Zak glass technology on glass processing, the doors and windows on doors, windows, facades, and our aluminum extrusion show, which is in Bombay and Delhi end of the year in December, every alternate years. So of course, this is our roots. This is where we started from, and then we evolved into these conference series. Quick glimpse, we head to Sydney, Australia next week. Australia is a great market in terms of sustainable products and construction. They have their own set of challenges in terms of no local manufacturing, but how they import everything from overseas and how they are still able to be sustainable. Then their neighbors, New Zealand. New Zealand, again, I think is one of our most surprising and well-attended events. We were bold enough to go to New Zealand all the way and do an event there, and they had never ever seen a facade conference in their history ever. So we take experts from across the globe, and we talk about their local projects and what's happening there. Singapore in the closer region next March, and of course our next few events in India. We go to Pune, so Pune was a first for us. Last year, go to Bangalore, and of course the biggest one in the series is Mumbai. That's it from me. I'd like to call upon today's event host and convener, Mr. Srinivas. He's going to be hosting today's event. He's a regional head at Sahvia Facade, and he'd be taking you through until the end of the day. So can I have Mr. Srinivas on stage, please? Thank you.
My name is Srinivas Deekonda. I am from Sahvia Facade Consultants. Please give him a big round of applause to welcome Speaker Anujay Vootla, the Design Director of Genesis Planners.
Good morning, ladies and gentlemen. Today I have a topic which is very close to my heart. I'm also a PhD scholar. We're getting close to finishing the research. And when we talked about Zak, they make facades. So it just immediately struck me that, we all have facades. We put a facade to the world. What is inside, only we knows or God knows. So when I thought about it, when I went into the process of design, why we create facades, what is the reason that the facades are there, and what are they concealing and what they are letting in. I think when you go into the epistemology of design, we are born with a skin. And did you guys know the largest organ in the human body is, anybody can take a guess? Right, absolutely right. So we tend to ignore that aspect of the design that we are built in. Our skin lets things in and obstructs some things. I'm going to build up a little argument and a rationale how we come up to that. So we are born with a skin. We have a second skin, that is our clothes. And we have a third skin, which is our built environment. And probably there's a fourth skin, which is modulating things and letting in and letting out things. So it's a huge world of facades that we are talking about. So this is a French philosopher. He said that we are not human beings having a spiritual experience. We are spiritual beings having a human experience. So if you also dig into the latest technology and latest science, that this whole world is being equated to something like a virtual reality, that we are wearing these body suits and there we are existing in our environments. And architecture is just an extension of that. And going back to the traditional Upanishads, it says that as is the human body, so is the cosmic body. As is the human mind, so is the cosmic mind. And as is the microcosm, so is the macrocosm. As is the atom, so is the universe. And in Bhagavad Gita, it says this, Anoraniyam Mahato Mahiyam. That means I am in the smallest of the small and the largest of the large. And that actually adds up to 1:1.6 and 8. Which is the ratio of the golden rectangle, which happens in architecture. If you see these things here, this is very interesting. That's the brain cell and that's the universe. That's the birth of a cell and that's the death of a star. And that's the human iris in the eye and that's a nebulae. You see everything. It's just magnified from the smallest of the small to the largest of the large. And Winston Churchill, he says, we shape our buildings, thereafter our buildings shape us. So what we create, in turn, modulates our being. And taking that to an extent, this is Bruce Lipton. He says that you may consider yourself as an individual, but as a cell biologist, I can tell you that you are in truth a cooperative community of approximately 50 trillion single-celled citizens. Almost all of the cells that make up your body are amoeba-like individual organisms that have evolved a cooperative strategy for the mutual survival. We are building our cities just like the human body. It's an extension of the microcosm into the macrocosm. We have, just like the city has a bad spot, we can have a good locality, and the arteries are the traffic that is running. A lot of analogies that you can look into. And taking the same cue, how we create, the epistemology of creation. On the left side, you see the computers. On the right side, you see the human biology. So CPU is the brain, motherboard is a neural network, virtual reality is the pineal gland, graphic card is the imagination, the power and the energy, the processing speed, buddhi, the hardware is the body, the peripherals is the physiology, operating system, and goes on and on and on. What we create is just in our own likelihood. God created our man in his own likelihood, or you can just say this, that we created God in our own likelihood. So this is embedded in our creative process. And taking that further, one of the famous neurologist and neurosurgeon, he said that the environment that we have created actually sustains only on this tripod, which is magnetism, light, and water. Why am I mentioning this thing today is that we are dealing with a lot of light here. Because the Zak World of windows, we are creating these perforations and then the vision into the world that is outside. Only with light it is all possible. But there is a huge spectrum of something else that I would like to point out here. When you're doing this thing, this portion here that you look at, the visible light spectrum is only 0.034% of that is visible. Of the whole energy spectrum, that's what we see. That's 0.034%. And rest of it is all there, we don't see it. And we are only concerned about what we see and forgetting what we don't see. Here comes the most important thing that I would like to mention, because sustainable architecture actually has to depend on this foundation stone here. Light enters our brain through the eye retina. It goes and hits the SCN, what they call it, suprachiasmatic nucleus, and triggers the pituitary gland. The pituitary gland connects your thyroid, and thyroid connects your endocrinal system and the whole gamut of your biology. First time I read an article which said that, LED lights cause diabetes. I was like, what? What are you talking about? It's actually the endocrinal system triggers that. So this biology becomes the basis of dealing with light. With the light, as the light levels go up, we have cortisol levels going up during the day. And by the time it is dusk, the cortisol goes down and melatonin goes up. And that's when we tend to sleep better. 1/3 of our lives we sleep. That takes care of our health. What is happening these days as compared to the last century? The average sleeping time, which was 8 hours in the last century, has been reduced to 6.5 with the intervention of artificial light. And artificial light is not making our biology sustainable. Did you guys know that anybody who lives very close to the equator has a darker skin, and anybody who lives closer to the poles have lighter skin? You know why? Because the skin modulates how much of light that it needs to enter into the body or stop it. You have lighter skin, you need more sun. You have darker skin, very little sun is good enough for you. So there is a cue to what facades we design, how much light we make that indoors, or what is necessary and what is not necessary. And the same goes for the food. If you are eating the food which is being grown near the equator, and you happen to live in the North Pole or the South Pole, it doesn't work. Your health has a zip code. You better eat things which are closer to your birthplace zip code. This is also built into your mechanism. And for a long time, people were thinking about cholesterol was bad. And they said, let's introduce statin drugs. Am I sounding more like a doctor here? Sorry, I'm not a doctor, but an architect here. But it's just my passion to, dig into these things. Stefan said, she said, there's a lady, her PhD was taken back from the MIT because just that she said that light and sun are more important than your cholesterol. And what happens is the sunlight hits your skin and the brain gives a message whether it needs to create cholesterol sulfate, which cleanses your arteries of the cholesterol, or it will create nitrous oxide related blood pressure reducing mechanism. So you don't need to take a pill, just sit in the sun and you're cured of your diabetes, your hypertension, and cholesterol problems. Now, there is a rating that has been done. That's the excellent sky that used to be there in the last century, but this is today's sky. The city suburban. And these are the light levels that have inundated our environments. And this is the interior which is actually mimicking the sunlight from outdoors through indoors during the day. This is called circadian lighting that you guys might. So how many are aware of this circadian lighting that has been introduced? Thank you. So it is just to make sure that you are living in an environment which is consistent with the outdoor environment, which actually helps your biology rather than hinder it and cause a lot of stress. And there are different methods, how to control what is bad, what is good, and everything. So this is the satellite picture of India and the different countries. And a lot of epidemics happening because of this artificial intrusion. And 90% of the people who survived the COVID last time had higher levels of vitamin D, which is correctly correlated with the sunlight. And this is our lifestyle these days. Late into the nights, bombarded with artificial light. And as a result, coming back to architecture, this is a project by HOK, where I used to work before. This is, if you look at the typical building plan here, and there's a big connection here that the indoor users are constantly being exposed to what is happening outside. This is a sustainable way of designing your facades where you let in the natural light that will take care of, and there's also the energy demands of lighting it artificially is also taken care of. This is one of my favorite projects. Now coming back, rethinking about what the facades are. The idea of the form and aesthetics might make a big impact to do some eye candy architecture. Or you can do the function and technology, the Abu Dhabi building in the center, which actually mimics something like what the dark skin and the fair skin kind of a technology that happens in our biology. And then the sustainability of it, the biophilic architecture which has been introduced in all these three concepts that you can see. Then you have the dynamic and adaptive facades. Dynamic and adaptive is an electrochromic glass, which actually, the thing that I was talking about, mimics what is outdoor and indoor. With the introduction of AI and technology, everything is possible. And we have kinetic facades, dynamic and adaptive facades, which are very pleasing to look at and something different and exciting, with smart materials. And then of course you want to give something back to the grid. You can create your own electricity, and then so much of sun's energy is being wasted, so you capture that and create facades. Then you have advanced insulation techniques and materials which are available, especially the aerogels, which are very light but still allow the light to pass through. Then we have responsive ventilation and shading, which is the Abu Dhabi project is one of my favorites, which actually mimics a lot of sacred geometry, the responsiveness to the climate, beautifully integrated. It's almost like a living thing. And of course, the greening of the facades, the vertical forest kind of a thing that we've been exploring. This is the Italian project on the left. And of course, it ties up with the biophilic design where you feel better and good when you connect with nature. And then the possibilities of it with the 3D printing and the designs that are available with the help of software. And then smart facade systems, which are very, nowadays with the introduction of AI. AI has loads of information, and it all depends on us, and it is the duty of architects and designers like me to judiciously pick what information needs to be translated and transformed into the things that we are designing. And then transparent and hybrid materials, you want to recycle something, and then there's a plastic that is being recycled and then used. And eventually, my favorite topic and close to heart, which is the circadian lighting integrated thing, design. So when these lights are really harsh, ideally I would have put on some kind of blinders, in the sense yellow glazing. It's because it's sending a message to my brain saying that it is mid-afternoon and cortisol levels need to go up, and eventually my BP will go up because of this harsh light, which is close to about 6,500 Kelvin. And the same project, which is the circadian lighting example. Then what are the possibilities on the horizon here? Dynamic and adaptive facades, which are not only just manually controlled, but it could be tied up with a building system itself, which actually works in sync with the rest of the day. And then not only just the building facades, maybe the highways. There is a lot of technology that we can learn when we introspect our own biologies. After all, we are building all our cities for the human-centric purposes. So we need to be there to appreciate it, or it needs to, whatever we create needs to sustain us. So these days, buildings look like they are just doing yoga, and you're seeing this chakras and how whole biology is functioning. Le Corbusier once said that a house is a machine that we live in, and then it got transformed into a thing that no, it's a living thing that we live in, is today's concept. And eventually, for the people who are more interested in the biology of it, we function because this is my favorite hero, this is Jack Kruse and Bruce Lipton. They said that your future belongs to the sensor that you don't notice. It is the sensor that built into your life, and attached to it, it is mitochondria. Mitochondria is something which totally controls your well-being. And it is connected with the sunlight. And whatever we design in terms of screens and layers that we are loading in our environments need to have a little sensibility about why are we building things, what are we building, without looking at the business point of view of plus and minus. So this is the final thing. This is Corbusier, I said, house is a machine to live in. But there's another saying which says that a house is not a machine to live in. It is the shell of man, his extension, his release, his spiritual emanation. So with that, I end my presentation. Thank you.
I would like to now invite our next speaker onto the stage, Ashwanii Khanna, the Chief Customer Officer from Fundamax India.
Okay, good morning, ladies and gentlemen. So it was really very insightful presentation. You connected many dots, spirituality, chakras, skin, light. So all these things are really connected, and facade is not just the face of the building, it's basically the skin, and it should breathe. So before I get into thick of things, I would request everyone to please log in to menti.com, because I want to talk to each one of you sitting in the room, because I'm really feeling alone here at this stage. So if you could please log into the menti.com, and you would be asked the code. The code is 772787774. It is also mentioned on the top of the screen. I'm sure we have more than 100 people sitting in the room, but so far no login. Wow. Yeah, happy Valentine Day to everyone. Yes, it's 14th Feb, not to forget. Great, good, energized, but only 2 people have logged in yet. We need more participation, please. 5 people have logged in. 6. Good and great. Awesome. This is getting bolder. So everyone is feeling good. And your presentation was really energizing, sir. That's a great start. Great. Wow. Okay. Let me, in interest of time, because I don't want to hear the bell, in interest of time, let me move on. Yeah. How important is the facade while designing the building? Because we all are talking about facade here. This event is World of Façades. So, inevitable. Yes? Yes? Face, very important. Yes? Aesthetics, very important is getting bolder. Joyful, necessity, it's the visual skin. Functional is also coming up. Face, yeah, it's design. It's the face of the building, of course. It is supposed to be unique. Moving on to the next question. So, while designing the facade, what is your expectation from the facade material? It should be safe, durable, sustainable. Sustainable is coming up, yeah? Performance, aesthetics should also meet functionality. Yes, adaptable, durable and light, ventilation, but sustainable is in the center. It's for us also, it is really a very big topic for Fundamax, and we are very serious about it. Moving on, your impression about the sustainable facade. So that was my second, next question. And thanks for making sustainable really at the center, making it bolder. And my next question is justified. So what is your impression about sustainable facade? Yeah, it should be for generations to come. Buildings should last longer. We are not required to redo the buildings. Long lasting. Environment, we have to protect the environment. We have a collective responsibility. Low carbon. I'm just reading what is coming to my eyes immediately, but there are many other topics here. It's a way forward. Yeah. We want to bring one topic from our side, which is also my topic today. What role does facade material play in ensuring the fire safety of the building? Key role, high important, critical, significant, 100%, I assume it is 100%. Yeah, so it's very, very important that facade, the skin, should also play a role in ensuring the fire safety of the building. Thank you. You have a wonderful audience. Thanks for participation. Now I'm not feeling alone. I'm confident to move forward with my presentation now. Today's topic is cladding on a high-rise building, but we are going to deeply touch upon the fire behavior of different materials. We will also talk about behavior of Class A and Class B material. So what actually the fire is? Fire is an exothermic rapid oxidation of the material. As a result, we get heat and light. And this definition does not cover the slow oxidations like rusting or digestion. Now, depending upon the source of fire, we have different classifications. A, B, C, D, K. This is the logo which we normally look on the fire extinguishers, like in the households or even in the buildings. Let me talk about, let's say, Class A, classification of the fire. It is originating out of ordinary material like wood, paper, rubber, and we look for this A logo on the fire extinguishers. normal water is also sufficient to extinguish the fire. Whereas when it is from the gases or flammable liquids, water is not good. We need dry powder, carbon dioxide to extinguish the fire. So, depending upon the source of fire, we have different ways to extinguish the fire. Moving on, then we have different material in the industry which are available. For example, as per the Euro class, we have A1 material, we have A2 material, we have Class B material. A1 and A2 are basically limited combustibility or no combustibility. For example, concrete. It's not combustible material at all. Similarly, A2 material and Class B material. From Fundamax, we have M-Look as a A2 class material and Max Exterior as a Class B material, which will not propagate the fire. We will discuss this in detail in the next part of the presentation. Now let's look at this diagram on the right side of the audience. The moment any material reaches the ignition temperature, it will start burning. Then the very important phase comes is the flashover point. Any material which crosses the flashover point will develop into a full-fledged fire. It will reach to the peak. So any material which will reach to the peak is not suggested to be used on claddings, because they have to act as a skin, they have to act as a surface to protect the building from further propagating the fire. Now in our case, M-Look panels, which are A2 class, they will have limited combustibility, they will remain at ignition temperature, but they will not move to the next level. Whereas Class B material will reach to the flashover point, but most importantly, it will not cross the flashover point. So both the products will not develop into a full-fledged fire. So as per the fire norm, the classification for M-Look is A2S1D0. I will explain it in detail. And for the Class B material, which is Max Exterior in our case, the classification is BS2D0. Now, as we said, A2 is limited combustibility and B is fire retardant. Fire retardant would mean it will not propagate the fire the moment we remove the source of fire. And S is the smoke index. Smoke index is 1 and 2 in M-Look and Max Exterior panel. And D is droplet. Droplet is 0 in both the cases. Now, I would like to touch upon smoke. Smoke plays a very important role when you have to extinguish the fire. If there is dense smoke, it is very difficult to identify the source of fire, where the fire is. It really becomes very difficult. And if the smoke is toxic, it can cause suffocation. The casualties normally does not happen because of the fire. It normally happens because of the smoke, because of the suffocation. From my childhood, I really remember Upahar Cinema tragedy in Delhi. How many of you remember Upahar Cinema tragedy? It was like, for me, it was like one of the case wherein the fire broke out in the cinema hall and the smoke was so dense that fire extinguishers had a tough time in identifying the source of fire and put it down, right? So we have both the products in offering, M-Look and Max Exterior. In fact, both the products are having decorative surfaces on the top as well as bottom. You can use both the products in combination. For example, these are two tall buildings. These two faces can be used with M-Look, other faces can be used with Max Exterior. This can help us in optimizing the cost as well. We have also done testing as per different standards, different regions. If we go to US, we have ASTM E84. Similarly, in India, we have done, we compliant to NBC 2017. We have also done NFPA test. I'm moving on in interest of time, and we are open to discuss the tests in detail. We have a booth outside. We are open to engage and discuss. But I have one interesting case over here. we don't have NOC to show the full project. But this was basically a residential project somewhere in upper north. This is max exterior panel which was used on the facade of the building. The fire broke out inside the house because of some short circuit. There were a lot of wallpapers on the living room and the whole house was burning in minutes. The intensity of fire was so high that the glass blasted. With due respect to the glazing, glass, we don't know what type of glass was used, but the glass blasted. What you see over here, the brick which is exposed, the surface, the plaster has also been ripped off because of the intensity of the fire. And that is when, for the first time, Fundamax panel came in touch with the fire. This was a time when Fundamax acted as a fire retardant material and did not propagate the fire to the next level. If you see the extreme left of this image, which is basically the front facade of the building, the fire did not even reach to that level. And the entire system did not lose the integrity. We used the complete system. Even the fasteners, the rivets are from Germany. None of the rivet gave up. The entire system was intact. And the other part was when we reversed the panel, we also tested it. We reversed the panel. The decor paper on the other side of the panel was also intact. So, how do we do the installation? We do the installation in the principle of rear ventilated facade system, which is also a type of rain screen facade system. Rear ventilated facade system is nothing but there is a cavity between the facade and the wall, allowing air to circulate. Like as we heard in the previous presentation also, we should allow certain things to go inside the building, so we are allowing air to go inside the cavity, thereby not blocking hot air inside the cavity. So this system will allow building to breathe. This system will have better heat insulation, better sound insulation, thereby reducing loads on HVAC, and our material is lightweight material, thereby reducing loads on the structure as well. We can look at the wind loads, we can work out the details for the very complex projects depending on the wind load, height of the building, and propose the solution. Now the question comes, there is a cavity. In the cavity there would be a continuous airflow. How do we stop that in case of fire? So in case of fire, that continuous air circulation can further help in spreading the fire. So we have a solution for this. That is known as fire stop. Fire stop would be used across the building length as well as the width of the building, or in some shapes. It could be square, rectangle, triangular, so that the moment that fire stop comes in touch with the fire, it will block the fire in that compartment. So this is a very common phenomena to restrict fire to the compartments. In case of fire, we normally try to have the compartments so that fire does not spread to the next level. So it is safe to use the high pressure laminates in high-rise buildings with fire stops in place. Some of the references which we have executed, like this is Jan Height project in Bangalore. On the right side you see Trill in Chennai. Like right from G+11 building, it has been cladded right from ground to the 11th floor. All these installations, in this part, all the installations are done in the principle of rear ventilated facade system. This is also a project in Bangalore. This is a very famous building in Western Express Highway in Mumbai. This is ONGC. This is the project in Mumbai. This is very interesting project. We have used 6 mm panel up to certain height and 8 mm panel after certain height. This combination was done to optimize the wind load. I mean, to optimize considering the wind load at different floors. On the right side, it is a private residence in Mumbai. We worked at 2.5 kPa. The soffits are cladded with Fundamax panels. This is project in Hyderabad. I'll just quickly run through some of the unique applications which are also possible apart from high-rise buildings. Just quickly. Last 1 minute, please. This is double skin facade, optimizing the sunlight, optimizing the glare, acting as a shading device. Louvers, perforations we can do. Louvers, shading device, again optimizing the shading coefficient. Yeah, when the podium is given to me, I don't like to leave the podium. Thank you so much.
To welcome Mr. Sudhir Mohan from Aspect Facade Consultants.
Okay, so good morning, everyone. And I must say, I think before I jump into the presentation, so I would like to take the reference of the presentation which we had the first thing in the morning today by Anujay sir. And sir, thank you for that, for the content. So in fact, I have noted down some points which coincidentally, right, so probably links with with the content which I've tried to show. So I represent the sustainability side of our organization, right? And it's not about just on the materials which I'll be talking about, but yes, from the design perspective also, of course, the architects being at the forefront of the building designing, and how we as as a facade and also as a green building consultant, right, can support the architectural design, right, through our thinking and to the best possible, the best possible extent. So, okay. Now this is the slide which will drive the entire presentation. So when I'm talking about starting a project, right, be it any typology, right, certain basics remain the same. Now, from the building envelope perspective, so when we are talking about, right, so going about the the selection, the design of the envelope that supports the architectural intent, right, and finally on to say the execution point of it, right. So as you can see, I've just mentioned 4 words under the discover criteria, which I believe is is the foremost before we jump on to say the design. Now there are certain I would say certain things or the assumptions which come as a default. But the point here is, do we always have to go by the default working? What has been done in the past, does it need to continue the same way, right? And then that's where we are talking about the assessment aspect. And then at the last stage is the implementation of it. So when I'm assessing, say probably on a particular project for the building envelope, right? So some of the areas that we need to see, and then again working on the combinations of what the site situation presents us, and then finally what design are we going to go ahead with that truly supports the architectural intent. Now I have put some say a couple of case studies, the contents, but before that, the initial assessment of, say, from a sustainability perspective, of course, sustainability itself is a big ocean. So from the facade perspective, what are we trying to do? Now, if I just take a building block, right, and then, okay, so here we have tried to compare the scenarios of, say, the longer facades, right, which are facing the preferred, right, again, the preferred orientations which we generally talk about, the north and south being the preferred orientation for the facades, then the east and west, right? So when we start as a, as a block model, right, now where and how much quantity of glazing needs to be there on which of the facades, right? Now, the second aspect, it's not just the building in isolation, it's the surroundings, right? Now, the surrounding structures play the most important role, right? Now, again, as I said, so designing a particular envelope with the balance of the opaque and the non-opaque materials cannot go in isolation. The surrounding structures play an important role throughout the year. And of course, all this is leading to ultimately what we're talking about, the overall reduction in the energy consumption of the building. Now, once the adjacencies, the site orientation, everything is seen, here I'm talking about the zoning, right? Now again, this is one aspect which again has a direct correlation to the, the building envelope, right? The areas of the building or a particular floor space that is assigned for a working zone versus a non-working zone. Because my glazing, right, needs to correlate with this. And then the fourth step comes in. So once we have defined the zoning, right, with respect to working and the non-working spaces, of course, here I'm talking about the buildings which are, fully air conditioned. It's not the natural ventilation scenario. So based on the zoning, the quantum of the air conditioning required for that particular zone comes into the picture. And this is the aspect where my location of the glazing, the quantum of the glazing properties comes into the picture, right? Now, this scenario, as you are seeing, I've been talking about the north and south, and largely you can see the window placements, right, are majorly on the north and south. East and west are largely kept for the services, right, which doesn't need a transparent facade. Now, I compare to the other scenario of, say, the east and west, wherein my major of the facade or the glazing is going to be on the east and west, right? Again, with this, my zoning cannot be the same what I had in the north and south scenario, but rather, it will be, since my majority of the facade is facing east or west. Yes, there will be a working zone, right, either on the east or on the west, because the building is a place where people come to work, right? But the conditioning load, right, the air conditioning load also matters. So here, if you can see, the red color is probably, is the spaces for the air conditioning, which are again occupied by the various services. And the green portion represents the working area. Now here, of course, north and south being a limited area, there the maximum glazing has to be there, right, to allow the natural light. And of course, east facade will also come up with, sufficient glazing. But the story will not end here, because considering the eastern facade, and especially for a climate like India throughout the year, right? So there is some form of treatment that comes onto the facade. So one of the scenarios, of course, there are many scenarios with today's technology with respect to the various shading strategies, if I can talk that word, right? And here, if you see, one of the strategies to mitigate the heat and the excess light on the eastern facade, right? Now, this is the, probably the two scenarios of the, of the orientation. And again, I'll refer to Anujay sir's wordings of the, the use of artificial lighting, the space workings, the, the connect with the nature and the natural daylighting, right? So I think these are all, sir, I think which you highly emphasized. And this particular slide I wanted to put is, so in today's term, there's a lot of, say, the technical or rather technological advancements happening in the industry which are related to HVACs, the lighting. But before we go into the stage, the first step of correcting this building envelope attributes, that will further drive my selection of the, the materials for interiors and my overall systems. So be it the site conditions or defining the building form or the geometry, the internal zoning, the cooling energy, the lighting energy, everything, all these key 5 aspects has a direct correlation with the building envelope. And what are we trying to do with that? So we start with the prelim analysis, that is before even the schematic design of the project is ready, right? And then assessing the default assumptions. The thing which we have done in the past, do we have to do it in the same way for the upcoming buildings? And of course, by doing those two, the ultimate aim is how am I reducing the energy consumption of the building? And when I talk about energy consumption, it's largely the conditioning load, which contributes to 50 to 60% of the total building energy demand. Next comes the energy load due to the artificial lighting. So both these aspects, are direct in correlation with the building envelope attributes. And of course, now, so here there's one project that we worked upon. Of course, I cannot mention the name, but yes, so what we try to do in the best, in the given situation, from the time we entered into the project. Assessing the site surroundings. So this is the foremost step. Now, there was a situation, right, so wherein the design case building is surrounded by many structures. So during the course of the discussion, working and all, right, so of course, the larger facade was on the non-preferred orientation of east, right? And then of course, the typical working for how to mitigate the heat on the east facade and all those things went on. But then the story came up when there is a proposed taller structure coming up on the eastern facade, which is going to come up in the next 2 to 3 years. Now, considering that, do I need to design the building, say, without the shading or with the adjacent building structures? Right now, so these are some of the initial studies that we did with respect to the local climatic condition. And most importantly is from the Hyderabad perspective, right, the duration of, say, if I can choose a month of May, April, May to June. So this is being the critical month with respect to my, the city receiving the maximum sunlight and having maximum temperature. Now, do we allow this much of sunlight, especially during the peak summer, to let in through the eastern facade? And then of course, again, so assessing the sun positions, because this strategy helped to arrive at a situation wherein my eastern facade, we can go for some kind of a shading. Okay, if that is a shading, then how many members need to be there? What inclination of that shading has to be there? What is the width of the shading that needs to be incorporated? So these studies, these workings, right, helped to achieve those workings. And as you can see here, so this is one of the image which we try to assess with respect to the solar angles at different times of the year. And this is not just one, so probably I mentioned the duration as well, right? So we choose March, June and December for the time in the first half, because we were talking about the eastern facade, right? So, and of course, keeping in mind the viewing angle, right? So if people standing inside the building should not be blocked by the shading element to look outside, right? And then so, again, so this is one video which I want to play here. So if we are designing the building without any shading versus if I put up a shading and the sunlight penetration, right? So direct sunlight penetration, by the way, so this can be done for any time and any month of the year, right? And on the left hand side, we are talking about the northern facade and the front portion is the eastern facade. So how quickly I am able to cut down the direct sunlight coming into the building, and I only allow the indirect light to come into the building for throughout the day. Now as you can see here, the north facade generally, when we speak, in our technical terms, we say north and south as a preferred orientation for the glazing. But for the location of the project, as you can see here, it's even, it's 5 p.m. time. The sunlight through the northern facade is very much as it was in the morning, right? So yes, the latitudes make a difference, but it cannot be like that. Okay, so being a northern facade, we leave it, we leave it as it is, and we don't treat it, right? So by doing this, at least we got to know. Okay, so probably the duration at which the sunlight is coming into the building, right? And again, the number of the shading strategies. Do we need to go for 4 or can I put only 2, right? Or be it, or the shading has to be like a vertical or a horizontal. So all these workings, right? And then, sorry. Now this image, if we see, right? So again, this is, I would say, a typical floor plan representing the lux distribution, right? Now along the facade, of course, the maximum lux will be there, right? But as you can see, those numbers here, which are in the red zone, right? Now, if this is my base case scenario, the moment I treat the facade, so at least those 2000s along the red are below 1000. Now, when I talk about a good working lux, say for an office building, right? So it is around 300 to 700. But overall, right, depending upon the depending upon the typology, so 100 to maximum up to say a 2000 lux, right, is considered as a good lux, even though 2000 is a bit higher number. But overall, if we see the reduction in the lux, right, at the same time, not making it completely dark and not blocking, too much of sunlight as well. Now, with this, now earlier we saw, okay, so what was happening on the inside. Now, when I talk about the outside, this is the first stage where, by means of treating the facade, right, how much of the solar radiation we are cutting which falls on the surface, irrespective of, say, whether it's a glass or a wall, right? And then here again, so we have those numbers here, and the last image is the effect due to the, the adjacent structure, right? Adjacent structure also, if you can see, so that facade, right, if it's a western facade, so almost lower half of the building is predominantly shaded by the, by the adjacent structures, right? Now this will, this can also help to say wherein some quantity of glazing can still go into the, that elevation, because throughout the year, my adjacent building will be shading my design case building. And then couple of elements again. So when I talk about the energy consumption, right? So here the two elements of the solar gain and the chiller load. Now chiller load, I put it mainly from the conditioning point. And again, there are, I would say, many elements that contribute to the reduction in the air conditioning. So here just the effect of envelope, right? Just the effect of the glazing is what I've taken into this. And if I see the baseline scenario, right? So with and without, so you can see almost a sizable difference with respect to my cooling load requirement, right? Which is almost a 16%. In terms of cost, it goes much higher. And of course, that chiller load is coming due to the reduction in the solar gain. So these workings at the initial stage, so before, before even we proceed with execution, right, helps to at least freeze on, on the overall envelope design. Right. So this is the last part of the presentation. So this is what we are, we currently do as a sustainability vertical, right? So of aspect facade. Primary being the green building certifications, right? So, and of course, the simulations which, which we do in isolations as well for particular projects. And before I end, just a couple of slides. I'm sure many of you are aware of our firm, Aspect Facade and Engineering Consultants. So just to give a glimpse of how we have come so far, right, in our journey. And then, of course, on the timeline, right. So with the, with the vision of growing with the diversity, so the year 2024, it was a, I would say, we are trying to make it as a game-changing year, right, by introducing our sustainability vertical here. And then, of course, not just related to the facade, but going beyond facades. Thank you.
Yeah. Rohan Keswani, Director of Aluplex.
So good morning, I'd say. Yeah, good morning, ladies and gentlemen. Thank you very much for that introduction, and talking to you today about glazed facades for high-end residential buildings. I'll quickly walk you through before who we are, for those who don't know Aluplex. Aluplex has been in the business for more than 40 years. We have a factory not too far away from here, about 150 kilometers. I think one of the first unitized production lines in this region. We were the first to sort of bring unitized curtain walling to India, besides also bringing a lot of these suppliers and partners over here, such as the first to use Dow silicone glazing in India, which was back in 1994, the first to bring Kinlong into India back in 1998, and also one of the first companies to bring Cotswold hinges to India back in the early 90s. So we've had our journey. Before I get into my topic, I'll just quickly talk about our presence in Hyderabad. To the 2010s, basically, we had the whole commercial market of Hyderabad blow up, where we had a lot of commercial buildings. We had Hyderabad's largest steel building that was built, which is a ICICI Bank in Gachibowli. It's unmissable. It just stands there as a block, and it was one of the first buildings that used, cast-in channels. It was a composite steel structure, and that was back in 2010 when we completed that. Since then, we've done several more projects. This is a project we did for Tishman Spire, a very interesting project where we had completely unitized again over here, but we had a combination of using the stone as an infill panel within the unitized panel besides glass. And, we worked very closely on the details. As you can see, we had, it was done phase-wise, and we had these details where we had glass as an infill panel in the vision area, and we had locally sourced granite because that's something that's available in the area. And we had granite also in, put into as the infill panel. And the way of clamping that granite into the unitized panel was a combination of using silicon, structural silicon. Obviously, it's important that we had the right primer, stone being a porous material, had to work very closely with the suppliers, whilst also having a clamp on the top of the stone. So it was a combination of stone, a combination of glass within the unitized curtain wall that we used over here in this particular building for Tishman Spire. Currently, we're working on a few projects here in Hyderabad. This is a very large development. We have the client over here, the consultant here. This is my home, Grava, which is in Kokapet. It's a large development of 8 towers, starting off with the first tower right now. We just recently started last month, so looking exciting ahead. We're also working on a high-end residential, 40-story residential building called My Home Nishada. Incorporates using, unitized curtain wall onto the facade. Using unitized panels onto the building. So it's very interesting project here as well. This is also sort of expected for completion this year. Besides that, we're working with Phoenix Group. Phoenix Group is a large developer who sort of focuses on commercial and IT developments, working for an IT building with them. Now, sorry, coming back to my topic. Sorry, I've been just introducing ourselves and who we are, what we're doing in Hyderabad. The topic that I wanted to speak about is using glazed facades in residential buildings. Now, as buildings grow taller and, with the advent of high-rise buildings, it's important that we have facades and windows that are easy to install, because, it's very difficult to have external access on a high-rise facade. It's also important that you're able to maintain them, to be able to, they have the durability that exists. Otherwise, you have to paint a building. Otherwise, you have paint on your concrete wall. You have to, not going to last you more than 10, 15 years. Then you come back and then you paint it again. So this is about what we've been doing for several of our projects in Mumbai and Calcutta and other high-rise development. So these are some of the buildings I'm going to talk about. Starting off with Omkar 1973. This is a building designed by Foster and Partners in Mumbai. It's a 250-meter tall towers over there. And this was completed back in 2018. It was completed. We started it in 2016. So very interesting project. What we have here is this the laser pointer? Yeah. So we have here is a particular balustrade panel. We had a curved, unitized balustrade panel on the external envelope of the building. At the columns over here, as you can see, is we have this particular, cladding that was covering all the columns. And on the inside over here, we had sliding doors. So everything you see on the external envelope, you don't see any sort of a painted wall or any sort of RCC on the building. Everything is completely covered with either aluminum or glass, and everything is cladded. So this is the kind of balustrade panel that we developed. It was a male-female unitized system. Afterwards, we had these caps removed as we do in value engineering, as we do in most particular cases. These particular caps in the front were then removed and it became all glass. This is, for the first time we had curved unitized balustrades that were done in the country. And, we had a lot of challenges. One of them was about bending the aluminum. Now, this is the conventional method of bending aluminum. You use a 3-roller bending machine, you put the aluminum through it and it bends. But there are challenges through this, there are problems in terms of there's limited aluminum depth, you can do probably maximum 75 to 100 millimeters in depth it can actually probably bend. And the smaller radii are not possible. The other option was using a particular method called push bending, where you have a particular ram and a mold that accordingly uses a die and it pushes it to bend it. But that was obviously that was something which was, again, limited profile depth over here as well. The other method we came up with was a method called stretch forming. So what we did here is, you had to extrude the material first in 6063 T4 material, not that, without any tempering. You had to extrude additional lengths to it, maybe 500 millimeters each on each length. You had a mold based on which it was kept, and then you had to pull it from each end and stretch it across that particular mold. And there we were able to achieve this sort of 200 millimeters we made this mold and pull it from each end, and 200 millimeters deep profile could be bent. This was obviously challenging and we had to get that done, and then had to go back to the extruder to complete the tempering process, so it goes to a T6 grade high strength alloy. The other problem we had was in terms of achieving the tolerances in bending aluminum and bending glass. At the time it was very difficult, and now of course, processes have upgraded. At the time it was very, very difficult for us to achieve the tolerances of plus or minus 3 millimeters. What would happen is either you'd have situations when the tolerance of the glass would be out, and then in the middle of the glass over here, as you can see, is we have this particular, what would happen is the glass would touch the aluminum in the ends and there'll be a gap formed in the middle. So you would have 0 millimeter gap between glass and aluminum and maybe 10 millimeters here or vice versa. So we had to work very closely with the suppliers, did several mock-ups. Over here I had Mr. Ravi Shankar in the back over here, Dow Corning, inspecting how the silicon bonding is happening in terms of ensuring that we have a uniform glue line of silicon. And that's something which we had to then work with the suppliers backward, talk to our aluminum suppliers, talk to our, go back to the bending, talk to our glass suppliers, and ensure that we're able to achieve the tolerances of plus or minus 3 millimeters to ensure the proper bonding of silicon. So this is the 200 millimeter deep profile, and we had to have a 1:1 scale drawing that we kept on the ground before material was dispatched from, we had to ensure and was taken into production. We had this 1:1 scale drawing, kept the aluminum profile on it, just to ensure that we're able to achieve that particular tolerance. Same goes to the glass supplier. We imported the glass from China Southern Glass. It was a laminated glass, so we made a stencil, like a pharma they call it, or a template, and we had to run the glass through it, because even though maybe you'd have it within tolerance at one edge, by the time you went down to the bottom of the glass, it would vary through. So it's very important for us to run this through from the top to bottom of the glass to ensure we will be able to achieve that tolerance of glass, of the radius in bending of glass as well as aluminum. And then the rest is history. We used this installation techniques. We had these panels installed on the site. As you can see, is it was a 50-story building and, 64-story building. The panels were installed, and you had this sort of curved, unitized balustrade panel that was installed. It was a cantilever panel. This is how it looks on completion. All you can see is even the curved railing is a unitized panel, as well as the other balustrade panel on the other side, which is over here, that in terms of aluminum sheet and a combination of aluminum sheet and glass. This is also unitized, and you have cladding panels. So you don't see any sort of concrete or sort of a painted structure whatsoever. So that helps in the longevity and the durability of the building. The other project talking about is Lodha Park in Mumbai. Again, an 81-story, two buildings that we built over here. Some innovation we used over here. Again, we used a unitized curtain wall in large areas of the building. And what we had over here was a very interesting system. Is, usually we worked with the architect. It was Woha Architects in Singapore. And we worked closely with them, and they didn't want a plant-on operable. So normally when we have an operable panel which is fixed onto within two mullions and between two transoms, you have a plant-on operable outer frame which is fixed onto the mullion. So in this case, if you see, this is not, yeah. So basically in this case, normally you'd have a plant-on operable that comes there. But over here, as you can see, there's no outer frame. There's no outer frame that is actually installed onto the mullion. So you have a complete seamless transition. You have, you don't know which is the operable panel. You don't know which is the fixed panel when you see it from the inside. And this was possible by, using a lot of innovation. We designed the mullion such that, after, it's like a concealed sash system where we designed the mullion so that basically on fabricating the mullion, you'd have grooves that were internally available as well to stick your gaskets on. And we were able to do that. The other interesting feature about this system is that if I go back one slide, you'll see that we had a particular passive ventilator. It's not very visible in this picture, which is coming below the transom. So it was the idea to get your ventilation through. And the whole idea was that we had this, it had a PM 2.5 filter in it. And it was a passive ventilator installed above and below the transom, just below the operable. So it could slide open and slide closed, and you could accordingly allow fresh air to enter without having to open the operable at high wind speeds at the top of the building. So this is from further detailing of the particular passive ventilator system. There's a lever inside of how it all came together and how we fabricated and installed it. Eventual detail got quite complicated with the sunshade in the front and the operable and a lot of detailing and engineering that needed to be done. But I won't get into that now. The other project I'd like to talk about is the Trump Tower in Calcutta. The Trump Tower in Calcutta was, it's a 42-story building in Calcutta, interesting facade. So the building was designed earlier. It wasn't the Trump Tower then. Then the Tribeca and the Trump organization came in and they said, we want the building to be all glass. So we worked with the architects and we worked out how we could make it an all glass building. Now, one of the key aspects of this, what trends that came through as we continued with doing high-rise residentials is that the developers did not want to have side-hung operables or top-hung operables in the building, thinking that a side-hung operable, you have a limit arm of maybe 200 millimeters that you can open it at most. And then they don't quite, the resident doesn't quite get the ventilation and doesn't quite get the comfort that he's looking for in having that operable. So we said, okay, let's put sliding windows within it. Now, putting a sliding window with a sliding frame into the unitized panel, you're not going to get a nice seamless glass look. You're going to see that fat aluminum frame all around. So we designed this particular system where we had, this is your unitized panel. This is what used to be your we could see that that's your sliding door system, window system there. Then we had a rain screen system on the dead walls and the shear walls over here. And then you continue with your USG, which is your unitized structural glazing. So what we developed here was a very interesting sliding system where we had no aluminum visible externally. So the point how we were able to achieve that is because we had a step glass that was able to structurally get glazed onto the particular sliding shutter frame. Obviously, we had to work closely with the hardware suppliers and the engineering to ensure that the shutter doesn't go off balance and the loads are transmitted to the rollers well. But the idea was to have a complete seamless integration. So even when it comes to the interlock, as you can see is from the front of it, you don't actually see a particular, over here is also the fixed frame is structurally glazed and the sliding shutter is structurally glazed. So the only external aluminum you see is the vertical bit over here when you see it from the side. And even in the sort of the sliding shutter, when you see the bottom track, we built this particular track and we had this step glass such that you don't actually see any aluminum when you see it externally. So that's your sliding shutter completed and you don't actually see any aluminum and it drains out through the transom. So this is how the building looks. It's ongoing and should be completed in this year. The other project to talk about is Voyage to the Stars in Pune. This is again an interesting project. We have a railing and a sliding door system over here. This system we had unique, you had a unitized panel, you had a track incorporated in the head profile, and then you had a railing system which was then bolted onto your mullions on the outside of the facade. This is unique project in that sense. And we were able to have the track of your head section to be connected so your sliding shutter could move across panel to panel. So you didn't have to have a mega panel of sorts in this particular project. It's a sort of low-rise development, about 15 to 16 stories. Wasn't too tall. But yeah, it's sort of reached completion now, and just getting handed over in just at the verge of handover. This is a project we're doing, in Mumbai. It's again a 60-story building. It's called 25 South. Again, the interesting part about this, besides having sliding doors and unitized, it has, again, vertical passive ventilators. So as I showed you horizontal passive ventilators earlier, this uses a particular vertical passive ventilator coming at the side next to the sliding door. So you can allow fresh air to enter without actually opening your door when you need to. The last project, which is closest to my heart, is a particular project which we did in Mumbai using mega panels. Had a panel discussion about this in Mumbai at my last visit. So there are 2 towers over here which have been completed, Tower A and B, and the third tower is currently under execution. And what we have over here is an interesting system. We had a unitized panel incorporating a sliding door. Now you have these spandrel panels which are fixed onto the onto the beam. So you have 2 unitized panels per floor. You have a vision panel which is floor to floor, and then you have a spandrel panel which comes on top of it. So the idea being is then you have this big panel which then accordingly this is about 6.4 meters in length that goes onto the facade, that goes onto the particular vision area, so 6 meters by 3 meters. And then we have these shutters that come in. So these shutters that come in and then drop into the particular unitized panel. We have them bracketed at 1.5 meters anyway, so it's structurally strong in that sense. But the idea was to have a continuous track. So we have this large track panel there. I'll just take 2 minutes. And then you have your railing that comes in internally. So this is what the detail basically look like. We have this particular external these external sliding shutters where the tracks were. We had a separate stack joint over here at the bottom. Above that, we had the fixed panel. So this particular glass which comes here is your fixed panel. And then you had a separate internal railing behind the particular sliding shutters, so you have a full height kind of look. I have a short little video to show you about this. This little short case study, about 1.5 minutes. Some volume, please.
Aluplex has been at the forefront of the facade and fenestration industry over the last 40 plus years, and we've completed over 400 plus projects to date. And I take this opportunity to thank the building fraternity for all your support over the years. With the advent of urbanization and the scarcity of land, we at Aluplex are happy to share with all of you that we've completed over 10 towers, 250 meter high. In fact, at this moment, we are working the facade project of the Rustomji Crown.
So Rustomji Crown is one of the most premium projects in Mumbai. It's a super high-rise project. The most unique feature of this project is the facade. In the West, the high-rise facade systems have greater reliance on artificial ventilation and limited natural ventilation. It was Mr. Irani's idea to give a continuous facade which is openable to give that feeling of openness like a deck or an open terrace. This is something that has not been done in India.
This was made possible by innovation in design, engineering and construction, by incorporating large sliding doors without compromising on the high performance of the unitized glazing facade. This has never been done before and posed a unique challenge. This bespoke design facade system was tested in a performance testing laboratory rigorously.
The largest panel on site was 6.5 meters wide and 3 meters in height, and that was a logistical challenge. Aluplex organized the production, the dispatch, the unloading, the vertical movement, and subsequent installation to work all in sync to ensure there was a continuous flow of throughput. In case a bottleneck was identified, we ensured they were eliminated by adding additional resources of manpower and machinery to them. We had more than 350 labor working at various locations for the project.
I'm glad that we were able to finish this facade in a record-breaking time with the teamwork between the Rustomji team and the Aluplex team. We worked together to ensure that we were able to deliver a superlative product.
Thank you very much. That's the completed project, and need some better pictures of them now, but thank you very much, and that's my presentation. Thank you.
Welcome back, ladies and gentlemen, to the Zak World of Façades 2025 Hyderabad edition. I hope you all are fueled enough with caffeine as we move into the next session, which gets more technical. And to start this session, we have a very special speaker, someone who was born in France, brought up in Mauritius, and is now in Singapore. He's the director of DP Facades. He's going to take us through the changes in the facades with getting more complex geometries and the efficiencies in design. Please welcome Mr. Mathieu Meur, DP Facades.
Much. Good morning, everyone. A lot of speakers have been talking about sustainability this morning, and yet it's so cold in this hall. I think the mechanical engineer should be shot. Right, so I'll try to talk about a complex subject, but keeping it simple to understand. So I'll start talking about the tools of the trade. When we design complex facades, when we work on complex projects, complex geometries, we make use of a certain number of tools, certain things that make our designs efficient, our design team quick, do things right, do it the first time. And this is really the key when you work on very complicated projects. Some of the things that we do is we make use of a technique called iterative rapid engineering. I'm not sure that's an actual thing, that's how I call it. We make use of specific software that not so many people use, but they're extremely fast to model anything from a simple project to a very complex project and come up with results in a record time. And a bit later on, I'll be showing you 3 case studies of projects around the world where we make use of this tool along with some of the other tools. The idea is basically we start, if you follow the little flow chart up there, we start from the idea, the architectural vision. We prototype it extremely quickly in our engineering software, get the results, optimize the results, and then it gets built. If you look at the 2 images side by side, they look very similar, except it's been optimized by one more round of engineering in between. We reduced the beams in half in between, so visually even more appealing compared to the original design intent. Another thing that is quite unique, again, I don't know that many people use this, we certainly do, is a sort of desktop-based wind tunnel testing or wind tunnel modeling. And this allows us to model very complicated facades or facades that traditional wind tunnel tests will either not be able to model or will take months to model. We take a day and we will test like a wind tunnel 36 directions every 10 degrees or every 15 degrees, 24 directions. Certain facade features, for example, this project here in Singapore has a very elaborate grid of steel elements and cladding. A traditional wind tunnel test cannot model this because it's an open structure. It's not able to calculate the difference in pressures. With our software, we're able to do this, and we've actually compared on past projects with wind tunnel test versus this. The results are very, very similar, very comparable. The difference is wind tunnel test will take 3 to 4 months to do and cost $50,000. We can do this in a day. And we can do it today, tomorrow, the day after. We can change every time the design changes, we can just update it. And it links with our structural model, meaning we obtain the pressures, we can directly model the structure based on these pressures. So extremely quick. BIM, of course, inescapable nowadays. I won't insist too much on it, except to say that we tend to link it with parametric modeling. Typically what we do is we use Grasshopper and Rhino, and then we use Rhino within Revit to model families, put in all the parameters and all the properties of the different families. So we document the facade as we are engineering it and designing it all at once. Again, it's all about speed and efficiency and the quality of the outcome. we can't escape the traditional touch and feel. You know, we must touch and feel what we're doing. And for very specific items, we have a bunch of routers and 3D printers, and we can actually print components. I'll show you that in a second on one specific case study. One of the things that I'm quite happy with is something called real-time rendering, and I've nicknamed it iVMU. We all know what VMU is, virtual mockup, a visual mockup. This is an interactive visual mockup, something different. Using VR goggles, we can model a small sample of the facade, make real-time changes, make the fin longer, shorter, change the color, change the glass. Very realistic. You can move in, move out of the building. Again, a visual mockup could take months to do, cost tens of thousands of dollars, take time to update every time you want to change a feature and a color. You can do this first. It's part of our service. By the time you do the actual VMU, you're done. It's a one time normally. I exaggerate a little bit, but that tends to definitely speed things up and cost a lot less. And I invite you, if you have your phone up, you can actually scan it. You will see a version of that on your phone. But I warn you that compared to VR goggles, it's a lot less impressive. In goggles, it really looks lifelike, and you can navigate in and out and make those changes I mentioned before. But this one on your phone, even as you're moving your phone around, you can actually navigate the mock-up, and it will show you what I'm talking about. So as I mentioned, I will show you 3 case studies of complex facades or unusual facades that we've designed using either all or some of those tools. One is 6 Battery Road in Singapore. This is a building, it's an office building. It's about 48 stories tall, 200 odd meters, 250 meters. It was built in the early 80s. And coincidentally, in the early 2000s, I did one first round of recladding on that building. About 6 years ago, we embarked in a recladding again, a rejuvenation of the facade. And if you look at the podium, here, there, at the bottom, it looks very plain. It's very 1980s, solid stone granite cladding. And the architect had this vision. They wanted something angular, not quite freeform, but certainly very different in tone. And it needs to wrap on all sides. So that angular facade wraps on the roof and even inside of the building, which I'll show you some images in a short while. And this is what it looks like afterwards. The challenge in this project was this is an existing and live building. We can only support the facade at the roof and at the bottom. So you can imagine 5 stories of steel structure to support a facade, keeping that nice and light and elegant, quite challenging. We can only support it top, bottom, left, right, and 2 points in the middle of the roof. That's it. 6 support points. We managed to do this with relatively small pipes, around 200 diameter, and just rods or cables in between. Proper word is rods, even though everybody calls them cables. And we've made use of Rhino scripting to build the frit on each piece of glass one by one to hide and blend the structure so that from outside, the structure becomes invisible. And I think the outcome is actually quite interesting, because if you think of this facade that's like, probably 40 meters wide, 5 stories tall, only 6 points to support it, the structure manages to sort of disappear and blends in this overall picture that you have on the screen. Looking at a bit of a close-up, one of the challenges we had was all these angles. There's no 2 angles between 2 different sheets of glass that are the same. So how do we tackle that? We did a little experiment to try and make it as small as possible and as flexible as possible to tackle all the different possible angles between glass panes. And at the same time to keep it as unobtrusive and make it disappear. So we did this computer simulation, we did mock-ups, we did 3D prints of the brackets as well. And as I mentioned, we managed to keep the structure extremely small. extremely small. It's typically 200 by 200. The lighting is integrated. Yeah, as I say, we use 3D printers to model the brackets and to make sure that everything worked and nothing clashed, nothing, on computer it works, but does it work in reality? So it did. As I said, the facade needs to wrap under and over, but under the facade, inside the building, we had a big problem. We're limited by height. So this is actually a flat ceiling, although it doesn't look like it. And how we did it, I'll show you progressively getting closer and closer. We use this technique of not making holes, but making 3/4 holes on the panels and opening them up, like you would open a can of soda maybe, but at a certain angle, and each of them is parametrically controlled to give the impression that they are not flat, but they are really flat, trust me. And this is a close-up where you can see the little, 3/4 capsules, so to speak, that have been raised at different angles. And with the reflectivity of the panels, they appear like they're in different angles. That's the secret, that's the magic right there. Another project that I'm quite happy with, you're sort of getting a first preview. I don't think anyone has spoken about it yet. Some of you may know there's the World Expo in Japan. It will be opening in Osaka in a little bit over a month and a half. And we designed the Singapore pavilion for this. And Singapore is known as the little red dot, right? Red is the color of the flag, and it's a tiny country on the map. It's barely visible on the world map, so we're called the little red dot. So the whole idea is a bit of a playful word on that. And one of the things we started doing when this idea came up was to try and think what would work, what material would be able to do this, and how would we panelize that. So the first thing we did was to work out the panelization, again, using parametric modeling. And we decided to use GRP for those panels. Why GRP, glass fiber reinforced polymer, or glass fiber reinforced polyester, is because of its ease of molding, the ability to take on different shapes quite easily. But we still wanted to maximize the panels within the logistics limits and facilitate site installation and construction as much as possible. So we use parametric modeling to maximize repeatability and minimize the number of different panels. We then use scripting to add an additional layer on it, which is the facade is made of discs that are supported on those GRP panels. And so we needed to create a script with a certain randomization to make the panel supports and the panel locations, the little discs, which I'll show you in a short while, as uniform, but still appearing random as possible. So Grasshopper and Rhino were really key in this particular case. What you see on the screen, that script is just the very beginning. It grew massively from there. Why did it grow? Because the original script, which was what the architect wanted, was 40,000 disks, 5 different sizes. We went through multiple rounds of optimizations and visualizations, and we eventually reduced it down by more than half to 17,000. And yet, it still appears the same. That means when you look at it, it doesn't look to the lay person. I mean, if the architect zooms in and looks, they will probably know, but you and I and the general public won't know. There's no part of the shell behind, the GRP shell that's visible. We used our wind modeling software to model this. This was something that most of the codes, again, cannot tackle, this kind of spherical geometry. And also the presence of all these disks that now you're starting to see on the surface there, calculating the overall pressure on the structure, but also the individual pressure on disks. These are, 2 mm thick aluminum disks cantilevered from one tiny little peg. And this is Osaka, it's a typhoon country. Just like in India, we have cyclones, they have typhoons there. We had to make sure nothing flies off and beheads a visitor, So we did this modeling and the structural engineering that goes with it. And we also then adding the different sizes of discs. So we went with 3 sizes of discs, looking at the inclination, making sure no disc clashed. This was quite an interesting thing because you have 17,000 discs on a sphere. How do we make sure they don't clash with each other? So this is part of the scripting. Then we integrated the lighting inside that script. So the lighting design involved a bunch of LED dots running along behind the panels, behind the discs. So we added the wiring, the LED, all this is done within the script. So we created troughs to fit these light fittings, and we tested out, as you can see on the bottom right, try to see if there's any spilling effect, any light that sticks out. Then, you sort of build it, and you try to position discs around the pegs, so you sort of change the angle. The exact position of each disc on this peg was actually optimized to avoid light spilling and the people being able to see the discs, see the LED fittings. Did all the cutouts for doors, entrances, all the edge reinforcements. So this is, in some sense, we finish it, we pass it to the fabricator, they just mold it and fabricate it, install it. It's a big responsibility as a designer to go to that level of detail. But the vision is there, and we wanted to make it a reality. And that's how it was called in the end. The little red dot was called the Dream Sphere. 17,000 discs, as I mentioned. The sustainability was still a big part of it, so it's based on 70% recycled aluminum. The coating for the GRP was also looked into in terms of recyclability. The GRP itself, we tried to find locally a source for recycling it. All this is not obvious, but we did in the end, so this is as sustainable as we could make it. Part of our script, we also use 3 different kinds of colors and 3 different kinds of patterns that are built into the discs. And all this is blended along the sphere to make it look uniform from a distance, but very interesting up close. 3D printing, of course, making sure that everybody's happy, the client's happy. We can actually see the little discs and even the different sizes of discs. Trust me, there's really 17,000 even in the 3D print. And then we did a mock-up. So we started with a visual mock-up. Initially, there was supposed to be windows, but that disappeared along the way. So that's why the top one has holes. Little pegs, we tried holes, we tried different light fittings, different combinations of holes, mesh, colors, patterns on the glass. This took a while. What you see on the left was probably about, it was around a year ago, I would say. It's probably around February last year. We did a couple of full-scale mock-ups. So this is one panel, one full-size panel. And then it started construction. I'll go a little bit quicker on that one. And you can see the panels going up. So these panels, actually, these are test fits initially, but the whole thing, what we did is we actually pre-assembled the discs onto those modules. So this was just the initial test fit to make sure that our modeling was correct. But the discs were pre-fitted onto the shells in the factory, except the perimeter. Because if we put the perimeter, everything will clash and nothing will fit, right? So that's how it looks. Once you start installing the panels with the discs, you can see the bands that form the separation between the different elements. And these were just added later on. In fact, I think I've got no, I think I took it out, but they just had maybe less than 1,000 panels or 1,000 discs to install manually at the end. And this was built extremely quickly. Once the construction started going, it was built in a record time, really. Again, like a close-up view where you can see just the border between the different elements. And I think you can see boxes of the discs on the bottom. Those crates, those orange crates have the discs at the bottom. These are the only few pieces left to install manually using boom lift. And then some images towards the end, towards completion. Again, you can see the different textures, you can see the different colors, but they blend. And they make it look a lot more interesting visually. And I think the end result speaks for itself. You know, it's a very nice. It's a nice effort to be creative as an engineer, as a facade engineer, to be creative and really work hand in hand completely with the architectural team, which I think might be something our friend Christoph might be talking about later. But really where we can unleash some creativity and we can be completely part of the design and not just be on the receiving end. So we contribute extremely deeply on the design on these complex structures because the structural aspect, the buildability aspect, the material aspect, the logistics aspect, all these are so intimately linked to the design that you cannot separate the two. And this is what it looks like, finally finished. So this is very fresh. It's only a couple of weeks old. And again, if you look closely on this close-up, you can just see the texture on the disc for those who are maybe closer to the stage, and the different colors of panels that give this dream sphere its unique appearance. The third and last case study I will be talking about is the Dubai Mall Grand Drive expansion. This is a project that was announced by Amar, who is the owner of Dubai Mall, amongst other things, a couple of months back in Dubai. So the existing mall, built in 2009 or finished in 2009, I was part of the original engineering team that designed the facade for Dubai Mall. I led the team for that. And the owners decided to expand that and change it to look like this. So if you know what the Dubai Mall looks like now, you may not recognize what this is. For those who may know, on the right-hand side somewhere here, this is the Address Hotel. And so this is really the main facade of the building. This is the main elevation that everybody who's been to Dubai and Dubai Mall would know. And what they have in mind is something that's really unique, really stunning, that will really stay in people's mind for a long time. And so this wavy facade is made of stainless steel and aluminum. So the architect gave us a nice rendering, and so this is a tiny part of it. Just to let you know, there's 5 parts like this: 5 building joints, 5 movement joints, or 4 movement joints. So we have 5 different sections of the facade like this. The whole length is about 650 meters. The height is about 30 meters. And this was designed in 2 days, all 5 parts. I don't think anyone can match that without sounding too cocky about it. It's really quite unique, including the wind modeling, including the all sorts of effects that we have to account for, whether it's seismic, temperature, you know, all these are extremely important in that region. So, as I mentioned, it's made of different parts. You have corners, you have bridges that integrate. There's a curtain wall behind, completely new curtain wall, and we also have to integrate the new curtain wall with this new facade. So we absolutely minimize the penetration points. This facade is primarily supported at roof level. It's literally, I hate to use the word cantilevered, but there's hardly any other way of calling it. It's really supported at the top and at the bottom. So there's 30 meters between support points. In some cases, a lot more, because as you can see, they flow out. And we managed to do this with 200 diameter pipes. Again, pretty heavy scripting involved in detailing this. The facade has been modeled visually using Rhino, using combinations of 200 and 150 diameter stainless steel pipes, 100 mm diameter aluminum pipes, and 8 mm rods to tie everything together. So the scripting, this was the initial one, still quite basic. We pushed that a lot further along now, including all the transitions, all the terminations, and all the family definitions in BIM, in Revit, are all built into the scripting. for ease of modeling, because modeling something like this manually in Revit, you would spend a lifetime. It's just not feasible. So this is to show you the sort of one of the iterations. We've gone through quite a bit of iterations since then, but everything is built into this, including diameters, lengths, all the different families, the colors. Everything is actually built into the script. This is how it looks within Rhino. Again, this is just a small portion of it around the corner. Each of the entrances has these big sweeping lines that protrude 12 to 15 meters away from the facade. So they add tremendous length, and yet we managed to maintain the same diameter of 200 diameter pipes. Some of the close-up views as well, some of the entrances and how they integrate and how they sort of lift that veil around the entrances. This is a sort of front view of the grand entrance. What is hard to see is that bottom screen is actually on a different plane. It's what you see there is actually on a, oops, sorry, I think I pressed the wrong button. There you go. The bottom screen there is, that screen there is another screen, different script, different material, different design on a different plane. So this facade as a whole is really quite complex. And this is, you know, what it looks on the BIM model and what it looks in the official rendering. You can see it's actually pretty cool. It looks like it should not hold, it should not stand, but somehow I think it will. You know, we put everything we could in there to make sure it would. So I'm quite confident that it will build. Some of the real challenges for this project, other than the engineering and the detailing and all that, will be the logistics. Bringing this to life in real life will be quite complex. So we are going through a process right now of engaging the contractors, the builders, the steel fabricators, putting everyone together to make sure this happens. And initial indications are it should be doable. We'll know in a year and a bit. And just to conclude on these 3 case studies is I just wanted to sort of quickly remind you of the sort of different things we use to make these possible. Not just possible, but make them happen quick, efficiently, and as I said, we like to do it once and do it well. And the different things we use is iterative rapid engineering, where we can do multiple rounds of engineering on super complex structures in record time. Wind simulation to help optimize the pressures and quickly determine way before a wind tunnel test could be done what the pressures on the facades will be. Parametric modeling, inescapable nowadays, especially on complex geometries. BIM documentation, every project almost nowadays requires BIM documentation, LOD 300, 350 from our end. Rapid prototyping, using routers, using 3D printers to test fit, so to speak, small components, little elements that are meant to come together. When you deal with complex geometries, it's sometimes very difficult to visualize that on a computer or on a screen or even with VR goggles, but doing a real prototype is really helpful. And then, of course, that real-time rendering, what I call the interactive virtual mock-up, to help visualize early on with the owner, with the architect, what the building will look like, tweak things on the fly, immediately see the result, and then make sure everybody's happy before we do a physical mock-up with real materials. So I hope you found it interesting, and if you want to be in touch or ask questions, because we don't have access to questions today, you feel free to add me by scanning the QR code on the screen, and I look forward to discussing with you maybe at the break later.
Thank you, Mathieu, for that very interesting presentation. You did make the complex facade look very simple, and India is an evolving market, and I think we all will agree that India is moving on from the conventional box buildings to much complex facades. So I'm sure that some softwares and some systems that Mathieu has mentioned, we will be incorporating in our designs, in our way of working to improve and make our facades more efficient. Moving on, as India is moving on towards energy efficiency and sustainability, we do understand that there are certain challenges that we face in terms of designing decarbonization and also supply chain for the purchase of materials. So we have our next speaker, Mr. Harsharaj Shetty, who's the Deputy Head Engineering of Shuko, who will run us through these difficulties and how we can overcome them. Over to you, Harsh.
Yes. Hello, everyone. So, myself, Harsha. This is my first time I'm presenting with World of Façades. So, bear with me if I get stuck. So yes, we had a few of us talking about sustainability from our morning session as well as in the previous talks. So, yes, we all know sustainability is something that has to be adapted into our market, which is a global requirement based on the climatic changes and whatever environmental changes that we are going through on a daily basis. So today's presentation, I'll be taking you through how this sustainability can be considered into the design part, as well as how we can implement into actually putting it into projects. So to start off, just as an introduction, pretty much we are all aware that buildings are responsible for up to 40% of the energy and material requirements worldwide, of which majorly there is the embodied carbon and then there is the operational carbon that comes as part of this emissions. So to add to this, facades, which is the topic of interest here, takes up to 20% of the embodied carbon emissions in most of the buildings. Okay, so as I was saying, 20% of the embodied carbons are through our facade systems. To explain it further, to have a better understanding of how this is being contributed I would like to break down a certain facade panel into its individual components of how much every component is adding up to the embodied carbon in a certain facade panel. So when we go through this, as Shuko, as a building system supplier, and since we majorly deal with the aluminium part of almost every building system, we'd like to highlight that aluminium profiles comprise up to 37% of the embodied carbon. And this is where Shuko needs to act in making sure the carbon control towards every building that it is supporting and it is helping to build is being controlled in the most efficient manner. To explain it further, I would like to just go back to a very basic understanding of the entire whole life carbon chart that we have here. So as we know, these are all the gates that the carbon gets embodied into a building, from the initial gates of mining, conversion of into a aluminium alloy or conversion of a product, and then it goes on to the construction part where it has been fabricated, has been built into a system, and it gets into a building. And then there comes the operational part, which is majorly to run the building, which takes up pretty much most of the life cycle of this entire stage. It can go up to 40, 50 years. And then post its natural life of sustenance, then it goes into demolition, and then the actual part of recycling it back into the as raw materials. So this is basically the entire cradle to cradle understanding that we have. So many a times we are not approaching it in the entire holistic manner. So to understand how this can be approached, so that whatever we deliver to a building is supporting the entire C2C, cradle to cradle understanding, we'll further look into how Shuko can actually invest or actually improvise on the sustainability part for this, where we can clearly understand that the importance for operational, controlling operational carbon is always there. There is always an increased importance towards having materials which are low carbon, having better designs which can improvise the operational carbon requirement, and also through better construction methods. So in particular, I will be having 3 business case studies that are more related to how design and material is being playing a major factor in delivering the projects that we are doing. So to help with the explanation, how does Shuko improvise on the sustainability factor? So Shuko has something called carbon control, which is the entire ideology to minimize carbon dioxide in buildings and have better green buildings. So how do we go through it? So we have the carbon control toolbox, which is basically comprised of 4 parts. So there is design to decarb, build to decarb, operate to decarb, and recycle to decarb. So through these 4 components, the entire carbon control toolbox enables Shuko to help the customers, help the building developers, everyone to have a holistic approach towards building a sustainable structure. And just to add few more details into this, through design to decarb, we enable sustainability into the design of the building at a very, very early stage, so that the selection of the material, optimization of the material, and better operational load through the building is achieved at a very early stage. And when we move to build to decarb, through better construction and fabrication methods, initial ideas on how the carbon is being added into the building is also being studied before it goes into the construction. And through operate to decarb, through our global services and maintenance team, and the investment that goes into maintaining the building, everything is being introduced to the customer on how the building has to be maintained, how the building has to be serviced, to make sure it runs for its majority of the life cycle, and the recyclability is also maintained. And through recycle to decarb, through the help of IOF and the system data that Shuko already has of most of its buildings that it's working on, it is rather easier to control what can be recycled from a building which has been built for quite a while ago. And this as a whole, as a 4-part carbon control toolbox, enables Shuko to better improvise on every building that it offers in the coming years. So in today's presentation, I'll be concentrating on design to decarb, of which there are 3 particular cases which I would like to explain more, which would be U-value, air tightness, and material consumption. So this is the first case which I would like to present, is basically on the U-value. I think we had a good session in the morning about how heat is going to affect the operational load in a building and how it can be controlled, right? And also we had a very good session on how daylight has to be a very important aspect in the interior of the building also, and how it has to be taken care when you are developing or when you are designing the envelope of the building. So this is a particular case study for Adani Energy House, where the intent was to reduce operational carbon, reduce the space cooling demand, and increase the daylight without any hindrance through the envelope, and also reduce the overall thermal bridging. So this was the main intent of this project, and what usually is the industry standard of 2.1 for the U-value, we were able to achieve the best in class of 1.9 through majorly by 2 aspects, that is on the functional area design. So this comprises of 2 aspects. One is the geometry and the material selection. So when it comes to controlling the U-value, the majority of the exposed surface is what has to be controlled through the geometry. And with our existing portfolio and the number of options that we have on our unitized and stick systems, we were able to achieve a very good U value of 1.87, that along with integrated with the right material selection as well. So through less exposure and the right material selection, which enhances the U value performance of the system, this is one of the projects that we were able to achieve. This is because this, at the end of the day, helps in reducing the overall operational load that the building has to take up, and which is going to be for a certain period of time all through its life cycle. So yeah, so this is more of the calculation part, where we are trying to explain is, it is not only about reducing the exposed surface, even if there are complicated geometry, complicated design. With the help of our tools, with the help of U-value calculation expertise and tools that we have, we are able to control the U-value to as per the requirement and to increase the sustainability of the building. So coming to the second part of the design to decarb topics, that is the air tightness. So we all know that the building as an envelope is an interface between the inside and outside, and the air transfer between the outside and inside can create a significant effect on the internal conditions. It can be the temperature, it can be the wind that comes in. So this is one of the projects Fairfax Aeon Noida, which with the intent of reducing again the operational carbon and reducing the space cooling demand, because the outside air, which can be hot, which can be cool, should not influence the internal temperature of the building, which again creates a more demand to HVAC and cooling systems. And also to improve better acoustics. So the desired air tightness for this particular project was somewhere around less than 3 meter cube per hour meter square, which is usually much less than the industry standard. And again, through a better interface area design, which is again comprised of geometry and material, and the designs and the profile concepts that we have, and the multi-barrier systems that we are already having in our portfolios, we were able to achieve this best in class. So one thing that we'd like to really mention is, when there is classes that are mentioned, or when there is a requirement of air tightness put into the tender specification, usually there is just a pressure. There is 600 Pascal and 300 Pascal. So, but we also need to mention what class exactly are we looking at for the building at the end of the day. Because as we see here, if we are doing it for 600, there is a reference permeability for 9 meter cube per hour also, that comes under class 3, but there is also a class 4 which makes it even better, and almost 3 times better than what class 3 is, which can definitely improve the overall air tightness of the building, making it more efficient and adding to the overall reduction in the operational load. So this is just a few examples of how this air tightness can also be achieved in complicated designs. It can be corners of any angles, or multiple fins and multiple fin constructions, and so on. So the third part is, this would be basically how we can optimize on material consumptions in the buildings. So usually there is a setting that when there is optimization, it is majorly on economic, but that is not just the case. So reduction of material in the building system, majorly the aluminum part, will always reduce the embodied carbon that is going into the system. So, but that said, it is always a requisite that the wind loads or the performance parameters are always met. So this is one of the examples here in Hyderabad Navanami, where the wind load of 1.8 kilopascal was to be achieved, but this was possible with the best-in-class weightage of 7.5 kg. This is an added advantage to reducing the dead weight on the structure, with the same structural performance that was mentioned with the conventional panel. So again, the same idea of geometry and how the load sharing can be divided between the structural design is what being achieved. So to understand better on how the 25% reduction is possible, there is a lot of manual calculations that goes into it. There are multiple modular systems that allows us to find the right fit that goes into the particular performance requirements. So this is more of a conventional way of how we can use multiple nodes and calculate the exact profile design. Apart from this, Shuko has something called optics, which helps us, as a software, it helps us analyze the best possible design for a particular profile and give us the right amount of aluminum that should be required with the perfect original strength also. So when we run the profile through this particular software, this is what we usually end up, and there is always a 4% reduction with a better or almost equal performance requirement that the tender has specified for. So this is more about the material optimization. So in many cases, material optimization may not be possible because there is a certain wind load requirement which will not help them in reducing the material a lot. So what do we do then? So Shuko has come up with something called the Shuko minimal wall technology, which is a very innovative structural glazing method that has been introduced, which helps the panel, conventional panel, to act as one single entity with the profile and the glass as added. So this has been through a lot of engineering analysis, testing, and backup elemental analysis, which proves that by this particular technology we can reduce up to 36% of aluminium over a conventional panel, as it is shown here. So what we see here is a standard panel, which and when it undergoes the minimal wall technology, can go up to 40% of its reduction in its overall facade zone also. So this is how is this going to affect the sustainability? So Shuko minimal wall was a topic that was generated out of the requirement for sustainability. So Shuko minimal wall stands as a cornerstone in driving the decarbonization of building envelopes. There is a guaranteed reduction of up to 70% of kg CO2 equivalents in components, and there is a 16% reduction in embodied carbon also. This, when it is been combined with our low carbon and ultra low carbon aluminum alloys that Shuko has, can further reduce up to 35% of the embodied carbon in fully glazed units. This is a very unique proposition from Shuko, which enables tall and wide panels to be constructed without much aluminum usage, and at the same time it also is a very fabricator friendly, and we don't need a lot of technology that needs to be going into this. So with this, Shuko wants to make sure whatever has been developed for the European part is also applicable to most of the countries through this particular minimal wall concept. So just to summarize on what we have been through and how Shuko wants to influence sustainability into the design as well as into how it can be introduced into the construction phase. Shuko will support the architects and developers in influencing the shape of the design. It can be through the form factor, it can be through the reducing the size of the building, or reducing the calculating the right form factor that is required for this, and it can be through the width of the elements, it can be to the material selection that has to go into this, and also it also will come up with, the design team always comes up with the right solution and right system that will help you in achieving your reducing in your operational load, as well as optimizing materials through, as I already explained, through optimization of existing systems or through the minimal wall technology, which will reduce an overall embodied carbon into your building structure. So yes, so this was pretty much my presentation for today. So sorry. So let's leave it better. So that's the hashtag for Shuko Carbon Control. Thank you.
Thanks, Harsha. It seemed like your first presentation. Ladies and gentlemen, time to get back to the society. So what does an architect think when he's designing a facade? I think a facade is nothing but a reflection of the country it's being built in, the history, the culture, and the environment of the place. To understand this concept more deeper, we have our next keynote speaker, Mr. Christoph Timm, who's a principal architect from Skidmore, Owens and Merlin, who are the architects for none other than the Burj. And I'd like him to come on the stage and take us through his presentation. Over to you, Chris.
Thank you for your kind introduction. Ahmed and team at the Zak World of thank you very much for the invitation here. Good afternoon. My name is Christoph Timm, and I'm an architect at the office of Skidmore, Owings and Merrill. We are a collective of architects, structural engineers, planners, all building a better world. And the pictures that you can see here flipping on the screen shows you a few examples of the work that we've been doing since our founding in the 1930s in Chicago as a integrated design practice now operating globally. Mathieu made my case earlier, talking about the integration of structure, of architecture, of other disciplines. And I wanted to talk about this a little bit because this is my first time here in Hyderabad talking to you, and I want to introduce a little bit how we as SOM work and see ourselves when we deliver architecture. The best work that we believe we are doing is when we integrate the disciplines. And I wanted to show you 3 examples for integration, successful integration, and the outstanding results of this work together. The first one is the Willis Tower, now known as the Willis Tower. It used to be called the Sears Tower in Chicago. It was the tallest building in the world when it was constructed in the 1970s. And if you look at the massing on the right-hand side of this building, you can see that this is actually a series of setbacks that happen as the building rises. And these stacks kind of set back and make the architecture. But in reality, this is the structure that really drove this design. We call this a bundled tube approach. And it's not just one building, it's actually nine buildings, 9 stacks that all lean against each other, brace each other, and create this lateral system against the wind loads that a tall structure like this has. So you can see how the architecture and the structure works together, creating this, this outstanding project. We have another example here. A layman probably would say, well, this building looks like a bridge, and it is a bridge. This is the Broadgate project in London, and you can see that the structure only comes down at the perimeter of the building. And the reason for that is it spans over existing rail yards. So there wasn't an opportunity of bringing the columns down, so we had to pick up the columns with this arc-shaped structure that is expressed on the facade. So we are not hiding the structure, we are showcasing it fundamentally as architects. And the third example for successful collaboration between structure and architects here within our office is the Burj Khalifa. Everyone knows it. And if you look at the diagram here, what was originally tested in the wind tunnel, the initial scheme, is much lower than the actual building, how it ended up. And that's only because of wind tunnel testing. Keep in mind that this building is built on sand, so the foundation was extremely complicated. And so fine-tuning the building in the wind tunnel made it possible to bring it up, as you can see in the final scheme, how much higher it is, and controlling the base moment and acceleration significantly compared to the original scheme. But I'm here to talk about making of a place. And when I say that making of a place, I don't mean like an ordinary space or something that's not of interest really to our daily lives. I'm talking about something like structures or places where we remember having been, wanting to come back. We have memories about it. So our unusual places that we enjoyed being at. Maybe in this day and age with social media, you take a selfie and you send it to the world, kind of showing that you've been there. And SOM has been helping to make places in the last 25 years here in India, in this great country. And you can see we have been all over the country. And today I would like to talk about 4 places that we've worked on in the last 25 years. So it's kind of like looking back a little bit. What have we done? And not alone, of course, together with our teams, with our owners, with the craftspeople, with consultants. We've achieved I think some significant architecture. And the first project I want to talk about is the Kempegowda International Airport that was opened 2 years ago in Bengaluru. And together with the client, we developed the concept, and we named it a terminal in the garden. Of course, this reflecting the garden city of India, Bengaluru. And whenever we work on a new locale, we want to capture the spirit. We want to reflect what this place is all about. We want to capture the genius loci. We want to work with materials that reflect the culture, reflect the people, the crafts of the specific space. And on this building, we wanted to make the terminal building, we wanted to make it all about the experience of the traveler in the terminal. It was not about like the latest and greatest technology. It was about the technology serving this experience, making it a sensory, like interesting experience for the traveler as they go through as they navigate through the building, and they're always connected with nature. The lights coming down through a lot of skylights, and this building is not a gateway, it's a destination where people go hang out and enjoy. And on a building like this, there's a lot of decisions that need to be made. Sometimes like small things like the faucets in the washrooms, and believe it or not, people talk about this online, how they liked it or didn't like it. But these little decisions need to be taken careful. And the big decisions actually, like what's the layout of the terminal? And we are in a fortunate position that we have planners in-house that specifically work on like only airports, figuring out how to make them most efficient and work in the best way. So we explored a whole range of like different typologies, narrowed it down, and in the very end we ended up with the H typology that you see at the bottom. And the beauty of this scheme is it really, really reduces the walking distances. Sometimes, something that all people always complain about in airports nowadays, that you have to walk so much. So this scheme turned out to be the quickest from drop-off to the gates. It also has a very efficient rectilinear airside layout, how the gates are oriented, and it has great retail opportunities, something that's today also extremely important. We took the massing, kind of slightly exploded it, created a zone for greenery, for the continuous garden belt that we call it, and we were able then to create this terminal in the garden. It also lent itself to the phasing that's oftentimes in airport construction required because of commercial reasons. Passenger numbers increase over time, but usually owners don't want to commit to the entire building, so we had to phase it. And what's seen in red here right now is phase 1 of Terminal T2, and that's what's gotten built. And phase 2 is just now starting to be designed. But it's going to be very, very similar, so the building will look like one when everything is finished. But one of the challenges was to really make phase 1 look like a finished product when it was opening 2 years ago. And I think we achieved this. It's hardly noticeable that this is just one half of the project. So here you can see how it looks like. It's tremendous dimensions, as you can imagine, on a project of that magnitude, 418 meters long, 154 meters wide. The head house, and here the piers. The piers are very intelligently, I think, capable of serving different types of planes at different types in different times of the day. For example, it can serve 12 wide-body planes with 2 aisles for international travel. And it can also serve during the daytime domestic planes with single lane, with single aisles, but 20 planes. So it's very flexible. And so one of the concepts on this project is to do more with less. The garden area here is, of course, important for the concept, so you're always connected to greenery as you navigate through the terminal. Architecture kind of takes a back row seat here, and it's all about vegetation biophilia. On the outside, we used a lot of native plants because they can deal best with the climate. And of course, these plants had to be grown, so nurseries were constructed early on during the design process, very long time before actually those plants being planted. And some of the plants were already hundreds of years old when they were harvested and replanted at the site. And they have a life expectancy of another 4,000 years, we were told. So really big planning went into this vegetation, this biophilia scheme in this airport. On the inside, the use of the plants that were used were more Mediterranean because of the temperature. It's much, much cooler, the inside temperature. And so it's kind of it had to be a compromise. We couldn't use the indigenous plants because of the climatic conditions on the inside. We also designed these hanging bells with greenery and the veils. These 2 structures were custom designed specifically for this project to create this atmosphere of richness and vegetation also hanging from the ceiling. Simulation only goes to a certain degree, so this irrigation system had to be tested, so a lot of mock-ups went into creating these bells, and eventually they are beautifully hanging there, and they're not plastic, they're real greenery, real plants that are hanging up on the roof. I'll go back. In this picture, I wanted to show that the roof is perforated with a lot of skylights, so we get a lot of daylight in. Of course, for sustainability reasons, the airport is pretty much run without electricity during the daytime in terms of electric lighting, so we use daylight to the largest degree possible. But of course, this daylight has to be controlled, especially for the plants, so we simulated how much light would hit the plants, and the plants were designed so that they would be in the areas appropriate for the light levels that they need. And of course also for people, that there's no glare and things like this, so people feel very comfortable in this space. The use of material was reduced as much as possible. We tried to not clad things, not paint things, but really expose beauty of materials, whether it's the brick, domestic brick, or the bamboo or stones. We try to minimize the use of materials to the largest degree possible. And of course, when we use materials, we do visual mock-ups, and here you can see one structural bay that was built with showing the brick at the entry vestibules, the bamboo covering the structural grid here, and then slightly to the right at the end, you see also the beginning of a mock-up for the facade. So everything is always tested as much as possible for visual, but also how it's being constructed. We went back to traditional wind tunnel testing to establish the cladding loads, which were very, very low, only at 1 kPa. And on the left, you see the phase 1 model, and on the right, phase 2. So we tested both schemes, both rendered pretty much the same low pressures. A few words about the facade, that of course is heavily depending on the head house cantilevering roof that's self-shading. So this way we were able to have a very, very transparent glazing with hardly any opaque areas, low iron glass, and it is built in a unitized aluminum curtain wall system 3 meters wide. We used the system all over the building, but then adjusted for opaque areas, we're adding metal, but it's always the same chassis of the unitized curtain wall that was used. Here a view from the inside, and you can see on the right a section at the top and a plan on the bottom here. You can see how in areas where we have large spans, we support the unitized curtain wall with a steel backup. And the steel backup in this case is a custom box beam with added flanges with niches that you can see filled in with the bamboo, kind of also giving it this feeling of like a harmonious interaction between the metal and the bamboo, similar to what we have also at the superstructure columns here, where we have the columns being clad in bamboo. A lot of attention went into the detailing of attaching the aluminum curtain wall to the steel backup. We tried to make it as minimal as possible with these components that you can see on the right, and you can see how clean it is, really, this component that still has the tolerances needed to adjust between the steel and the aluminum. For the piers, we have a much more closed facade. That's due because we don't have the overhangs, the self-shading overhangs. So this is where we have the added aluminum opaque areas that we oriented with a shingle system to create some sort of interest throughout the day, that the shading of these shingles changes, the black lines you can see change throughout the day. Very simple, but it's the same system again, 3 meters wide, glass, nice, big, expansive, 3 meters tall, so when you look out, there's not a feeling of being boxed in. You really, really feel like very connected to the vegetation. And so when we finish a project, of course, it's very interesting to kind of looking back how you got there. Like in this slide, I just wanted to show some of these beautiful original design sketches from the beginning of the project, where we wanted to show like the ideas of like making this a green humanistic terminal, and then how we ended up here. Very, very similar, I would say. Another shot here that illustrates the initial idea of like connecting people to daylight, to vegetation, right when they land on the plane. And this is actually what you see when you land on a plane and you after deboarding the plane. Going back 10 years, we worked on the Mumbai airport terminal T2, and we incorporated, even back then already, a lot of similar ideas that we used for the Bengaluru airport. And I wanted to walk you through this a little bit. Super constrained condition here in the heart of Mumbai. We have the domestic terminal T1 here on the left. We have the existing international terminal T2, and this aerial shot is from 2009, while T2, the new T2 was already on construction. And we came up with a layout for this terminal with an X-shaped, and this was based upon like all pinch points, constraints that we had. We had to have the airport running 24/7. We had to have, of course, the airport access to the runway. We had to respect some of the dwellers in the vicinity there. We had the river that was constraining us, and other like storage facilities for kerosene, the taxi lanes. So a lot of constraints led us to have this X-shape terminal layout. And we've learned that you don't have a design unless you have a way of implementing it. And so I wanted to show you what it took to implement this design change in this fast. So you can see the various phases, how it was kept operating 24/7. And this is basically a satellite shot how it looks like today. You see it's not yet like 100% built, and that remains on like passenger traveler numbers, how they develop. But in the future, it could also add a little bit of piers, as you can see here. And this is how it looks when you approach it at night. For an international flight, usually at night, you go here and you see it like this. And the base concept of this is very, very much similar to the Taj Mahal. You have a pedestal at the bottom, and then you have a pavilion rising on top of this pedestal. Same thing here. We put a lot of the infrastructure and the concourses at the lower level as a pedestal, and then this head house, the pavilion rising on top of that. Very transparent glazing you can see at the pavilion. Oh. You can see through the building, and the building grid is 34 meters by 64 meters, so tremendous spans. And the columns that you have altogether, 28 columns that this head house ceiling is resting on, have a diameter of 2.7 meters, including rain leaders in the middle, like big pipes bringing all the rainwater down. Tremendous dimensions, of course. Some of these columns span 40 meters up in concrete, cast in place, and then are topped by a steel head truss system that you can see here, all built out of very, very standard steel profiles, allowing the light to come through, as you can see here on the finished clad column. You can see the skylights above and how the light can filter through these openings in these coffered GFR gypsum clad panels here on the inside. On the exterior, we have glass fiber reinforced cement panels. So they look the same, but they're different materials. And this is, of course, all based on inspiration that we found in India. The structure here, you can see the post and the beams and the capital here, very similar in a different material, of course, than the pattern making. And then, of course, the inspiration for the coffered ceiling, the national bird of India, the peacock. And this is how it looks close up, parametrically designed, of course. We had about 270 different panels per each column, altogether over 8,000, I think, for the entire roof. This was, of course, all, again, marked up. We studied every aspect of it. For example, here you can see what was not executed in the very end, like a golden inserted joint here. We didn't go with that way, with that design in the very end, but we tested it. And this is how it presents itself. Oh, this is how it presented itself right before opening in 2014. And in the back, you can see this beautiful, very, very minimal cable wall that I want to talk about next. But first, this place, I think a very memorable place, the drop-off here. I think if you've been there, you will never forget this place. It's pretty special. And again, you can see on the right side the cable net wall for maximum transparency. It has tremendous dimensions, again, 326 meters long without any expansion joints at the drop-off. And then it also has additionally 504 meters in length. And in total, it's over 800 meters of cable wall, so tremendous dimensions. It's a very standard system at the time. We have a double laminated glass, DGU, the clip here that holds the glass to the cable, and then a stainless steel cable as only a vertical cable, so it's not a horizontal cable at all, only vertical. Cable net walls need movement, so the deflection is plus minus 30 centimeters here, illustrated in yellow for a span of 15 meters. And cable net walls, of course, look so minimal, but a lot of people always forget that there's a lot of structure that go into cable net walls out of sight. So at the bottom, there's huge concrete structure and also a truss up at the top to get this minimal look in this vision zone of 15 meters. Coming to the vestibule, this system gets interrupted because the vestibule is 4 meters tall, so all of a sudden the span of the cables is completely different, so the deflection is completely different. So we had to deal with this, and the way we dealt with this to avoid excessive glass panel warpage was adjusting the cable net tensioning, the cable thickness, and making it tighter or more tensioned at the perimeter of the vestibules. Of course, nobody will ever see this. All the engineering that went into this to making this such a simple design. Why is this of importance? Of course, you have to avoid glass breakage because of excessive warpage, and you have to also, since it's an IGU, you have to make sure that the primary and secondary seal stay intact and the IGU doesn't fog up over time because of warpage. Another detail that we used to make this, to achieve this safe construction was to change ever so slightly the typical attachment clip at the bottom here. That's the typical one. But at the vestibules, it has a little pin included, so it's a pin connection, allowing for more like flexibility of the glass, avoiding excessive stresses in the glass that could lead to failure. So this was my second project that I wanted to showcase here. Now we're making a big jump to a commercial office building in Mumbai. It's a much smaller project, of course, 19 stories high, Godrej BKC. It's about 110,000 square meters. It's a refined, very simple curtain wall that you can see, a unitized curtain wall with a super grid and with a lot of horizontal shading, of course, against excessive solar heat gains. We try to keep the glass as transparent as possible, floor-to-ceiling glazing. This is not like revolutionary design, but our idea was to really deliver a simple facade that is beautifully executed, well crafted, and holding up to the elements, and visually like pleasing. On the lower floor, we have a semi-unitized system. Again, very, very simple, standard, but using it I think in a very aesthetically simple and reduced aesthetic. Beautiful local domestic stone. We always try to do this, use domestic products to reduce the carbon, embodied carbon due to shipments. We don't want to ship halfway around the world. Integrated design, similar things here. We try to hide like the unfortunate need for like these metal detectors, and therefore we built this vestibule here to kind of like make this a special zone that can be like treated slightly different as a need for devices like this change, so they're not so apparent and it's kind of like hidden away. The lobby extremely minimal, all white, and focuses on the artwork here on the right-hand side behind the desk. And we believe that this project is also a place because where people go. Because, for example, it's very successful, fully leased, and a lot of real estate people actually have their offices in the place. And so we think it's quite successful. To get this, we are always very interested in like participating in performance mock-up testing for the facade that you can see here, or also being present in the shops or on site, making sure that our design is really implemented on site. And the last project I want to talk about is, again, in Mumbai. We finished it in 2022. We call it the Carmichael Road project. It's a residential tower. You can see at the top, just to orient yourself, we have the Mumbai T2 airport at the top, and then at the bottom, gateway to India. And then this is where the project is, in Kumbala Hill. Beautiful area, of course, with fantastic views of the Arabian Sea. That you can see here, situated in a garden-like area with a lot of vegetation, lush vegetation, and the typical buildings, pavilion buildings, that don't make it past the vegetation zone of this area. And so, yeah, beautiful vegetation here, the detailing, even of simple walls, beautiful. And we were asked to have make a complete scale change here by introducing this tower into the mix here. You can see in the background also other tall buildings here, kind of slightly illustrated. But this is the volume that we were asked to work with. And of course, you can see how the vegetation is interrupted at our site here. It just stops here as a detail. And of course, this as an architect was like not very pleasing. And so we tried to counter this by creating the lower 4-5 floors, and drape it into an all of greenery vegetation, and then only above we have 14 floors of residential apartments, usually 2 per floor. We have at the top also this beautiful infinity edge pool. And this is what I talked about earlier, I tried to talk about earlier, is the first 4 or 5 floors are fully covered with greenery, kind of blending into this vegetation zone that you have typically on the right, and then using a lot of wood here on the first floor, screening the lobby space and the entry area. This is how we achieved it. Very, very simple construction. Again, we have a planter moat here, I would call it, at the perimeter of the building. Stainless steel cables that plants can use to climb up, and then the cars are all hidden from view, and we create that, basically a green wall at the bottom of the building. We're using very, very classic Indian principles, the charger here that protects you from the elements, from the sun, reduces glare, and also, of course, protects you from excessive rain-driven wind. So very, very simple construction. And of course, then we have these operable panels here that allow you to modulate the light. These screens are in front of balconies in certain areas, in front of loggias, and in front of the bedrooms as well. And you can see how relatively simply they can be adjusted. Just have a look at this lady here, moving them to the side, just as you please. Of course, they reduce the solar heat gain, change the privacy. You can get more privacy, less privacy, and reduce the glare however you please to arrange them. And of course, it adds interest to the building, having this pattern that's always ever changing. Character-defining items like this, we always mock up again, even simple stuff like this out of foam core in the office, not even worrying about the materiality, just to get a sense for scale, and so we mock this up. Here's what I talked about, loggias. We have a very simple glazing system, sliding wall system on the typical residential floors. You can see it's two apartments per floor. And this is the system that we use to enclose the building. Just a simple sliding wall system here. On the outside, on the inside here, the left side is the inside of the building, and the right side is the outside. And then these movable sliders on the right side here. Very simple construction, but we are always interested in going to the shop, making sure that the craftsmanship is really there. And in this case here, I took some pictures of the IGU and how it was fitted out with some framing, and then ultimately was put into this track here. A view up is showing the underside of the chargers, beautifully clad with wood. And again, an image kind of looking back at the design that we set out to do, like showing like what a tight, constrained space we had here on the left, and then how it looks when you arrive nowadays. So I think we gave back the place, this greenery, this vegetation zone that I talked about at a palm tree level or tree level, and we fully, it looks like it's flowing through again, and I think we succeeded here, making this again a place that people will remember or enjoy coming home. And with this, I would like to end my talk and say that we've been here in India for 25 years. We're really enjoying working with the people here, with the traditions that we have here, and we hope that we have a few more projects to do in the next 25 years. And with that, I would like to end my talk, and thank you for the attention.
Thank you, Chris, for this very insightful presentation. I think we have more clarity and understanding that when an architect specifies a particular stone, a particular color, a particular glass, what is the actual intent behind it? He's just trying to bring the personality of the building into life. Thank you so much for that. I'd like to add here that when we enter the Bangalore airport, it's not just entering any airport in India. The second you enter, you realize you've entered the Bangalore airport. I think that's very remarkable in the design, and thank you, Chris, for that. Moving on, our next session, it's a panel discussion on the topic is influence of digital tools and modeling for designing facades. And for this, I request Mr. Narsim, who's the chairman of the Indian Institute of Architects, Telangana chapter, to please come on the stage. He'll be taking over as the moderator for this panel discussion.
Good afternoon. So I would like to request our panelists, Architect George Varghese, Director RSP Design Consultants, to come to the stage, please. Architect Ratna Kompella, Head of Design, Aparna Constructions, please come onto the stage. Architect Kanaka Rao, please, he is from Sanjog Architects. And Mr. Sapan Gupta, General Manager, Head and Master Planning and Design, GMR. Please come to the stage. So, wonderful talks we have been watching till now. Excellent presentations and their experiences. Just thought I'll ask you to give a two lines about yourself, sir. Mr. George Varghese, when did you finish? In the sense, how many years you are in architecture field and what's your experience?
Okay, my name is George. I'm the director of RSP Design Consultants. I've been in the profession, well, almost 27, 28 years.
28 years?
Yeah, yeah.
With RSP?
With RSP, about 21 years.
21 years. In Hyderabad?
In Hyderabad, yes.
Mr. Architect Kanaka Rao.
Hi. Hi, everyone. I'm Architect Kanaka. I've been with 22 years experience, worked at national and international firms, and presently practicing in Samyog Design Studio in Hyderabad.
Architect Ratna.
Hi, everybody. Same as Kanaka. He and I are classmates.
Okay.
So, 22 years of experience and currently working as head of design and planning for Aparna Constructions.
Okay. Yes.
My name is Sapan Gupta. I am working with GMR Group, heading master planning and design, and designing airport and doing master planning. Christoph has already spoken about a lot about airports, so maybe I'll also pitch in and
How many years you said, sir?
15 years.
15 years with GMR.
No, I am with GMR. It's been 6 years.
Okay.
Yeah, I've been working with some consultancy firms, and providing consultancies to the clients like GMR.
You're also an architect?
I'm an architect and urban planner.
Okay, myself, I'm a professor and architect and landscape architect, practicing for the last 34 years in Hyderabad, worked abroad in Middle East, and I have little experience on various aspects that have projects that are being discussed about. Today, we're all talking about facade design. Well, we had an era before this digitalization has happened. And just to, as an appetizer, I thought I'll just say a few words and then I will ask each one of you about, various questions and that we have in our mind. So the modern 3D visualization enables architects to present detailed, immersive facade designs, helping clients understand spatial and material aspects before construction begins. Like tools like BIM, Rhino, simulation software enhance precision, optimize performance and streamline facade design. Then digital tools are transforming facade design in India, particularly in urban centers. However, cost, training and accessibility remains barriers for smaller firms. I think the technology is growing, but the smaller firms are yet to pick up. This is my major concern, and I think only 5 to 10% of the firms, maybe world over or in India, are able to use all these technologies, and they are very expensive. So, you need to have such clientele and such projects. Most of the firms are yet to upgrade. I think time will solve the problem, but I feel there's a lot of other problems like corruption and various aspects which are not letting smaller firms become more, equipped. So anyway, so finally the next frontier in facade design lies in AI-driven modeling, dynamic facades, and life cycle management through digital twins and so on and so forth. So now I would like to ask you, Mr. George Varghese, what was it like for architects prior to the digitization age?
So prior to the digital, the time when we got a lot of these digital tools to work with, things were much less efficient as compared to today, and the whole process was very cumbersome. There was lack of precision in the work that could be done, and collaboration was very difficult.
But still we did.
We still did it, but when you compare it with today, for example, just precision, it's 100x better. We worked within those constraints.
The scale of projects probably were smaller and lesser, so we were able to manage.
True.
With those days.
True. So the issue was it took much more time because everything was manually drafted.
There was time also at that time. Now nobody has time.
And if there were changes, you had to do the entire process again. As against today, you don't have to repeat the entire process. Visualization. In those days, we didn't have these wonderful tools. It was physical models. Those also took time.
I remember a lot of people used to come up with perspectives, beautifully watercolors.
Yes.
Rendered.
Yes.
So those were the days I think
Absolutely.
you and me have seen.
Absolutely. We worked with manual calculators.
And we stood all the day and drafted things, and corrections were difficult.
Exactly. So, that's also a point. It was very labor intensive, both for architects, for the draftsmen. Everything had to be hand-drawn. And that was something which was particular to that time.
Yes.
Yeah.
So, Mr. Khanna.
Yeah.
How did architects in the pre-digitalization age cater to clients and ensure design clarity?
Yeah, pre-digital era was a period where everything happens with human touch, lot of artists involvement without much of software's availability. So there, like Sir said, it is more of precision, making of life-size prototyping and keeping things and making sign-offs, seeing physical model. Now, after digitalization, it is more of a virtual clarification, sign-off, lot of options. There are not of much options available. So it is to be very tedious, very skillful people involvement, time-taking sometimes. That was
We had study models.
Basically, it has to be a study model to see the proportions, scale, and the material applicability or the joining details. Everything used to be physically and prototyping. Most of the prototyping used to happen.
So, Madam, how did client aspirations change with the advent of digital tools?
One is wanting multiple options, wanting to see...
Wanting more.
Wanting more, wanting to see a lot more options, wanting to see a lot more materials. Globalization also has changed the perspective of clients in terms of what they aspire for their own buildings. And that is something that has been also a pain point because thanks to the digitalization, a lot of them would say something like, I've seen this in Paris, I want that, or things like that. So yeah, there is an upside and there's a downside to this. But yes, a lot more options, a lot more materials that they would want. Yes, there is that the client's perspective on design also has become a key ingredient in the whole design.
So they have hyper aspirations.
Yes, they do. Absolutely.
My friend, do you feel digital tools simplify design, and how?
Yeah, absolutely. I mean, digital tools, definitely they simplify the design. In fact, if you see the visualization and the conceptualization of the complex structures are quite possible with the tools that we have now. And at various, I would say at various fields, we can use them, like architects and designers, like facade designers also. Can use a different set of tool, but when it goes to fabrication or site implementation, there are different tools. So from it's like a relay from one set to another set, and how it is getting transformed to actual a building or a structure. It's something which is quite easy now. So it's quite possible now these days, working on the complex structure and realizing and kind of analyzing their attributes further. So it's there are tools, I mean, to name like Grasshopper or Rhino. These are the tools that are used by designers, and at the same time when it goes to the fabrication, there are Tekla and Bentley, these kind of software which they use it for the fabrication and the implementation. So, yes.
Do you think these tools not only simplify design, but also there is a possibility that the core concept or losing the design intent, is that possible?
It basically, because see, design obviously it comes from your own imagination or your inspiration, but ultimately when you are putting it to some sort of a modeling or some sort of a actual onto the ground, onto the drawing, probably there will be some aspects which are not realistic, or it is quite complicated to, or maybe complicated is not the right word, but probably not possible based on the environment or any other aspect. So maybe that intent may be missing because of those factors, but I don't see, if you are having some intent originally, it is quite easy to transform. Easy as in it's quite possible to transform these days.
Okay, I'll just randomly ask you people. Kanaka,
yeah.
Is 3D printing extensively used for architectural applications, or do we still rely on physical study models?
Yeah, there is a cost factor to that. Everybody can't afford 3D printing machines as of now. Maybe like the mobiles in initial era, how it was little expensive. Now everybody has that. Soon, I wish AEC professionals will use 3D printing as required, as demanding. But physical models are very much prevailing now. A lot of professionals still demands, a lot of projects still demands the physical model because it is easily accessible, visible, and they can relate it to the context, and they can make it. Moreover, even AR VR is enabling a lot of virtual movement into the spaces. 3D printing will still, it has its time to come still, but most of the projects it is advised. As architects, we still advise and we are making it. For minor or a little bit of mid-range of projects, it is possible.
In fact, I would like to add to this particular question. So these days we are working on a hybrid mode, especially in India. Even though it is quite easier for us to kind of 3D print any complex structure, maybe for a modeling purpose, but for an easy structure, we go for a a regular CNC cut, or maybe just make the model the way it is being done traditionally. But for any complex structure, let's say I'm coming from a master planning background, so if at all something very complex roof or maybe a stadium structure needs to be put, probably I will try to 3D print it and then put it to the model. So modeling is one application, but then I think where you are coming from is the in the human size structure to be 3D printed fully and then utilize it for living or functional purposes. Yes, that is still we are kind of evolving.
3D printing in that sense, like prototyping or doing the scale model of certain complex items or elements in the facade or some of the elements in the within the building, it was too tedious and we required for sure skilled people there. With 3D printing, it can be done dead easy. It is dead easy for that. We can sign off the things with clients whom they cannot visualize or take it for granted. So this model will help us. These models will help. With olden days, we used to do sketches and try to elaborate them. But this 3D printing will definitely help in that sense.
Madam, how do Revit, SolidWorks or similar software play a role in architectural design? Is it extensively used in all offices?
I do not think it has been extensively used in all offices. One, because a lot of them, coordination that happens for the entire project with multiple consultants doesn't happen in Revit. So I do not think a lot of them, they would want to, they are looking at, even the clients and even the the owners are insisting on Revit models now. A lot of them are, but there is still, a lack of that coordination that I see, which needs to be, that gap has to be still filled. So it is a good software that can be used where, coordination becomes a lot more easier in terms of all the other engineering aspects that come into the buildings, be it structure coordination, be it facade coordination, be it MEP coordination, especially MEP. So yes, it's a good software that needs to be incorporated in every form.
You're aware of the term LOD, so all this
level of
boils
development,
down to
correct.
LOD.
Correct, 350, 400.
Yeah,
See, that's what I'm saying. Coming to a point where we are working on BIM models to an extent of generating GFCs, generating BOQs, generating as-built drawings, coordination with the shop drawings. All of that is, far more error-free, I should say, when we are working on Revit models, when we're working in BIM. It's far more easier to evaluate what is the errors that, are being generated, and all the coordination issues can be foreseen upfront and then taken up. So yes, using a Revit model is a good idea, and I am for, taking it up. And I think all the firms also. But then we lack the basic coordination. That's not happening because not all firms take up, architecture firms only take up architecture work. MEP firms take up only MEP work, and coordination of syncing all of that together is a pain point still.
Yes. Sir, do you foresee any challenges in adopting digital modeling tools? If so, how?
The primary challenge is cost, because these softwares are pretty expensive. That's number one. Number two is there's always a kind of a cultural issue within firms of there's a resistance to change, because most of these new technologies you have to relearn. It's not so easy to transition from basic CAD to these technologies, so that aspect is there. There is also particularly in India, the lack of trained manpower. Even if the software was available and even if all the stakeholders had all the tools, do we have the people to work on those tools? So that's also one challenge. And going forward, when everything will be, using these tools in the coming years, Of course, there would be the issue, because most of this would be in the cloud, and there would be aspects of security, cyber security, and that is something which would be a challenge. It's not that it can't be surmounted, but that would be a challenge in the future of adopting or transitioning to these digital.
Do you think this introduction of some of these technologies in our education system, do you think it is now high time to introduce learning of these softwares in the syllabus of our architecture or engineering? So because a lot of youngsters are now, we have heard mechanical engineering is no more there. It has become mechatronics. Now civil is, no takers for civil. I mean, a lot of seats are going vacant in the universities. Similarly, architecture also is having the toll now. Not many youngsters are wanting to join, and now they want to make it 4 years with our new NEP. So 4-year course it is going to be made. But do you think these things have to be brought into syllabus? What is your take, sir?
Absolutely, it has to be brought into the syllabus, and that's what training is required. The students have to be trained into these technologies, plus they should be given the opportunity for internships and things like that to make them industry ready. I'm sorry to say, both in my time as well as now, the graduates which come out, they're not industry ready. So yes, academic institutions have a great, very serious role to be able to impart this training, this knowledge to students, so that they can easily transition into the profession.
I was just thinking, if it is made 4-year course instead of 5 years, the 1 year letting the students work internship, like MBBS, once one studies, and after that 1 year they have to work in hospital on the bodies. So similarly, architects 4 years later, they should work in an office for 1 year, and then they get their degrees. Similarly, engineering also probably 1 semester, 6 months, it could be a pure training for them also on these technologies. I think the syllabus and educational methods also have to slowly change, because a lot of youngsters are running towards now machine learning, AI, and data science, and so on and so forth. So all the pure courses are all falling short of students. So probably just bringing some of those subjects into our subjects will probably help and make again revival.
I'd like to add to that. I come from a very conventional thought process. So for me, I feel that the exposure to all these softwares and all these technology kind of makes us lazy. We don't tend to innovate. We don't tend to think. Because it's become very mechanical for us to work on a software and develop. So I feel that the initial stages of the education still should hold on to the actual root of how the conventional process of design has to be done. With the paper, with the pencil, with the thought process, with a lot of discussions and things like that, with a lot of scale models, sit down, work on it. And then probably during the second half of your education, where the technology can be introduced, where the children are learning the technology and incorporating the design into how they can improvise on it. So that is something that I feel, because that I'm very conventional thought process.
Even I agree with you. I always say the pencil is everything. Yeah. Pencil is very important. Okay. Because pencil and sketching has to go continuously, and that's how human brains, as designers, we sharpen our skills and not just sitting on the laptops and keep working on technologies.
In fact, I've been associated with a few architectural institutes for the past 5 years very closely. I've been associated with one of the institute for full time also in between after COVID. I was forced to get into that. So what I observed is COA is very keen on, for certain period they have to do manual drafting, understanding the touch of the pencil to the paper and how the brain thinks. That's the stimulation happens and ideas generate. That's the proven fact. So after certain period, second semester, third semester, there is introduction of certain softwares. In our days it was CAD. Now it is much of various softwares, and lot of softwares are student friendly. They are giving without charging them for certain period. So lot of students have acquired those skills in much early stages and they are doing the academic works. So it is helping them that way. And whoever is equating those, they are easy to work in the actual practices. Whoever is taking it easy, they are facing it different. It is already there. But it depends on, see, usually like what Architect Ratna said is factual. We will be forced with a lot of assignments, not only one topic. There will be acoustic, there will be climatology, there is design studio and these softwares. So it is very tight for them to get into this. But whoever is getting the basics and practicing really in the practical period, practical, internships and all, they are getting it easily. There are a lot of insistence happening. COA gives the academic regulation also depends on the institution. Institution should come up with a lot of inputs, infrastructure development and awareness of the software's availability. Only once they are coming out of college, they are able to get in hands-on experience. Offices practice is different and the academics are totally, there is no connection in between.
One last question to you, Sapan. Do facade consultants and contractors work on the same software? Could you give us some insight?
So, I mean, the answer is no. I mean, they don't work on the same software because the visualization and the conceptualization is one aspect. The another aspect is actually getting it realized. So, probably there could be a file format which will be supporting both the applications, which can be imported to the other one. But I believe, like in my earlier answers also, I've mentioned about Grasshoppers and Rhino. These two are the software used by the designers and architects, and they are working on those, tools, and then taking it to a form where a contractor can pick it from there. And contractor is working on Tekla and Bentley and these kind of softwares to kind of make it, getting into a realization mode. So they don't work, but yes, there has to be some sort of integration between both the applications, both set of applications, and of course there are fields. So that's there.
It's like design and engineering.
Yeah.
Okay, thank you. So we have covered a broad spectrum of insights today. While digitization presents immense opportunities, it also comes with challenges. The key takeaway is that architects must embrace technology while preserving creativity and design integrity. Thank you all for the engaging discussion.
Thank you.
Thank you. Thank you.
Thank you all the panelists for giving us your thoughts and insights. We'll break for lunch. I'm sure everyone is hungry. Welcome back, everyone. Hope you all are full with the superb lunch. Moving ahead, we have Mr. Nandakumar, who's the director at Evamark Facades. They are consultants and PMCs for builders and corporates all over the country. And they specialize working with hospitals and the hotel industry and also the IT industry. Mr. Nandakumar is going to take us through the structural and thermal comfort in facades. Over to you, sir.
Thank you, Vishesh. Good afternoon, everyone. So I think after lunch, it's a little bit of a more technical topic which I'm going to talk about. I hope I will keep everyone awake during my session. So thank you for inviting me as a speaker. So today I'm going to talk about structural and thermal comfort in facades. So we are basically facade consultants based in Bangalore, and we are doing projects across India, mostly commercial buildings. So as a consultant, a facade consultant, So I believe that these are the 4 important knowledge areas every facade engineer has to possess. And one is the architectural knowledge. Of course, architects give us the concepts. So we work with the architects to make it more like a little bit of engineering from engineering point of view. Then structural thermal designs. So every project where the facade is involved, structurally and thermally it should be designed properly to get the maximum comfort and maximum safety. Then the mechanical part where we do the fabrication of the facades in the factories and the materials which are done in big factories. Then the civil, of course, finally the final product is installed at the sites. So we have to coordinate with the civil engineers, and we should have all these 4 knowledges to become a successful facade engineer or a facade consultant. So today I'll be talking more about structural and thermal design. So that's my topic today. So the first part will be on the structural design. So structural design, so we have to first identify what are the loads acting on the facades. So the major 3 loads which are coming on the facade. Facade, as you know, is not by itself, it's not a load-bearing element, except in very few cases. But otherwise, it is subjected to external loads and its self-weight. So one of the major load is the wind load, which is exerted on the facade, because facade is the first element which receives the wind, and then it transfers to the main structure. Then the dead load. Dead load is basically the self-weight of the facade itself. And the live loads. Live loads are the exerted loads by various elements such as human beings or some other materials. And apart from this, there are other loads as well, which based on the projects we will have to consider. That is one of the most important one is the seismic loads. Then in cold countries or the cold regions, we have to also consider the snow loads. And other loads such as the building maintenance loads and some other additional materials if you are using. So those kind of other loads based on the projects. So we will have to consider that. So we will go one by one. The first one is the wind load. So since it is, my topic is structural thing on the facade, so I will have to go into a little deep about each load. So one is the first one is the wind load. So wind loads are basically calculated as per the IS 875 part 3. So that is the code. The latest one which we are referring is IS 875 2015. So the first is so when we design a project, so we need to know what is the wind speed acting in that region. So we have basically 6 wind speed zones classified in the code, starting from the basic 33 meter per second, it goes up to 55 meter per second. Apart from that, apart from the basic wind speeds, we will have to also look at the various factors. One is the risk coefficient, which we call as the K1 factor. So I'll get into a little bit detail about the different coefficients. Then K2 factor, which is the terrain height and the height factor. So as you go up, the wind load increases. Then topography factor, so the surrounding regions, if there is a hill or any cliff or some other, any other element, so that will affect the wind load coming onto the structure. And K4 factor, which is introduced in the latest code, this is the cyclone affected area, so they have introduced the K4 factor. So you will have to multiply the basic wind speed with all these factors. Then after that, you will have to, with the help of a formula, you calculate the wind load. Basically, that is that you will get it in kilopascal. So if you are looking at the K1 factor, so that is called as a risk coefficient. So we have various type of buildings, so right from the temporary structures to the normal buildings to some of the important structures. So we have various structures, and this, so the factor, the K1 factor for all general buildings is taken as 1. And for other types, in the code, it is given as different coefficients for that. Then K2 factor is basically the height factor. So we will have to categorize the building, class A, class B, and class C, and we will have to, based on the terrain, so we will have to choose the coefficient. So we will have to say, for example, if it's a 50-meter high building, so the basic wind load is up to 10 meters. So beyond that, we will have to take it from this table, and we will have to multiply it for deriving the wind loads. K3 factor, as I told earlier, it is basically if there is a cliff or any other elements nearby the building. So we will have to consider that, and we will have to take how the wind load affects on the building. And K4 factor is the cyclonic areas. So this is like an importance factor which we will have to consider. So these factors are added to the basic wind speed and arrived at the wind load. So apart from that, we should also have the knowledge of how the wind load acts on the building. So one is deriving the wind load based on these factors, and next is the wind load acting on the building. So wind load act in a different ways. One is the uplift force on the building, shear load and lateral load. So you will have to consider this, how it acts, and we will have to take into account the coefficient. So normally when there is two tall buildings and if there is a narrow space, it creates a wind tunnel effect. So those kind of things you can do it with the help of a test or with the help of calculations you can arrive at, or simulations you can arrive at, and those things has to be added. So as a thumb rule, we normally take about whatever wind load we get, about 25% extra for the corners, so that it creates a positive and a negative wind effect. When the wind hits on the facade and it moves away from the building, it creates a pulling effect. So those things also we have to consider in the wind loads. Then coming to the dead loads. So dead load is basically the self-weight of the structure. So self-weight is normally you calculate the volume into density. That's how you get the weight of the structure. So volume you can calculate as per the measurements, length, width and height. And density for each materials, I have just listed 3 materials. So if you are using any special type of claddings or tiles or some other materials, so those densities you can multiply with the volume, so you get the dead load. So those dead loads are to be, so first basically you will have to identify all these loads. So dead load is one of the important things. Then live loads, of course you will have to take the live loads. For example, somebody walking on your canopy for cleaning the canopies, or the building maintenance guy using the structure. So he exerts pressure on the structure, the facade structure. And sometimes there may be some elements kept, like some furnitures are kept on your glass or some facade elements. So those are live loads. So that has to be taken into account. So for designing the facade. So these are some of the examples. Sometimes signages are also there. So apart from that, so we will also have to look into the seismic loads. So this is a seismic map of India. So most of the big cities lies in zone 2 and zone 3 areas. So we will have to consider that, and those loads also has to be taken into account for designing the structure. So after you identify the loads, then you will have to design each elements to withstand those loads. So one is like you will have to identify what is the maximum load the material can take and what is the actual load which you are getting. So major load bearing elements in the facade is the aluminum, glass, so the brackets, anchor bolts, casting channels, fasteners, openable windows, the accessories and structural sealant. So these are the major load bearing elements in a facade. So you will have to design each material which, so whatever loads you have calculated, these material has to take those loads. So for example, aluminum, it has you will have to design it for the stress which is exerted on the aluminum, the buckling loads and also the deflection. So the stress is you have how much stress the aluminum can take, you have that value. So actual stress what is exerted because of these loads, you will have to take it with the help of calculation by using STAD or FEM analysis, and you will have to compare that. So the load should be lesser than the allowable loads. So that's how you calculate the different loads, and finally come to a value that, okay, come to a conclusion that this particular element is safe in all these different types of loads. So on glass, this is normally the code which is referred, ASTM E1300, and glass is, you can give the stress level of the glass from as less as 3-second stress till nowadays the code talks about even up to 1 year, the stress exerted on the glass. So that you can take it from the code, and then you can calculate the deflection. So deflection is normally, there are various formulas in different codes. So normally it should not exceed 20 mm as a basic thumb rule. But as the glass sizes gets bigger, we have a coefficient to that. So that has to be added to that. Then other elements such as anchor bolts. So this is one of the most critical elements because all the loads are transferred to the brackets and to the structure with the help of the brackets and the anchors. So anchors, you will have to decide what type of anchors you need. Like some areas, the concrete, based on the concrete strength, also it depends. So cracked concrete anchors, uncracked concrete anchors. Sometimes you may have to go for chemical anchors where the loads are very high. So those type of, based on the loads, you will have to select a particular type of anchor. And the anchor stresses and all those things, you can get it from the anchor supplies technical data sheet, and also you can calculate it based on the material properties. And one of the important thing in the anchor is the embedment depth. So most of the projects, what we see is that the calculation is okay, but due to the site condition, the embedment depth is not met. So when these situations arises, so that particular load which is designed, intended to take the load, the anchor may not take and it may fail. So some of the failures I have just listed for the reference. So we have these kind of failures in the concrete. So the major one what we see is the concrete cone failure and the concrete edge failure. So edge failure is when you don't have enough edge distance from the edge of the concrete to your anchor. So this is very important so that there is no edge failure in the concrete, in the structure. And also concrete cone failure is when the concrete itself has not developed the full strength. So for example, sometime due to the schedule, pressure and all that, you do the concrete today and tomorrow itself they will start putting the anchors in the site. So that concrete strength or whatever that 15 days or 21 days, whatever required to attain the full strength is not achieved. So that time you will experience these kind of failures in the concrete, and apart from that, the other things are all anchor itself failing because of a poor design. So the second part I am just going through the thermal, so for the thermal comfort, what are the basic things you will have to keep in mind while you design a facade. So basically, like similar to the structural map, the wind speed map, we have a thermal map also. So this is given in the code called ECBC, which is Energy Conservation Building Code, given by the Government of India, Ministry of Power. So they have developed this. So it's there in existence for many years, like 20-25 years. Normally the MEP engineers are using this to determine their the HVAC loads. So if we consider this, so we have 5 different zones for the climatic conditions. So right from the cold conditions where you can see the blue ones, and then the temperate conditions, so especially if you see a Bangalore as a city, you have a temperate climate. So it is more or less same climate throughout the year. And Hyderabad is a composite climate where the winters are cold, so summer is hot. So this is, if you take Delhi is also a composite climate, and cities like Mumbai, Chennai and Kolkata are all in warm and humid climate. So it is closer to the seashores. So our facade has to be designed based on this, the environmental conditions, the climatic conditions of those areas. So I've listed some of the important cities, so we can refer this code for this. So basically 3 factors determine the design of the facade for thermal comfort. The first factor is the U value. So U value is basically the heat transfer from outside to inside or inside to outside. So in cold climatic conditions, it's normally from inside to outside. So whatever the heat retained inside, it goes through the facade outside. In hot condition, it's from outside to inside. So the U value plays an important role in this. So it's basically calculated as the temperature difference. You have to take the temperature difference into the U value. So for example, the outside temperature is say 40 degrees. Inside is you need 22 degrees or 23 degrees. The difference is 18 degrees Celsius. So 18 into your U value will give you the total heat gain into the building. So for that particular value, the HVAC the design has to be done. Otherwise, your thermal comfort is lost. So this is about the U value. So U value is more critical in cold climate because your heat loss, if it happens, so your heating load has to be increased. So in the cold climates, the U value plays a major role. Then the solar factor or solar heat gain coefficient, this is the second major important element which has to be considered in the thermal comfort design. So the solar factor is basically the total, the radiations, what you have outside because of the solar which directly comes into your building through the glass or through the facade elements. So this can be a short term or long term. Sometimes the facade will attract the heat, it will slowly dissipate the heat into the building. So both put together, the sum of that, you will have to take the heat gain into the building, and these two factors will play an important role in your HVAC design. So for example, you have a outside radiation of say 750 watts per meter square as an example. So it depends from climate to climate. So I'm just giving an example, and it is an average across India if you take from the codes. So your SHGC value is say 0.3 in a glass or in a facade element. So 0.3 into your 750. So much heat gain is happening into the building. But if you see as a cold climatic condition, so the heat gain will work as an advantage because your heat gain is coming into the building, so your heating losses are reduced. So SHGC has to be increased in the cold climates and it has to be decreased in the other climatic zones. And India being a tropical zone and most of the high-rise buildings or the facades elements are in this, other than the cold region, so it is very important to select a the lower SHGC glasses. So basically, we have some standards in ECBC which is given. So ECBC is mandatory for Griha ratings. So the solar factor, so the one way of reducing the solar factor is providing the shading devices. So you can do a simulation with the help of IES or a design builder softwares, and you can identify that which area, what direction that solar panels, solar is hitting the facade. So those areas you can provide some shading so that that impact is reduced. So normally in an Indian climatic condition, especially in the southern part of India, your northern elevation receives almost zero sunlight. The other three elevations has to be basically designed for the proper shading devices and other things. Like most importantly, the southern and western and southwestern areas. So when you are designing that, so you will reduce the solar radiation into the building, and you can also keep your, like for example, your staircase areas or the core areas in those areas, the southern and southwestern region, so that your overall the cooling requirement you can reduce. The loads on the cooling equipments can be reduced. So this is the overall thumb rule. Then so for the basic, so we have this ECBC code which talks about all these parameters, and there are a lot of examples and checklists are also there in that. So when you're designing building, you can take those checklists, you can mark that, okay, these things I can do, these things I can avoid, and when you can when you're designing a facade, you can, like the concept itself, you can align with this so that your HVAC loads are coming down and your thermal comforts can be increased. And ECBC has become mandatory for the Griha rating. So without meeting those requirements, so these are some of the requirements, minimum requirement which has to met for your rating. So one is your window to wall ratio has to be lesser than 40%. So window means basically your vision panels which are directly getting your daylight and the solar radiation. So, and the wall is all the other elements, including your spandrel panels. So those are considered as wall. So window to wall ratio should be less than 40%. So that is mandatory for the GRIA rating. And minimum allowable light is 0.27, that is 27%. So that your day lighting requirements, the artificial lighting things are coming down. And you are utilizing the maximum day lighting benefits. So these are some of the basic things. And coming to there is a table, if you see, table 4.10 if you see in ECBC, 2017 code. So this is the minimum and maximum requirement, like U value for all the 5 climatic conditions, you will have to maintain a U value of 3 watt per meter square Kelvin. So this is not, so normally we get confused with the U value of the glass. But it's not only about the glass, you have to simulate for the entire facade, including your frames, or you have your spandrel panels, or your tile cladding, clay tiles, or ACP, or whatever it is. So all that put together, so your overall average U value should be less than 3 watt per meter square Kelvin for the facades. And that is for the solar factor, as I already told, the northern elevation normally receives lesser sunlight for our climatic conditions. So you can have a SHGCO of up to 0.5. And all the other elevations, you have to limit it to 0.27, except for cold areas where you need more solar for reducing your heat loads. So these are some of the basic things. So you will have to keep in mind while designing the facade for structural and thermal comfort. So I have just addressed the basic things. So once you get into the more details, you will find a lot of challenges, and you can use different softwares for getting into more accurate values. You can do a sun path analysis for exact the solar radiation where you can it hits the facade, and you can arrive at the you can size the building in a way where you get the maximum benefit, especially in the thermal comfort. So thank you very much.
Thank you, Nanda sir. We truly understand and appreciate the efforts and the calculations that you all as consultants need to put in while designing the facade. Moving on, our next speaker, Ms. Swati Puchalapalli. She's the founder director for Terra Vidis Consultants. They specialize in sustainability and energy efficiency. And over the past 25 years, they've been giving guidance to various corporates such as Infosys, Microsoft, TCS, Amazon, to name a few. Today, she's going to speak to us regarding the impact of facade design on energy efficiency, comfort, and wellness. Ms. Swati.
Thank you, everyone. And thank you, Nandakumar. That was a very great introduction to the thermal properties of facades and how they impact and the various codes. I'm going to take a notch up. I'll actually be a little more technical as well, like Mr. Nandakumar has been. Sorry about that, but that's my job too. So here I go. I'm going to talk about the facade and the various features of facade that we should be looking at when we design for sustainability. So when we talk about facade, one of the biggest questions or one of the biggest concerns we always have is that what has been designed for is never what we see in operation. A high-performance facade that is designed as a high-performance facade never really works as a high-performance facade. And why is that? There are several reasons for that. And in our experience, one of the primary reasons is because we look at facade only from an energy perspective or from a daylight perspective. But facade is connected to everything here. It's connected to energy, carbon, believe it or not, water as well, health, circular economy, user comfort, resilience primarily, climate resilience. So everything is interconnected. And when we start looking at a facade design as a combination of all these elements from the perspective of all these elements is when your facade, which is designed for high performance, will work as high performance facade. And why is that? And why is it important? You all know, right? After the foundations and the structure, the facade is one element that gets changed the least in the life cycle of a building. So it is extremely important. It's an extremely important element. I'm sure all of you agree on that. And it is also very true, and these are based actually on medical journals more than sustainability journals, that the impact of facade and the impact of a building on people's well-being is quite large. For example, thermal comfort that Mr. Nandakumar spoke about improves productivity or performance by 6%, right? And biophilia and views out, specifically views out and having a connect to the outdoors improves performance by 15% in offices, whereas in academic buildings, it improves performance by as much as 25%. Short-term memory improves by 25%, focus improves by 22%. And this comes from creating that impact, in creating that unhindered view out for people who are staying there. And of course, you know about the other ones too, daylighting, lighting, and noise, acoustics. So all these play a large part in how a building functions and how the performance of a building is used. So let's think out of the box. Let's think beyond what just the thermal properties or the daylight properties of a facade is, and look at also future-proofing our buildings. Issues that we face now in terms of, let's say, pollution, in terms of water management or energy are going to change. Hopefully pollution will reduce, but the issue with water and energy are going to increase tremendously over the next few years. And we are seeing that more and more with extreme climate events happening more and more often. So how do we approach design? So let's look at this. Usually when we assess the performance of a facade, we look at heating energy, cooling energy, from a peak cooling load, from annual cooling energy demand, and maybe envelope heat gain factor, which is required, which is a metric that is used more and more nowadays. We also look at it from a daylight and a visual comfort perspective, which is glare, right? And just like Mr. Nandakumar said, he just explained what each one of those is. You know, the U value, the SGC of glass, the VLT of glass, I think he ran through everything. So these are the performance indices that, okay, do I see this? These are the performance indices that we usually, when we look at 2-3 options of facades, these are the ones that we most usually look at. However, this is not going to give us the performance. This will give us a performance on paper, but for that performance to be converted to performance in reality, we also need to look at these. We need to look at what we called operative temperature or the felt temperature in a space. We need to look at what is the difference between the temperature near the facade to inner side of the room. What is the difference in that temperature? And how does that impact comfort? We need to look at, that's called thermal distribution. We need to look at internal surface temperatures of the facades. And why is that important? Because like if we have, all of us have experienced radiators in winter, especially in Delhi or any of the cold climates. If the internal surface temperature is very high, then that starts acting like a radiator in summer. And that radiant heat increases thermal discomfort more than anything else, which cannot be cut down by any kind of air conditioning system as well, right? Unless the air conditioning system is specifically designed to cool down the surface temperature, which it's usually not, and which it shouldn't be doing. Apart from that, daylight distribution. Daylight distribution is important in terms of uniformity ratio from one part of the room to another part of the room. If a room, let's say this size of the room or the depth of the floor plate for that matter, is we have a very, very deep floor plate, and at one end of the room is quite dark, the other end of the room is quite bright. What will happen is people who enter the room will see the difference between the two spaces and would want the darker part of the room to be lit to the same level. And that's psychology. That's how you would think that then a room is brightly lit. And all of us, if you think about it, all of us experience the same. It might be the case that the darker part of the room might have sufficient daylight, but still we perceive it as something that is not enough. So we would start turning on artificial lights again. So distribution of daylight is equally important. And then finally, we talk about views out. I just showed you the metric about creating that unobstructed views out. Several medical journals say that that unobstructed views out without a blind in between improves performance, improves focus rates, improves memory, right? So how many hours of blind-free daylight on views out are you able to provide? So these, if you extend the facade assessment indices to this, I think it will go a long way in bridging that gap. And so let's look at each one of these. Okay. So comfort. When we look at comfort, let me start with comfort. There are many kinds of comfort. There is thermal comfort, there is visual comfort, there is auditory comfort. If it is too noisy, you wouldn't want it. So there is auditory comfort, which of course you need to take care of. And olfactory comfort. The smells also are part of the whole comfort equation. That is for internal spaces. Now, if you look at air quality or designing for health, the ones that have, there are a lot of things in a building that impact the health and wellness of its occupants. But the 4 ones that I have highlighted in red are the ones that are specifically related to facades, which is maintaining a connection with the outdoor, visual as well as physical. This is part of, the biophilic design principles. This is an important one. Interaction with vegetation. Not internal vegetation, but actually external vegetation. Again, creating a view out and trying to bring the vegetation part of it indoors to the extent possible. Access to daylight and access to naturally ventilated spaces. So some of the spaces in the building, if they can be designed as naturally ventilated, a quick access to naturally ventilated spaces goes a long way in improving the wellness and health of its occupants. Climate resilience, we all think about it, we all talk about it, but what is it exactly? It's about designing to look at extreme temperatures, extreme heat waves, extreme cold waves. Is the facade being your first line of defense for comfort? Is it able to, with the existing systems, might be a naturally ventilated system, or might be an air-conditioned system, or might be a mixed-mode conditioned building. Is the facade able to control, manage the extreme heat waves and the extreme cold waves? Is the facade able to take high-intensity rains without leakages? Is it able to look at gale force winds, and is it able to control wind-driven rain? So wind-driven rain, lot of naturally ventilated, especially when we talk about apartments. Windows are open. We would like to keep the windows open, especially as you go higher, because it brings in the fresh air, right? Especially during monsoons. But the wind-driven rain, if it starts coming into our living spaces, your facade needs to act as the first line of defense, trying to stop it to the extent possible, right? So wind-driven rain is a major aspect in looking at resilience and making buildings more, to look at facades performing better. So how do we go about designing? Some examples. This was for a hospital that we did in Chandigarh. So one of the first things, this was a hospital where we spoke about, ensuring views out. So whom are we ensuring views out for? Is it for people entering into the patient rooms? Of course, people in lobbies and transition spaces are different, they're transitioning. But people who are lying down on a bed, in a IPD, what is the view out, and how do we manage efficient view out for people like that? So if you look at inpatient beds, how do you place the openings? We don't want the whole window, whole facade to be open. But how do we create or position the opening such that people who are lying down on the bed, who actually need a view out to be able to get better quickly, get the view out? So positioning the windows correctly based on, your line of sights and how much one can tilt their heads would be quite an important aspect. Similarly, in a larger room, this was another room. What you see here is, in several hospitals, I don't know, I hope most of you haven't been to an inpatient ward, but if you have, you will see that the attendant bed is always next to the window. And that attendant is always uncomfortable because they're so warm, because it is right next to a glazing and they're very uncomfortable, very hot. So if you can move them around, what will happen? The patient will get a view out and discomfort of the attendant can be alleviated. So some small adjustments to the way the room can be done and where you position the windows goes a long way. And then once you start looking at performance of the facade, Mr. Nandakumar just showed about shading devices and how they can help. If you look at various options of shading devices, with and without the shading devices, there are several things that you can compare the performance of a facade. So, of course, daylight, what we call the usable daylight, 100 to 2000 lux, how does it get distributed in a room? Glare, the one without daylight creates a 13.7 or 14% glare for the space, whereas the one with the different types of shading devices manages to bring it down. And along with that, the number of hours of blind-free view. How many hours can the patient actually keep their blinds up and have the view out? Don't you think that is important? Especially for someone who is in a hospital ward, it is probably one of the most important aspects for them to get better. So the number of hours of blind-free view becomes an important aspect. That is from a visual comfort and a daylight perspective. And then we have from a thermal comfort perspective. What you see here on the top are what we call thermal maps. Just like daylight maps, we can do thermal maps where it maps out the felt temperature or the operative temperature across a space. And it can show which facade is creating more heat compared to the other facades. Right? So as you improve, these are some of the things that you can use to make design decisions, to help convince people of going for better facades that perform well. Along with that, internal surface temperatures. With shading devices, the internal surface temperatures can reduce by 3 to 6 degrees, depending on the time of the day. And of course, there was another solar canopy which also managed that. Different types of shading devices. And then if you see the surface temperature itself goes up by as much as 6 degrees. The graphs that you see here, the orange line is without the shading device, and the yellow and the blue lines are the ones with shading devices. And you can see that during a day, the temperature difference between on the surface, interior surface of a space, varies by as much as 6 degrees across the day, depending on which orientation you are on. So this is some things, and another example of the same of how you can put across all the various parameters that actually relate to the performance of a facade in one page to explain which option is better than that. So instead of looking at it only from a cooling load perspective, if you look at comfort, performance, wellness, and health perspective, you get a more complete picture than otherwise. Now, of course, it will cost a little more, and it will also have a fairly large impact. So what you see here is the impact of the amount of, in this particular case, we did a lot of study on the amount of energy savings that are possible, and what would be the annual energy savings, and how does it reduce, and it also has an impact on the chiller size, because the amount of cooling required in a space like that will go down. So there is a capex saving. There is an increase in cost of the facade. In this particular case was about 2.5 crores. But there is also a reduction in the sizing of the system, which has a capex saving of 2 crores, right? And there is an annual saving as well. So together, the ROI, depending on what you're looking at, would be a maximum of 2 years. So these are some things that we can look at numbers and various performance metrics that can help in creating our, pushing a higher performance facade forward. Now, resilience, how do you design or analyze for wind-driven rain? So there are a lot of calculation methodologies to look at what would be the depth of a raindrop penetration based on the wind speed and the size of the raindrop. So these are some graphs that we have developed, and we can see that based on the number of hours of rains during the rainy season, the wind speeds and the frequency of the wind speeds, we can to a certain extent analyze and say that the depth of penetration of wind-driven rain can vary from this much to this much. And these go a long way in deciding what kind of control elements need to be put on facades. So this is again designing for resilience. Now, why is that important? Because we are having more and more wind-driven rain nowadays, and it's only going to increase. The other part, the last thing that I would like to talk about would be to look at a facade not just from a U value perspective, but also from a thermal mass perspective. So we might, that will be, when you talk about U value, yes, you do get a good, very good reduction in the amount of cooling loads. However, when we speak about thermal mass, so when we look at thermal mass, in this particular case, this is 3 types of wall. All 3 of them are the same U value. This is a naturally ventilated space, by the way. And you can see that what you see, the red line, is the line which tells you what the internal temperature of the space is. Same U value, but the internal temperature of the space varies purely because of thermal mass. The variation in thermal mass from a lightweight structure to something which has a lot more mass in it. So there is something called thermal lag, which, and specific capacity of the material itself, which one should consider. So that also goes, this again, why am I showing? Because again, this becomes very important when we look at extreme cold times, cold waves and extreme heat waves. Because the first line of defense again is your facade, and looking at these aspects, looking beyond U value, will help in controlling that. So I'll end up with this. Look at the extended, please don't look at just daylight and energy, or daylight or the amount of heat gains that come into a facade when you're looking at the facade performance. Look at other matrices that also look at health and well-being and comfort of its occupants. And please don't forget that the interrelationship between all these elements is as important to the facade as it is to any campus or any site. Thank you very much.
Thank you, Swati. As India takes steps towards sustainability and energy efficiency, we are privileged to have consultants like Swati who have so much in-depth knowledge on this subject, and I'm sure she'll be more than happy to answer certain questions when we have the networking break. Thank you, Swati, once again. Moving on, we have the next speaker. There's someone who add in their own way colors to the facades. It's Mr. Deepak Parameswaran. He's the specifications manager for Jotun powder coating, and he's going to run us through the durability, the aesthetics, and the sustainability, and the types of powder coating with Jotun. Over to you, Deepak.
A very good afternoon to all. Thank you for the introduction, and it's a privilege to be amongst you all here. When we talk about, when any architectural landscape is being designed, we think how can we ensure that it is built for generations. In fact, how can we ever build for generations or for years together? This durability, aesthetics, and sustainability need to be at the core of the design thought. Jotun, through its paints and coating solutions, would like to throw some products which, or throw some ideas here which can really help in the entire aspect of beautifying and protecting your projects for years to come. Having said that, we have been in this business of paints and coatings for the last about a century, and more importantly, we have been protecting these various projects across the globe for about since 1926. We had a very humble beginning where we started off with protecting ice-going vessels to the southern oceans from Norway in 1926. Then we have really now grown to an area where we are protecting a wide range of assets from industries and architectural infrastructure. As I mentioned, we started off with marine coatings and then have gradually moved on to other protective coatings, have developed world-class solutions for protective coatings, decorative paints, and powder coatings. We are today 10,000 dedicated employees operating in more than 100 countries, 40 factories, and 7 dedicated innovation hubs delivering the latest in the coating world. Trusted by leading architects, developers, and consultants, we have been providing world-class solutions to to the best of the projects across the globe. Just to give an information, out of the top 20 skyscrapers that are dotting the globe, we have provided our coating solutions to about 14 of them. So how do we build for generations with architectural powder coatings? So build for generations can be based on 4 basic platforms, parameters. One is make the project long-lasting, sustainable, beautiful, and last but not the least, safe and reliable. We will be covering these aspects one by one. So first, let us start with looking at durable finishes and making it long-lasting. So Jotun powder coatings, as a part of the powder portfolio, we have 3 main products which we provide on the facades. One is Jotun Facade, which offers 15 years of guarantee. Jotun Super Durable, which offers 25 years guarantee. And Jotun Durasol, which offers 30 years of guarantee. Delving more into details, the durability of aluminium portfolio is basically classified into 3 broad specifications, which is AMA 2603, AMA 2604, and AMA 2605. AMA 2603 compliant is Jotun Facade, AMA 2604 compliant is Jotun Super Durable, and last but not the least, the best in the class, AMA 2605 compliant is Jotun Durasol. Sorry, 2604 is Jotun Super Durable, and AMA 2604 compliant is Jotun Durasol. Fire specifications or fire classification is gaining some significance in the recent past. It will be good to note that Super Durable and Durasol is classified as A2 and A1 in fire classification, and A1 being the best. We will be taking you through some case studies highlighting the protection that these products basically offer. So I don't think so anybody needs an introduction to this landmark right in the middle of the sea on an artificial island. This is Burj Al Arab, and we have provided our Jotun Super Durable AMA 2604 compliant products. This has been coated and this has been standing since 1998. This has been standing since 1998 in the harshest of the climates, and at the beginning of the project we always retain a master sample, and the master sample, when you compare with the door profile which is standing on the site even today, you can see it has stood the test of time. Another project is not really working, I'm sorry. Another project, Atlantis Hotel, Palm Jumeirah. This has been standing since 2007. It uses a green shade in the project, which is RAL 6033. If we delve into the details, we basically, when we measure the performance of the coating is measured on the gloss levels, the color difference over the period of the guarantee years, and also the film integrity. So you can see from the figures, it has stood the test of the time on all 3 parameters, which includes gloss, color retention, and the film integrity. Now we'll come to a better product, better than Super Durable, in the sense that which provides ultimate beauty, ultimate durability, and the most sustainable in the entire range of products. So when we talk about Jotun Durasol, we generally tend to compare it with liquid PVDF systems. So as like liquid PVDF systems, Jotun Durasol is an AMA 2605 compliant product. It's a fluoropolymer resin. It uses a fluoropolymer resin like a PVDF system. Where it is better, it is that it is basically a single coat system, 50 to 70 microns compared to PVDF, which is about 35 to 45 microns, depending upon whether it is a 2-coat or a 3-coat system. Low VOC, by virtue of being a powder coating, it is a low VOC. It has less than 2% VOC content, so a highly sustainable product. It is also faster and efficient in application. As there is no solvent, even the application process is faster and also sustainable. And last but not the least, 30 years of exterior guarantees, which we offer for this particular product as compared to 20-25 years for the other systems, for the competing systems. When we talk about guarantees, what does it mainly cover? The guarantees mainly covers these 3 aspects: the color retention, the gloss retention, and the film integrity. But how do we ensure that the guarantee is offered on the site, on the ground? For that, we have a specific program which we, in order to identify the best of the approved applicators. There are many applicators in the market, but how do we identify the best out of them? So for that, we have an approved applicator program that we run, in which we identify the best of the applicators, we audit their systems, we basically check whether they have a lab, a storage capacity, and the reside process, the Convener system. And most importantly, we also ensure that their line samples are taken and tested for long-term testings. Once the long-term testing is done and is completed, that is when we offer the approved applicator certificate to the customer, to the applicator. Today, globally, we have 88 Jotun approved applicators for Durasol, including 7 in India, and 182 applicators for Super Durable, including 26 in India. Another aspect which I would like to introduce is the coatings on architectural steel. So there are coatings available on architectural steel as well. So depending upon the environment, whether it is a highly corrosive environment or based on the classifications that we have, C1 to C5, what is the kind of durability that you require, whether you require a 5 years or a 10 years guarantee. The coating systems are basically proposed. The coating systems are generally on steel, a 2-coat systems. You have a primer coat, which is either Primex Defend, Primex Protect, Extend, and the top coat is either the Facade or the Super Durable, depending upon the range of guarantees that is required. So the major protection in case of a 2-coat system is basically provided by the primer, and therefore it would be good to know there are 2 kinds of primers which are available with us. One is the zinc rich primer, which is Primex Protect, and the other one is zinc Extend, which is a zinc free primer. The zinc free primers are much more preferred because they give a better mileage and thereby helps in the overall reduction of the project cost. We spoke about the durability aspect. Now let us get into the finishes or the kinds of colors or the kind of finishes that we can be offered with Jotun powder coatings. So a stunning range of color and finishes, including metallics, a fine texture effect called the Sahara finishes. Then you have the wood coating like finish or the wood like effect finish, which is known as the wood spiration, and the color and the cool shades. There is also a coating which can help reduce the temperatures inside. So we will cover them one by one. Metallics, it gives a definite glare, a design glare to the project. Represents premium, elegance, and luxury, and provides a unique distinction to the project. It is preferred more and more nowadays, with more and more projects going into a metallic finish. The second is the Sahara collection. The Sahara collection, basically, when we talk about, is a fine texture finish that we can offer. By virtue of the fine texture finish, it basically conceals the imperfections of the substrates and the dye lines and the welds. It is much more better in terms of scratch resistance, and the dirt pickup resistance is also improved when you go for a fine texture finish. Wood spiration, this is a finish that is now imitating the wood finish on an aluminium, where again you can have a range of wood like grain finishes on aluminium. These are mainly used on facades in order to in limited areas in order to ensure that there is a wood like premiumness which is given. Again, it's a 2-step process where first we need to have the base coat done, and then on top of that, you need to do a film, sublimation process, which imparts that wood coating or the wood-like grain finish on the aluminum. So these are also picking up, and there is a lot of demand for these kinds of products in the market. The last but not the least, the Cool Shade collection. This reduces, by courtesy of a special pigment that we use in these products, it reduces the surface and the interior temperatures, and also reflects heat it reflects lesser heat into the environment, thereby reducing the heat island effect as well. So there are no projects that are done in India as of now, but this is also gaining a lot of attention amongst the facade consultants and other architects, primarily because of the increased focus on sustainability in the coming years. The third aspect that we focus on is the sustainability. We spoke about cool shades here, but Jotun powder coatings or powder coatings in general are sustainable products because they do not use solvent. All the powder coating products, Jotun powder coating products, are compliant with most of the standards which are very much prevalent in the industry, including LEED and also the Indian standards like Griha. Since LEED is the most commonly used standard, we thought that we would just bring out what is the possibility of points that you can get. Paints and coatings overall contributes to about 8 points over different parameters like sustainable sites, material resources, and indoor environment quality. Out of that, powder contributes to about 4 to 5 points. When we talk about environment product declaration, this is also quite an important document, I believe, today in sustainability. We have the highest number of EPDs and an exhaustive list of EPDs for protective coatings across the globe, and these can be made available to you depending upon whether you are going for a LEED certification or any other green building certification. This is our headquarters in Norway, and this is an example. We ourselves are a LEED Platinum certified building, so we take sustainability quite seriously, and would like to ensure that this becomes a trend in the future going forward, making sure that we are building more sustainable projects. Last, would like to take you through some of the references. Jotun Super Durable, the AMA 2605 compliant products, some of the projects that we have done. Dubai International Airport, Forum Serendipity, this is in India, Mumbai. It's a residential project which has come up. Abu Dhabi Airport. We have done a lot of landmarks, as I highlighted in the earlier projects, and we have supplied to a lot of airport projects. Dubai Airport Concourse, Capital Towers, again Abu Dhabi. Mumbai Airport, the Terminal 2 is done with our Jotun Super Durable finishes. The ONGC office in Delhi is also being coated with our Super Durable finishes. This is a project in Turkey, again in Jotun Super Durable. The Suvarnabhumi International Airport, Thailand, Super Durable LEED certified projects. The Common Central Secretariat project, CCS, is completely Super Durable. One of the first few government projects which I believe has been coated in Super Durable finishes. Then Jotun Durasol, the trend is catching up in India as well. We are currently executing a project in Hyderabad as we speak. These are the international projects. Rama, which is G Tower Rama 9, which is Thailand, Bangkok. World Trade Center, again in Jakarta. Jewel of the Creek, Dubai. This is right again next to the sea, a highly corrosive environment. Jotun Durasol is being used. Olympia Park Residency, this is our first project in India where we use Jotun Durasol as early as 2016, 2015, and it still is performing well. We have not found any major challenges. King Salman Energy Park, again Jotun Durasol, and Noida International Airport is also being executed in Jotun Durasol. So that's about from my end. Thank you very much. Yeah.
Thank you, Deepak. Very informative. A lot of insight we got towards the new products of Jotun. We move on. One of the most important element and material of the facade is the glass. And as we move on towards sustainability and safety, it is imperative and important to bring a genesis between both these elements. So our next speaker is Mr. Rohan, who's flown in all the way from US. He's the Global Director for High Performance Products, and he's been working with Corare for over 9 years now. Mr. Rohan is going to take us through the new developments in sustainable and structural interlayers for laminated glasses. Thank you, Mr. Ron. Over to you.
Yes, once again, my name is Ron Hall. I'm based in the United States. Thank you for welcoming me to your beautiful city. It's my first time here. I've been to India many times, but this is really a wonderful city, and the food is fantastic. My agenda today is start off with an introduction, and then talk about some innovative structural glass applications, and then touch on a new product of ours called ES Pro, and then finish it off with our sustainable interlayers. Kuraray is a Japanese company based in Tokyo, but we have 30-some locations, and we have offices scattered all over the world. So we're truly a global company. We try to make products within the regions to help with sustainability. All right, so in the business I work in is called Advanced Interlayers Solutions, and we service many different markets. The two I'm going to talk about today are structural security and low carbon and sustainability. Okay, what is laminated glass? Well, there's some samples coming around. It's basically 2 or more pieces of glass with a film, interlayer film in the center. The 2 main types are PVB and centric glass ionoplast. So in general, the PVB is soft. When you touch it, it's soft, and the centric glass ionoplast is stiff. But we do have a new product, a new stiff PVB that's included in these samples going around that I'll talk about in a minute. All right, so what is centric glass and why is it so unique? Well, it's 100 times stiffer and 5 times more tear resistant than PVB. The clarity is fantastic. If you're ever doing low iron glass, laminated glass, it's the perfect interlayer for that. Durability, centric glass was invented over 25 years ago for the Florida hurricane market, and we have 25 years of experience in a hot, salty environment, kind of like in India, where the edges still look great after 25 years. Impact resistance, so for both hurricanes, cyclones, typhoons, it's a great product to keep water from coming inside the building, as well as some security. And one of our customers has a really nice security piece of glass out in the foyer. Sometimes interlayers touch sealants, so in general, century glass is very compatible with most sealants, but always get that checked. Another thing is post-breakage strake. If the glass breaks, the stiff interlayers like century glass stay in place until it can be replaced, where a PVB kind of falls over like a wet noodle, which is not as safe. And the last thing is century glass can enable you to design optimal and sustainable pieces of glass if it's structural. All right, so there's some confusion in the marketplace about what is century glass versus SGP. So really quick, the history, about 25 years ago, DuPont invented Century Glass Plus, really for the hurricane market. And then a few years later, Apple picked it up, and Apple started using it in all of their stores. But people started calling it SGP. And then to make it even more confusing, DuPont decided to drop the plus about 14 years ago. So really for the last 15 years, Century Glass Plus, SGB, has really been called Century Glass or SG. Then in 2014, the DuPont business was sold to Kuraray, the company I work for, and all the patents, all the trademarks, all the equipment came along from DuPont over to Kuraray. So we're the only ones that can use the high quality raw materials for century glass. Now, you may have heard in recent years there are some SGP interlayers coming out of China and Asia. But you just got to be aware that the quality is much lower. They use much different raw materials, and then the performance factors are a lot different. You can't use our performance data when using a Chinese-made SGP, so be careful with that. But our recommendation is to, if you want a high-quality structural interlayer century glass, just to specify century glass or SG by Kuraray. Okay, I'm going to show 4 projects that we became aware of recently. Most of these are in China. The first one, this is an airport in China that used SGP. And as you can see, it looks like the glass cracked. Well, actually, that is the SGP interlayer that cracked inside of the glass. The glass is fine. So apparently it must have been a wind load that came along, and it cracked the interlayer inside the glass, which is, we've never seen that with century glass. And there's actually another similar project that had the exact same results. And then one thing about Century Glass is the post-breakage strength. So there was a test being done in London, and they wanted to see the post-breakage strength, and this was the SGP, post-breakage strength. It basically looks like PVB. And the last is iridescence. It's tough to tell on these charts, but basically the iridescence is much higher with the China SGP versus Century Glass. So we do have some competitive intelligence, and so two factors that we look at are yellowness, how much yellowness is in the interlayer, and haze. So you can see on the left are our competitors. The yellowness is much higher, and then the haze is much higher as well. So that's one way to tell the difference. And then more important is how well does the interlayer stick to the glass? We call that adhesion. So this is in a test showing Century Glass has perfect adhesion. 10 out of 10 is the highest you can get, and our competitors were much lower. So when we tell people, be aware, of some lower quality products out there, they say, what are you going to do? So this year we're actually introducing a new blockchain technology where we're basically going to issue a token for every batch of material that we sell to our customers, and then the batch will go to our customers, and then when they laminate the glass, that batch token will go to their customer, and ultimately all the way to the building owner. So we should have a very traceable way of knowing if Century Glass was used, or if someone decided to replace the Century Glass with a SGP material. So this is not fully implemented yet, but we just started this week talking to our customers to get it going. Okay, next for some innovative glass structures. What is structural glass? Basically, there's probably 20 different definitions, but one definition I like is it's used to describe a frameless glass assembly where the glass is taking on an element of the load. So this whole segment started up when DuPont invented Century Glass Plus, and Apple was the first one to start using it in their stores, their staircases, and their facades. Here's many of the different applications. You're probably aware of many of these. Today I want to show a couple of unique applications. I'm sure you've seen this building before, but on the top of the sky deck is a glass railing all the way around, and it was installed in 2010. And last year I had the privilege of being in Singapore, so I went up there, had a drink at the nice bar up there and took some pictures, and so this is how it looks today. So 14 years later, the edges, the clarity, everything looks very well, and this is a very wet and high wind load area. So we're very happy to see how well this has weathered. Okay, in Chicago, there's a building called the John Hancock Building. Someone decided to put in take out some of the facade and put in this fun device called the tilt, and I'll show you a quick video. So it literally feels like you're going to fall off the building. So there's a lot of really unique applications for structural glass. Here's another one in Los Angeles. Once again, the tallest building in Los Angeles. Someone decided to take a window out and put a glass slide. I'll show you. Here's the video. And then there's a nice observation desk on the bottom when you land. And what's nice, this is pretty far away from here, but in 2021 in Dubai, another glass slide was opened up. Actually, that one's even at a higher elevation. So if you're afraid of heights, it's probably no fun. And then at Glass Tech a couple years ago, there's a big glass show in Germany. Some engineers decided to design a fixed glass slide. And at the show, it was great. People could climb up this and slide down, but you can see it's all made out of structural glass. And then there's the famous bridge, a suspension bridge in China. As you can see, it's strong enough to withstand a car on it. But there's an extra piece of glass, so they decided to break an extra piece of glass on top of the bridge, just to show you what would happen if one of these pieces of glass broke. So it's very safe if the glass did happen to break. Okay, the last video I wanted to show is in the United States, we do a lot of security testing. This is some recent testing. So in this case, one side is PVB, the other side is our sentry glass, and we shot both with a bullet. The bullet goes through. It's not bullet-resistant glass. And then we try to break through it with 15 different tools. So once again, on the left is the PVB, on the right is the sentry glass. And that thick sentry glass sample going around is actually what is in the glass in the right. So this is a 15-minute test. So I'm not going to go through all of it. But once again, there's probably 12 different tools that these people can use. And there's a joke that a lot of the people that work here are in an anger management program. Okay, so, all right, next to talk about some new products we have. So the first one is called ES Pro. So if you look at the diagram, on the left is our structural products, and on the right are the non-structural. So the first one I'm going to talk about is Trosafol ES Pro, and a sample is going around the room, and ES stands for extra stiff. And we don't have time to go through this, but you can just see looking at all these parameters, sentry glass first, followed by ES Pro, and then some competitors, stiff structural PVB. You can see sentry glass is still the best, but our ES Pro is pretty good. But keep in mind, the stiff PVB start losing their stiffness at around 30 degrees C. A glass railing company in Australia last year did a test with a competitive stiff PVB versus our sentry glass. With the shop bag test, it's a bag you drop and it hits the glass, breaks the glass. So in the center is the competitive stiff PVB. So this is at 36 degrees C. And then on the right is the sentry glass. So actually the sentry glass, it didn't break. So they actually had to get a punch and break the sentry glass and then hit it again with the swing bag. So temperatures are very important when you're designing structural glass. And here's a model that we've done from S.J. Mepla, just showing the Trosafol ES Pro versus our competitive PVB. In every case, Young's modulus, deflections, glass stress, ES Pro was much better. And then here is a 4-point bend test. On the top is the ES Pro, and the bottom is the competitive product. Both start off looking good, and they put 100 Newton weight on it. See, after 5 minutes, the ES Pro still looks pretty good, not much deflection. The competitive product starts deflecting a lot, and after 7.5 minutes, you can see the competitive product collapses, but the ES Pro is still hanging in there. And the last thing I'll mention about ES Pro versus the competitive structural interlayers, this is glass is broken and they put a force on it. So with the competitive product, at 8 kilograms, the structural PB fell over, and it took 15 kilograms of pressure for the ES Pro to fall over. All right. So I'll just finish it up with sustainability. We, like most companies, we have a goal to be at zero carbon emissions by 2050. And we have a new product called Trosafol R3. R stands for reuse, reduce, recycle. And this was our result. So if you look at the life cycle analysis and EPDs of Our products, our trossable PVB comes in at 3.26 kilograms per square meter of 0.76. Century glass is even lower, and the trossable R3 is the lowest. And just for the fun of it, we put in a Chinese-made PVB. It's actually around a 10. All right, and then just 2 more slides. The Shanghai Tower, third tallest building in the world, has a double wall with central glass in both walls. What they found was by down gauging the glass, originally they were going to go with PVB to save money, but they down gauged the glass, and they're able to reduce it from 15 millimeter down to 12, which saved 20% of CO2. And then this is from a glass railing. In this case, you had with PVB 8 millimeter, and with century glass, you're able to do 6 millimeter, which reduced the CO2 of the glass by 24%. So that's all I had.
Thank you, Ron. Very informative. Thank you for flying down all the way to give your expertise to us. With the growing complex facades in India and the high-rise buildings, it's very important and imperative that we test these facades. Our next speaker is someone who's been testing facades since 2002 in Dubai, and he set up his testing chamber in testing lab in Hyderabad in the year 2022. He has in-depth knowledge about facade testing, structural testing, and also acoustics. So I would like to call upon stage Reji Bhami, the director for Eminent International Testing Center, who's going to speak about the importance of facade testing and acoustic testing. Thanks, Reji.
Thank you. Good evening. Good. But a little bit more energy. Good evening. Yeah, that sounds nice. And to be frank, I'm a little bit nervous today. Why? Because there are a lot of known faces here. And I'm a little bit nervous on, presenting something in front of them. Anyway, I have to do it. My name is Reji Bhami. I am the director of Eminent International Testing Center. Eminent International Testing Center is one of the facade testing laboratory. It's the largest testing lab in Hyderabad. And we do all kind of facade testing. And we are actually, the head office is in Dubai. We do testing in Dubai. We do laboratory testing in Hyderabad. We are, in India, we are accredited by NABL with various standards like ASTM, AMA, BSEN standard, CWCT. We are applied for IS standard also, which is newly released. In Dubai, we are accredited by IAC, which is Emirates International Accreditation Center. Okay, before I start to go for my topic, I wanted to show you some videographs and all. So there is nothing wrong in it. This is something tested in our laboratory, and we do the pre-testing. So the pre-testing, you can see what is the water condition. So again, I'm telling you, when you do the testing and you find a water leakage, there's nothing wrong in it, because you are getting a chance to fix your problems. This is why we are always recommending to the people, to the industry, go for the testing first and then go for the installation on site. So basically, what is the benefit you are getting when you do the testing, when you do the performance mock-up testing at the laboratory? So basically, when you do the, we just see the water leakage. So if there is a water leakage, you get a chance to rectify. Maybe there is a chance of, because the gasket is not engaged properly, or some kind of design issues are there, which you can identify at the time of testing, and you can rectify, you get a chance to rectify that. And the PME testing, you can identify if there is structural issues that are there, like any, vibrations on the facade, or any bracket movement, or the bracket is not able to take the load of facade system, can be identified at the time of testing, and you get a chance to, if it is a structural issues, you can strengthen the mullion or aluminum, or if you wanted to change the glass size, can be done. And this is the important thing. When you do the performance mock-up testing, before it installed on the site, you are able to identify the problem of your facade, and you are able to fix the problem without putting any additional amount. Because if it is already installed on site and you found the problem, then you have to spend a lot of money, lot of time to fix it. So the main testings, and if the testing is not done properly, or the testing is not done, then what is the effect is going to happen? So for example, if the air infiltration testing, and if there is an excess air leakage, you will have hot air transferred to the room, and then you will have, when there is high temperature inside the room, then you need to run your air condition fast, and then your utility bill is going to be like more bill you have to pay. And the second thing is moisture content and water intrusion damage. It can happen to the building. This can damage your floorings. This can damage your wall, like your expensive wall papers and the wooden floorings. The next is the water penetration. So the water penetration, if there is a leaky building, if there is a water entering to a building, for example, you are going for a vacation for 1 week or 1 month, and you come back to your apartment, your villa, you have a water leakage, and the entire floor is damaged with water, the furniture is damaged with water. So all these kind of things can be identified at the time of testing. The other thing is a structural failure. So what if the system is installed on a building without testing, and you realize that the system is not working properly, the system is not able to withstand the wind load. So what is going to happen? You have to dismantle the system, and it's very difficult. The system is, everything is installed, and it is very difficult to rectify. Then the seismic movement, if there is any building movement is happen, how the system is working. Your facade system is properly working along with the slab deflection, slab movement, which can be tested in the laboratory, and we will be able to identify our problems. So how are we going to do the testing? Like initially, the project is awarded to the contractor, and the contractor will make all the die drawings, and the design is completed, die drawing is produced, and the fabrication is completed. You can send the 6 or 8 panels to the laboratory, and once we get performance mock-up testing drawings, we will be creating a structure according to your sample size, your sample shape, and we will be creating the sample ready for you. Once the rig is ready, the rig will create it for you, and once the rig is ready, you can send your sample for installation. Once the sample is installed, and we can close the chamber, the photograph number 4, we will close the chamber, and we make sure a complete airtight chamber, and then we can, the sample is ready for testing. So basically, the whole process will take 10 to 15 days time. So the most important testing we conduct in our laboratory, the first one is the air permeability, which you are measuring the air leakage of the facade. We have all the equipment facilities there. So we will be measuring the air leakage through the facade. There will be some allowable criteria for each system depending on the projects. And we have to make sure that air leakage is within the limit. And if it is beyond the limit, still we will be able to rectify. The structural load testing is one of the important testing, which is we conduct based on your design calculation, your design wind load. We will be able to create that pressure in our laboratory and conduct the testing and get your deflection of the mullion and transom and the glass deflection. Everything can be determined at PMU testing time. And the next is the water penetration testing. We do the water testing in our laboratory with the spraying water from outside, and at the same time we will be creating a negative pressure inside the chamber. Similarly, we are conducting a dynamic water penetration testing. It's like we develop a wind pressure from outside with a wind machine equivalent to a certain wind speed. And at the same time, we will be spraying the water from outside, and then we can wait for the result. Seismic testing is one of the tests. We simulate the building movement, like a seismic movement. We create we move the beam left and right to identify how the system is performing with seismic movement. Seal degradation testing is one of the testing. We remove some part of the sealant and then conduct the water penetration testing, which is replicating like if you have any damages on silicone or any gasket damages, how the system is going to performing. So this can be identified at the time of performance mock-up testing with the seal degradation. Thermal cycling testing is one of the important testing, which we create various temperature from an actual standard. It is like a minus 18 degree till 80 degrees Celsius. But in our country, in India, it is not required. However, we can do the thermal cycling testing as per our market standard condition. Railing and balustrade testing is very important testing because you know that people are relying on our system, railing system. You know, we are constructing high-rise building, and people are completely relying on the contractor, the railing contractors. But we have to make sure the system is tested properly. It can take the load as requested in the standard. So BME pull-out testing can be conducted in our laboratory. And vertical displacement testing. Like for example, we have a dead load and live load on the or slab deflection can be conducted in our laboratory. Like we artificially move the beam, the bracket up and down, and make sure the system is performing along with the bracket. Then impact testing, we do the impact testing on the glass and make sure that if there is any BMU, building maintenance unit installed on site, which is, you know, it can hit on the glass or it can hit on the aluminum so that it doesn't damage, it will not damage the glass or aluminum, that we can make sure in the laboratory. Site chamber testing is one of the tests we conduct on site, which is this is actually validating the performance mock-up test we have conducted in the laboratory. And similar way, we can conduct air infiltration, water penetration, and structural load testing on site. And we have the facility to do on site. We have, in our experience, we have done one of the project in Delhi. We have done up to 4 kPa wind load and tested in the Delhi project. Building airtightness testing, it is not that common in India. But in our office in Dubai, we used to do a lot of building airtightness testing. For example, I'll explain to you what is building airtightness testing. For example, we wanted to know what is the air leakage in this conference hall. So we connect our blower in one location, one of the door, and we pressurize the whole area with certain pressure like 50 or 75 pascals, and we'll measure the air leakage. The leakage is not only from the facade, it can be from the floor, the crack on the floor, the MEP leakages, and risers and all there on the building can be identified, and we can give the total leakage of the building. Anchor bolt pull-out testing will be able to identify what is how is anchor engaged with concrete and all. Thermographic inspection is one of the tests we do. This is mainly identify the thermal transmission, and it can be used for air leakage when we have air leakage, hot air is transferring to the building, and we'll be able to identify by scanning the camera, whereas we can pinpoint the air leakage locations. And hose test is a very common testing we'll be able to do on site. We already started to do glass testing like fragmentation, roller wave, edge lift, overall bow, and we do the surface compression testing. And the surface compression testing, we are using scalp machine, which we can test even on installed glass panels on site. We have already completed a couple of projects in India, some airport projects and some projects in Pune and Hyderabad. This is one of the testing we are conducting as per BSEN 13030 standards, louver testing. And this is the performance louver testing. At present, Eminent is the only lab can do this testing in India. So this is another testing. We are facing so many issues with glass or window shutter falling off. So there is a standard for identifying those issues, like AMA 910 standard. We call it misuse testing. So we can conduct this testing in the laboratory and at site. We recently conducted one of the project in Hyderabad, Pocharam, and we did a couple of window like misuse testing at open condition. So I wanted to show you some special projects we have done in our laboratory. This is one of the Hyderabad project. The specialty of this project is like 3 different elements in a building. The developer wanted to test each and every elements and different elements, and they wanted to get the result of that elements. So they have taken some segmented facade and then straight facade and inner corner and outer corner. So all these combined system tested together with, they could identify what was the actual problem with the system, and the client was satisfied. So this is another system we have tested for one of the project in Hyderabad. And this is the specialty of this project. We have tested with waterproofing membrane, like the connection between the wall and the facade is tested together. Normally we test only the facade system, but the interface is not tested, like ACP cladding or waterproofing membrane is not tested. But in this case here, it was tested and satisfied. And this is another testing we have tested for one of the airport project. We tested with the roofing system along with the integrated skylight and gutter and everything tested together. And this is one of the special testing and one of the biggest project we have done. Okay. Now we already started to conduct acoustic testing. Acoustic testing is one of the major testing we are expecting in the industry from, requirements we are expecting from the industry. Okay. I wanted to show you some of our testing facility. So this is what our facility, and we started our laboratory in 2022. Since 2022 till now, we have nearly completed 100 projects with our esteemed client, and these are our client list. Thank you. That's it for now, and thank you so much.
Thank you, Reji. Didn't look like you were nervous. Thank you for the understanding of the importance of facade testing and also the types of testing that are carried out in Eminent. Currently working with Viva, metal composite panels, and he's national head for the projects for Viva. It's been over 5 years. Faizer not only sells the products, but he is very influential in developing new products for Viva based on the ever-emerging Indian market. He's been very influential in getting certain products certified and taking Viva to the next level. I take great pride in calling up Faizer Ali Dastagir of Viva.
Thank you, Vishwesh. Thank you so much for those kind words. And trust me, I didn't give Vishwesh a treat yesterday night. It was purely friendly. Good evening. Arey yaar, come on, don't do this. I know I'm holding up you for coffee. I'll try to make it as caffeine as possible. Good evening. One guy make more noise than 150 people. Doesn't work that way. Good evening. That's much better. That's much better. I'm Faizer Ali Dastagir, National Head Projects, Viva Metal Composite Panel, Asia's largest ACP and cladding solution manufacturer. So Viva anymore doesn't remain an ACP manufacturer. You will get to know why. I am mentioning the word ACP because that's how we've been identified in the market. But trust me, the presentation will speak very less about ACP and more about a lot of other innovative products that Viva has brought into the market. The topic today, as I said, is going to be less about ACP and more about the innovation that we bring. Just a brief into what is coil coating because it is connected to the products that come henceforth. And a lot about innovation into fire retardant products. Obviously, the products that are coming forward now and are ready to be launched are sustainable products. So Viva started its journey in the year 2003. Today, by God's grace, we are present in 20 countries, covering all continents across the world, except Latin America. That's where we don't have our presence at the moment. I hope we'll be there soon as well. We have a massive capacity of 12 million square meter per annum, which is around 30,000 square meter. We've scaled it up. Now it's around 40,000 square meter per annum, per day. And today Viva has 12 production lines, out of which we have 4 active coating lines and we have 8 lamination lines. We're adding up much. I'll talk about it as we move later. Our biggest strength today is the kind of innovation we come, and innovation starts with the aesthetics, with the shades, with the textures that we can offer you. We're well supported by our customers, dealers, distributors throughout. I was hearing somebody mention in a very small village in Ramnad, in a very small shop, he saw an ACP sheet. That's because of the kind of robust network we have today in India. I'm not going to be introducing ACP to you. You all are familiar. I don't want to be talking more about that. We all need to understand that the coating on ACP basically works with a standard called AMA 2605. So AMA 2605 defines what coating you should have for an exterior application. So I would like to highlight some points here because most of the audience I have met or I've been to their offices often have this question with me: why does ACP fade? Why have we seen a lot of ACP being faded? The point is that when AMA 2605 is not followed properly, the right kind of coating, the right kind of curing is not given, the right kind of paint is not applied. Please understand, every paint is not UV resistant. A polyester is a very good paint, it is not UV resistant. We need to use the right paint for an exterior cladding product, for the product to live its life. So it's very important that we understand what we are buying and why we are buying for. So just a thumb rule, in case you want to buy a metal panel, be it ACP or be it a solid sheet, a 10-year warranty product basically should have a 25 micron coating. The terminology in bracket 2 coat, 2 bake means every coat of paint needs to be cured. Let's all understand any metal composite or any solid sheet that is manufactured undergoes a very rigorous precision manufacturing process. So if I am curing a particular thickness of sheet for a paint of 0.5, if my setting has to be 251 degrees, all my ovens have to be at 251. If I go 252, the paint will flake. If I underdo the temperature, the paint will chalk. So ACP manufacturing is a highly precision-driven engineering process. So we need to appreciate that ACP is not a very easily commodity product. one of the major, sorry, I just forgot to highlight something here. A 15-year warranty is 28 micron, a 20-year warranty is 35 micron, and a 25-year warranty is 40 micron. I was talking to one of the delegates here, and he asked me, what do you think about coating and warranty? How is PVDF versus FEV? So today, FEV is a very good paint, no doubt about it, but the kind of chemistry today PVDF offers, it is equivalent to an FEV paint. The technology is improved. If I'm talking about innovation, a 15-year warranty now can be done in a 2-coat, 2-bake, while 2 years before it was a 3-coat, 3-bake. So technology is improving. The best part is, what we were dependent on countries abroad, today everything is available right at our doorstep. We do not have to look on to foreign brands to build the nation. We don't have to. Rather, other nations are using us to build their nation. So let's change the perspective of an Indian manufacturer can do better than any other international manufacturer for sure. One of the greatest strengths of Viva is the innovation we bring across in terms of shades and textures. The kind of finishes we have. You think of any material and we can replicate that onto an ACP format. We can replicate that onto an honeycomb format. We can replicate that onto a solid sheet format. Anything is possible. Stone, granite, wooden, you name it, we can do it. We've done it. And I'll be sharing some case studies as we end the presentation. So this is one of our very signature series which we launched, Santa Fe, which has the texture of a stone on ACP. So it is coating and embossing both together. It's a very advanced technology. Coming to fire retardancy, which is always, I have spoken a lot about it in my previous presentations at Zak. It is a very important criteria because a material should look good. At the same time, it should perform well on fire, which is very important. Lives are important. We do that by changing the composition of the core. We add a non-combustible component to the core in different percentages. I'll also talk about it as I move further. Again, a very important question we all need to ask when we buy a material. Is the material tested for fire or is it certified for fire? There is a huge difference between being tested for fire and being certified for fire. When we say certified, the plant automatically falls under an audit process of 4 audits per year. So a Viva plant has almost 3 certifications on each grade, EN 13501, NFPA 285, ASTM E84. So for each standard, we have 1 audit. So guess how many audits we do. So the plant always keeps running audits from Thomas Bellwright. So that's the kind of control we have on our product. And very important, it gives you the validation as a client, as a stakeholder. The big announcement I wanted to make with all of you is, at last, we have A1 non-combustible panels in India now. We've been talking about Class B. When I started my journey with Viva, we went on to A2, and today we have non-combustible panels in India, and Viva will be the first to manufacture A1 ACP end of March. A1 means non-combustible. It's like a solid sheet. It will have a mineral composition of 95%. We will come with the details in the end of March when we launch the product. Our corrugated core is also going to become an A1 product. And our honeycomb panels, as on date, has an A1 certification. We have an A1 certification from Thomas Bellwright for our honeycomb panels. We are the first in India to get that. So 3 composite panel products are going to have A1 certification, which I think so is a very big achievement for an Indian company. This is our A2 plus corrugated core, which is going to have an A1 certification. This is a honeycomb panel, 12 mm and 25 mm, which already has an A1 certification. We will also be coming out with some innovative products like ready-made fins. You have vertical fins on the facade, right? So instead of doing an extrusion to make a fin, you will actually make a ready-made fin out of honeycomb. So we'll have 150 mm depth fins, 300 mm depth fins, 450 as ready-made modules for you to install. So that is another product we're going to be value-adding to honeycomb. And this is the hero of the show. So basically, we're launching our solid sheet 3 mm and 2 mm. It's going to be branded as SX 3.0 and SX 2.0. And the machine is already running, we are already producing, we are already working on projects. The best part is, for the first time in India, we have pre-coated solid aluminum sheet. Please understand the difference between the word pre-coated has a very significant point. Whatever solid aluminum today available is not pre-coated, it is bent and then it is coated. This is going to be the reverse. We're going to coat and then we're going to bend and make it into a tray. So the services we offer here are going to be coating, starting from 15-year warranty up to 40 years of warranty. We're going to be operating on 3000 alloy, 5000 alloy, and 5747 as well. So we're going to be operating on 3 alloys, and the best part is we will have ready-to-fix panels also made. So if a project needs panels ready to fix, we will make that as well. So this is a very important and significant innovation that has come through. And another beautiful product is the anodized ACP for the first time in India. The coil warranty for this is 25, the product warranty is 25 years, the coil warranty is a lifetime guarantee on this product. We've collaborated with the Aloxide from Germany. They're the pioneers in this field. Then we have zinc composite panels with collaboration with L-Zinc. We offer a special width of 1250 where the other zinc manufacturers cannot do that. So this is where all the magic happens. This is our first plant. The plant version, we call it 1.0, 13 acres of land. IGBC certified plant. We'll be also working into more sustainability factors. A paint mixing unit. This is our coating line 1, 2, 3. And these are our production lines for lamination, for honeycomb, for A2+, for A2. And this is the expansion of the plant. This is 50-acre land parcel, which is going to have 2 coating lines, one for solid sheet, which is running, second coating line for, again for ACP, that's going to be the 4th coating line for ACP, 3 lamination lines, and for the first time in India, an FR-A2 core line as well. So we really want to take the world by storm. So that's the way it is going, and it's going to continue. Hyderabad has always been one of the very responsive markets we've had. We've been privileged to be a part of some wonderful projects here. One is the Raheja Comozone building, Qualcomm, and this is 26,000 square meter of FR Class B with a Desert Series product here. This is one of our recent projects we finished. This is Meenakshi Pramila. This is 5,000 square meter of FR Class B. We did a project, last year we completed this project with zinc composite panel. This is Satwa Signature Towers, opposite the GVK Mall. This is one of our first projects in Hyderabad. We did this with Raheja, and this is the walkway bridge, which is a very iconic structure by itself. This is our capital land project, the first big, large commercial project we did in Hyderabad, 26,000 square meter. Phoenix has been one of our key accounts in Hyderabad. We worked with Phoenix for Centeris Hyderabad. We worked with them for Aquila, for Litop, for B-Hub. I can keep listing, it's continuing. We've done n number of convention centers across AP Telangana. If I do the list, then it will be another presentation by itself. And the best part is, all of them have got our premium products. It's not that we've done any normal solid metallic stuff. This is one of our iconic projects in Bangalore, Mall of Asia. Again, Phoenix is a very large account that we handle. This is an iconic project in Chennai, the Chennai Metro Rail headquarters. It's a 5-year-old building. So whenever people ask me how long have your ACP seen live, I take them to this building. So this is a great building in Chennai. This is a building which has our A2 plus corrugated core panel, and it experiences some great wind loads. The panels are sturdy, absolutely flat after 5 years. Some projects in Pune. Again, Pune has been a great destination for projects. As I told you, Viva believes in innovation, and one of the key innovation factors is developing new shades, customizing. I would say fulfilling the dreams of the architect, the developer and the fabricator, what they want to put. So this is one mall in Kingdom of Saudi Arabia where they wanted a barcode you can see the barcode detailing given by the architect, and you can see the final product, what has come out. So this is how it panned out. This is my favorite, the Al Khor Zoo in Qatar, where we developed a bamboo shade for the panda. It's a panda enclosure. So you have pandas inside which have been kept. So the concept is that pandas feed on bamboo, so they wanted the entire cladding with bamboo. So we've developed this bamboo shade, and that is the detailing for the architect. That is the prototype we developed. And eventually we won the project. In short, if I have to say that Viva is a company that is looking forward to take on challenges you would throw at us, and we would love to be a part of any of the projects, and looking forward to the same kind of support as we keep innovating and growing. Thank you for being a great audience, and congratulating all the speakers tonight, and a great audience. Clap for yourselves, please. Thank you.
Thank you, Faizer. Great to know Viva's going great guns, not just nationally, but internationally. And it's excellent to see the amount of products that you're adding into your kitty. All the best. Well, it's time for a quick break. We'll take a nice 15-minute coffee break. We don't have too much of time, so we'll request you all to come back as soon as possible. I'd like the speakers to say back, please. Ready? Welcome back, ladies and gentlemen, to the last session of the Zak 2025 Hyderabad edition. Our next speaker is architect Nishanth Vijayaputra, who is a principal architect for Morfemi Architects. After graduating from London and Madrid, he moved on for some experience to Shanghai and Singapore, and moved back to Hyderabad in 2015, where he set up his own practice of Morfemi Architects. I'd like Mr. Nishanth to take over.
Yeah, thank you so much for that short and sweet presentation. Everyone, good evening. You must be very tired, and I'm sure all of you have Valentine's Day's plans. So I'll keep it quite short. So a little bit about my history. This is my thesis project about 12 years back when I was studying at the Architectural Association in London. So what it is essentially we were trying to solve a geometrical problem of creating these curved walls by focusing on a single element. And what we have over here is this brick with a soft joint which can kind of create curved surfaces to a certain degree. And this kind of requires rigorous geometrical thinking. And this project kind of influenced my ideology and thoughts on architecture. So curves have always been something that I've been fascinated with, and I feel that it is much more human. It makes the building more organic, and it makes the building more relatable to the human scale. So today, I don't have any data, no technical stuff. I'm just going to talk about inspiration and how our architecture is driven and what kind of comes about. So these are images. One is of an eroded stone, and the other is these Cappadocian cave dwellings. These are kind of very fascinating stuff. And when we look at architecture, we kind of want to draw parallels and understand and inform our work about this. So first, I'm going to show a few residential projects that we're working on. Usually, these residential projects are big rectangular blocks in the city and have a huge presence, and they're very masculine and strong and rectangular in nature. And, you know, because of... And then there's also this very beautiful architecture. This is Antonio Gaudi's La Pedra in Barcelona, and it's got such a beautiful softness to it, and even after like 100 odd years, it still feels quite nice, and it actually drives the economy of the city. So the architecture is superbly powerful over here. So what we try to kind of look at is how can this inform modern structures where everything is kind of based on efficiency and super productivity. So we have to build things fast, especially for a developing nation like ours. So first, thing that I'm going to talk about is curves. So we've got this typical residential tower block, which has squarish rectangular apartments because of Vastu, and then we've got these balconies projected out. So what we thought is, let us look at the balcony as a facade element and concentrate on just that one single element. And let's see what the architecture happens after we focus on it. So we've got these sharp corners which we've rounded out, and then we've kind of raised it a little bit for a functional purpose. As you can see over here, this part is raised. It's because it's kind of covering this utility area. But also what it does is it kind of creates privacy. So each balcony is kind of private in a way because the neighbor cannot see into the balcony, and sometimes it's hiding the utility, sometimes it's hiding the master bedroom. So this is kind of what happens, and this is the stage in which the project is. One of the tower out of 6 towers has been built, and it's due to be finished in May. This is another project. Again, it's for the same client. So initially, balconies were looked at as a very luxurious element, but we kind of convinced because these projects happened to happen during the COVID stage, and we were able to convince the developer to have large balconies as a functional element and not as something to be looked at as a luxury. So here, again, what we were trying to do is we were kind of trying to deal with this issue of repetition because most of these buildings have this repeated scale and it looks quite monotonous. So we've introduced a small dimple in the balcony over here, if you can see, and then put a vertical aluminum element. And what it does is it kind of creates it breaks the monotony a little bit. But also what it was is, it is a facade lighting strategy which kind of makes the shape of a tulip because the project's name is Tulip. So we were able to sell the idea of the facade to the client because of that. This is one of the renders of the inside. This project is also under construction. Then I'm not going to go through all the projects, but this is a proposal we gave for an apartment overlooking a golf course, not in Hyderabad. This is again an up-end project, about 100 apartments, one single tower. This next element is about screens, how we look at screens and how we want to, experiment with. Again, this is for a tall 22-story apartment facade. So we thought okay, there's going to be a repetition in the facade, but how do we make it interesting? At least how do we play with that repetition? So screens is something that people are used to over here. So we thought we'll kind of introduce screens alternatively, and then we kind of create this playfulness in the facade, creating a bit of privacy, helping with the shading of the apartment a little bit. So this is the kind of language that comes about. Again, I feel that it's much more interesting and dynamic as a facade than the facades. So this is again another project. It's actually the clubhouse of one of the residences that we had shown. So we just want to quickly show how we kind of go about it. So fortunately, we've got this triangular building, which we generally don't get, but because of the site conditions, it's got this cafe and restaurant below, which is glazed, and we thought we'll put in louvers, and usually, again, we use a lot of parametric tools like Grasshopper and all that to kind of influence. So we can actually see what is the distance to give between each thing, what is the angle that it needs to be, and this is the concept that's in development at the moment. And yeah, we're working with facade consultants for this as well. Patterns, and again, I think Jali is a superb Indian element which has been used quite a bit. It breaks down harsh sunlight and it also brings a lot of grace and lightness to the building. This filigree thing is from Delhi's buildings, of course. And learning from nature as well. This is a stone that is eroded, and it's got this beautiful organic pattern that has arrived. So this is the facade that we developed for a building which kind of needed varying degrees of openness. So the facade actually becomes more open towards the bottom and less towards the top. At the top, it's actually the parapet that is covering the terrace, so you don't really need much privacy, and it creates this open space that is guarded. This, again, is another recurring element, looking at patterns and geometry and how this can kind of bring grace. This is one of our clinical lab proposals. This is our first building that we did in Hyderabad. It is a clinical research lab, which is also a green building, which we kind of won an award for this. So this building was designed to be a 4-story building, but the client initially wanted to build only 2 stories. So it's super classical, modernist, rectangular, 3.6 by 1.8 meter grid building. And we wanted to extend it. But we just didn't want to copy the same elements above, because that would kind of make the building look very heavy. So what we did, we kind of started looking at patterns again. This kind of shadow play that happens when you look at light that falls through foliage is very beautiful. And this is something that's always attracted me. And this beautiful dragonfly's wings, which comes, the Voronoi pattern, it's very overused geometrically. But the client over here was interested in cellular biology, so he wanted to kind of use this idea. So the previous idea and this idea, we've developed this facade jali element, which is arrives out of this thing, but we also create variations so that it's not too repetitive, and create these variations, varying degrees of openness, and again through grasshopper. This is a small detail of it. So this is what we kind of are expecting. I mean, this is one of the proposals that we had given, and we're still working on it. But the building's mass looks quite big. Geometry. Again, geometry is a very recurring theme. We're working with this very interesting startup from Hyderabad, actually, who's looking at recycled plastic. Apparently, Hyderabad produces 365 tons of waste, plastic waste, every day. So they're trying to solve this issue by turning it into pellets and then creating these panels about 4x4. And some of these panels have these very beautiful marble-like patterns, and some also have this translucency. So we're trying to kind of create this pavilion that can be set up in design shows for them to kind of elevate a product that is otherwise looked as a waste product. So we want them to kind of look at it as a very nice architectural element that you can use. Biophilia, again, it's this innate and genetically determined love for the natural world, felt universally by everyone. And I think, like, as Indians, we love our green. Unfortunately, we are destroying a lot of it in the process of building. But how do we kind of deal with this, contrast? This is a conceptual project that we've done for a developer. It's actually about 20 floors or so. So again, we're trying to break the repetition of the facade. Balconies is a recurring element that we've used. And we want to kind of put a load of plans on it. This is how we kind of envision it to be. Hopefully they're going to like it and build it. Then this is another small project that we are doing. It's actually a micro hotel with a small cafe and a co-working space below, and then rooms above. So we were looking at how to kind of make the facade full of plans, but in an interesting geometric way. We purposely took this platonic solid, which is just cylinders, and varying the heights and creating this facade, because it's also in a very busy part of the city and doesn't have something that's very interesting to look at. But if you can create this, it can create this micro view from the hotel rooms above, and create a very nice ambience for the cafe below. Yeah, as I promised, it's short and sweet, I hope. Thank you.
Thank you, Nishanth. Beautiful presentation, just like the buildings that have been designed by you. Well, we move on to the last session of the day. It's a panel discussion on the challenges, innovations, and the way forward in implementing the National Building Code. To moderate this, I would like to call upon Mr. Kusharga Avasti, Head of Engineering, Shuko India.
Good evening, everyone. So we are in the last stage of today's presentations and panels. I have a very elite team today. So I would like to call Dr. S.P. Anchuri, Chief Architect Anchuri and Anchuri, to please come on the stage. Architect Gaurav Sangvi, co-founder Peta Space Design Studio. Mr. Kalyan Chakravarti, Associate VP Phoenix Group. And Mr. Satish Kumar, GM Planning and Development, My Homes Construction. So this evening we have a very interesting topic. This is regarding the National Building Codes, NBC, which is getting published in 2025. We have been working on this code for quite some time along with the BIS team. So there has been mixed reviews, mixed thoughts that we had. So today we will be discussing in detail what this NBC will do to our industry, what we can expect, how we can implement it, how we can make it successful. So I will just leave the thought of this NBC 2025 up here without any questions for now. So your first thoughts?
I need some mic. Okay, sorry. First thing is that as a developer, I represent a developer group. So perspective from the developer side is about implementation, and we see this is an opportunity where we can get more visibility and predictability in terms of efficiencies or in terms of value engineering, which can be brought in terms of design, execution, and in terms of maintenance. So we seek more clarity in terms of information, which in the present NBC 2016, what I see, largely it is only a guideline which is there and not much elaborated. But in the drafts, what I see is there's much more detailed steps have been given. I think that gives a guideline in terms of what can be done better in terms of implementation. So one area what I see is about an approach, an SOP can be established with this kind of NBC implementation. From a developer perspective, I think that is one I would like to say at an initial start point to start with.
Yeah, so basically this, the new version, the latest updates is redefining again. So the definitions are something which is coming new. We have redefined it. Second thing, the performance parameters, acceptance criteria that has, the level has been increased. Then again, there is a much more emphasis on the sustainability aspect now. So it is a directive from Ministry of Science that there has to be, a talk about sustainability in all the chapters, let it be any CED what you take. Then the more focus is on the safety aspect also, right? So how it can be made more stringent and how it can be made more available to the public, right? So given the thought, it is more exclusive kind of a detailing that has been done, but it is also a collection of, the ideas or the different codes that we had in BIS or IS. It will be like a mother code, I would say, right? So we have to see whether it can be, how it will be implemented on a national level, because, the regional requirements are different, So we need to see that.
From 2005 code to that of 2006, we have seen a huge leap in terms of information, the way it is structured, and a lot of things have been added, both in safety. Safety has been the predominant area where 2016 was focusing at. And in the present code, what I see is safety is one thing and sustainability, as you said. And particular to today's topic in terms of glass, glass has become like a standard material for building construction.
Yes.
And now, adaptability-wise, it has come to such an extent without glass, you can't have a building which can be imagined.
So if that is a case, that is a given case, I think more inputs in terms of what type of classes has to be used where and what purpose and what parameters have to be utilized. That differentiation will certainly help in understanding the adaptability better. Today, the larger developments are happening on high-rise structures. So in terms of efficiencies, one is about your deflection criteria, or in terms of heat reflection, or in terms of your energy savings onto the glass parameters.
Right.
These are something which are coming as a standard. ECBC already states in terms of the parameters
Right.
which is required. Correlating codes with other codes what we have. Either it is ECBC, NBC, and then we have specific codes pertaining IS codes which are there.
Right.
I think more correlation and detail within the present code itself might really helpful to understand. Most of the times we refer multiple documents for an information. I think if that correlation can be brought in the same document, it is much easier to relate with.
Right, very valid point. So it has to be consolidated code. Not everyone has to refer to n number of documents to just to get
We have been using largely with the ASTM EN codes where it is required. That I think we should come to a situation where we should refer to our own code saying that this is what is right.
No, the time has come. I mean, it is the time to, refer to our own codes. There is a well-defined procedure now for testings also in this new release. And I'm sure the test labs that we have here in Hyderabad, Eminent, and in Chennai, and even in Mumbai, in Winwall, everyone is competent enough and accredited to, get as per the new IS code and the NBC. What is your thought, Sudhir?
So, when coming to this code, we have to have a standardization. So basically what is happening is, as what he was also explaining, we have different requirements for different aspects. We have a structural code, we have for energy saving code, but especially for facade, if I have to bring it, I don't have a specific code.
Right, absolutely right.
Okay, and everyone thinks facade is only an external feature, but without that, because as everyone knows, that is the first line of element which acts against the environment. So even take up the SHGC or VLT, U value, all these. But all other machinery and everything is within the building. But the first element which is facing this atmosphere of so much of resilience is the facade. So what is that standardization you are going to bring in here? So as a developer, what we look at is we have to have a specific detailing. If you are going to such a height, this is what you have to follow. If you have fixed a code, try to make sure that is being followed. Like how we get structural approvals for going for OC or for a fire approval, the CFO. Similarly, for facade also, we are supposed to get the approval.
Correct.
Because many a times we see that fire officer comes, he checks, he gives an approval, considering only whether you are given a sprinkler at a 600 mm from the facade. And we apparently don't submit a single document to the fire authority for the elevation. Whether we are providing 10, for every 10 panels, for every 10 meters, we have a openable panel or not.
Correct.
We don't submit any document for it. There is no standardization for it. So what I mean to say is, when codes are coming in, make sure it has been implemented and standardized, and everyone follows.
But you see, projects are run by specifications as defined by facade consultant, which is anyway is the responsibility of system supplier or bespoke systems to comply to those specifications and submit the same to the facade consultant for approval. It is not as part of the code, but it's part of the specification. So there is a standard, I would say, which is being followed. Of course, the specifications will vary from region to region, projects to project. Right?
So as a developer, what we happen to do is we appoint consultants and we entirely depend upon them.
Yeah.
And unfortunately or fortunately, at times, these specifications gets missed out. Because project to project, location to location, the requirements changes.
Correct.
For in Hyderabad, it might be different, or it might be in Mumbai, it will be different, or any other abroad, it will be different.
Right.
So you cannot have a standardized detailing which is provided. And many of the times, this is what is being followed.
So geography, I mean, looking at the geography also, you can't have the same specifications for north and
So
south.
that is what
and
the
east and west.
standardization has to come in. So what happens here is, if you are having a CFO over here, the fire authority is here, he is having a specific detailing that needs to be followed. Similarly, for the facade also, you have to make sure that these are the standards to be followed. A documentation has to be given, an SOP has to be set, saying that this is the minimum criteria to be met for you to get an approval. Then what happens is, it becomes as a mandate, or else, because facade plays an important role, and this has to be understood by everyone. And facade is not only glass. There is a mixture of so many elements into it. Any one element fails, the entire facade fails.
Correct, correct.
And the life of the facade is equivalent to the life of the building. I cannot rip down a facade in next 20, 30 years.
Correct.
Which is seeing its full life cycle. Then I can change a machinery after 5 years. Can I change the facade for a commercial building which is leased out to the clients? No, we cannot.
We cannot. Yeah.
So we have to be more precise in terms of detailing what we are looking at. What is the life? What is the type of material I have to follow? What is the type of specifications I have to follow? How is the fire compliant or not? And basically, there are testing codes which are coming up. IS, ASTM codes, IUL code is there. And now Indian code is also come up. But how many of them are actually following it?
That's what we need to educate the industry, educate the people.
Educate, not the developer. The consultant has to educate the developer.
Yes, I agree.
Because we are dependent on the consultants.
Right. What do you think?
Namaste everybody. In fact, when any code, that may be National Building Code 2005, see code that gives us some kind of guidelines. Now tell me why the amendments are required or why the update is required, because there is a development in overall cross-section of the industry. Down the line 2005 something was there, now today something is there. So what I feel is, it's not NBC only changes, but in that, for example, we are talking about the resilient buildings, now earthquake. Now today I am into zone 2, but if I get some things, in the future it comes into zone 4. So IS 16700, which is the code for tall buildings, which is again new edition is coming. See, architectural elements. See, as on date, architects were knowing only some part of the function and this one. But today I am happy that architects are talking about structure, they are talking about parametric, they are using engineering words. But I feel these things are developed, then NBC is a collection of all those things, isn't it? So there are sustainability. It was not there earlier, it was there. But if that NBC 2025 and such things come, it's going to be a part of. Somebody says ECBC should be, should be there because Griha rating. So Griha is there, ECBC is coming up, or ECSBC is coming up. So I think these things are to be developed or amended or versions. These are not amendments but versions. And good that our country is going fast, implementation point of view, acceptance point of view. Now today, if you go to NBC, each chapter, you are there, I am there. So all industry stakeholders are there and that interaction is good. Earlier it was not there. See, earlier the deliberations and debates were to some extent, but today it's there. So it's online or whatever it is. But the things are required and this will be, today we are talking about 2025. Maybe it may be within 3 years we can change. In other countries, every year that changes. Here it takes about 10 years. IS 870, IS 456, it's about 20 years, 25. Some things are there which is 50 years old codes.
Correct.
So I think that code, how it will be applied now. So I think this entire thing, this exercise in 2025 is more of an implementation oriented, which is a user-centric and then implementable. I think we have to welcome that. And naturally, the performance-based things are going to be very, very vital. Code is only a guideline. But if you are complying that, I think we'll be go. And I welcome that 2025 as a more of an implementation-oriented.
Right, it's part of the much bigger vision which is being to be net zero by 2070. You know, that's the vision. So this is one step towards it, and this is a good thing. At least in our times, we are able to see this change happening. I don't know whether I'll be there to see the net zero in 2070 or not, but at least it's good to be part of this change, and it's really, I hope that, you know, it becomes a big success. What is your thought, Gaurav?
Actually, being a design architect and working across different geographies in the country, I feel that, kind of having a standardized code like 2025, 2016, I think it did work at a particular point to kind of get, some standards and regulations to a certain point. But now I think it's so robust, the development is so robust across the country. I feel it should be more region specific, and Bombay is growing at a very, very fast pace. Hyderabad is growing at a very, very fast pace. Gurgaon is growing again at a very, very fast pace. Other cities are growing, but they're not growing exactly at this pace, right? So having a standardized code where, some cities are kind of outperforming that speed, I think if you kind of make it more regional, I think there would be more adaptability, more learnings, and codes can grow faster and adapt faster, rather than kind of putting an umbrella over the country. It's very difficult for our country to kind of, contain development at this point. So I personally feel there should be standardization, but then regionally there should be autonomy kind of, letting it kind of grow in a particular direction, and then there should be cross learnings, right? So I think that will kind of really amplify, as we say, from lead to griha, how we kind of started Indianizing a lot of our, systems.
Yeah.
I think that is the way forward, right? So learning from fast growing cities, see how the codes are actually kind of bottlenecking them, or kind of upgrading, or see where the challenges are, learn from that, and kind of start putting it into the other areas. So I feel there has to be autonomy and there should be standardization, and you kind of have to play within this regionally.
Yeah, and moreover, I mean, this brings to an interesting stat that I have. Like 70% of India is still not developed, right?
Yes.
It's only 30% developed, right? The cities that you mentioned, the fast-growing cities, eventually the scenario is just the opposite there in those cities. 70% or more than 70% is already developed in those cities. And we have hardly like 10 to 15% left to be developed in those cities. That's why the expansion, greater Noida is happening, or,
Yes.
this Navi Mumbai is happening, and so on.
Maha Mumbai 3.
It will go somewhere, or maybe we'll reach Pune.
Yes.
I don't know. Calling Mumbai that it's right at the outskirts of Pune, I don't know. So the scenario is different there. You are absolutely right. We are more into the renovation kind of a business in those cities now, rather than, development and getting. Yeah, it's more of a redevelopment.
Redevelopment, yes.
The demand for redevelopment
Yes,
is really
it's
high
very
in those
high.
areas. Yeah. Whereas compared to the other tier 2 cities, or even for that matter tier 1 cities also, which is left to be developed. So the scenario is different. I completely agree with you that it has to be done on the focus should also be on the regional aspect, rather than having everything under the same umbrella of the national code. But yes, I mean, but having said that, this leads to the next question. We know that there will be increase in the performance parameters, right? And somehow I can conclude from what I heard is somehow structurally we were able to follow the codes till now, right? From a safety perspective, fire perspective, we were able to follow the codes now. Aesthetically and performance is something which we have neglected. This is, I think the panel is agreeing on that, right? So we have, because that is related with the cost. So the cost is actually making a big influence on the aspects of aesthetics. But cost is not getting into picture when the safety is concerned or the structural design is concerned, right? So this has been followed. Now, what we have to do in order to make this code successful. What do you think, how we should educate the industry, or you being developers, how will you push this into the market now and educate your end customers that this is for your good? How are you going to do it?
First thing, material as such, one is about glass we discussed, but facade has several other materials which comes in terms of application. So every material, understanding the material better is where you will be able to adapt it into your projects better. So the parameters which is right from its U value, right from its strength, right from its adaptability into external areas, internal areas by virtue of its UV coating or whatever it is. I'm saying for everything there is a parameter which we check. I'm saying that awareness was not there a few years back or probably a decade back. But now, today the awareness and that requirement is very much where we ourselves will try to get into detail as much as possible, try and understand the material specification in terms of what we choose and whether that actually works out value for money or not. So this guidelines, whatever we are trying to put through, which is your codes as a baseline, majority of the times codes are a reference point. But then it also has something which is called as prescriptive and one is performance approach. So performance approach, in the recent draft, what I've seen, a lot of examples, formulas, those things have been given. So that kind of understanding will certainly help people to understand more better. And yes, it is, sometimes I've seen consultants saying that you guys get into more detail, which is not required. And, leave it to the consultants in terms of, I'm saying the more the challenge, you'll be able to put it in front of the consultants. That's when the collaboration comes in and you can get the best product out of the solution. So this code, I foresee that we should have a lot of matrices. And one of the matrices in the document when I was seeing, there is something which is actually giving an interface between the parameters. How, what is correlating what?
Correct.
What increases, what reduces, and what impact will give to what?
Correct.
So these are things which are essentially required to be understood. And I'm saying as an industry practice, we should see that these things are quite often discussed. I'm saying we should create forums. We shouldn't have the forums for even students, for colleges, or I'm saying for even the industry practitioners. We should have forums to discuss. We should have something which is getting constantly circulated. I'm saying the more the awareness, more the implementation comes easier. So I foresee this is a greater opportunity to educate the fraternity. At the same time, it's an opportunity to get into the better thing. I'm saying the specification, the more you get in better, the better you ask what you need. So I might have gone with some specification a few years back, but I've upgraded myself in asking what I want now. I might have gone with certain seal and bite at one point of a time, but I might ask seal and bite today, which is a baseline. In fact, coincidentally, the baseline of a seal and bite, which is mentioned in the document, is something what we are also putting up as a standard in our project, and that's good to see and understand. I'm saying these are some things which I'm saying, unless you get into the detail, this is purely what we do. I'm saying if a doctor treats someone, it is a person who is getting affected. If a building is done, it's an entire community which is affected. So we are all part of that community where we are the doctors of the buildings, and we have to see this is what is catered in that way. So this is a great opportunity to have that all documentation is done rightly. And yes, we can read the document better is what I'm foreseeing. So as from my side, if you ask me, I would say I should have an opportunity to read it better, understand it better, much easy as general document, not as a code where people feel distant from the document.
Right, true.
So in my perspective, design plays a major role, and the design should be a need-based. What is happening nowadays is it's a fancy-based. So everyone are going for glass. Let me surround the entire building with glass. You might not require glass for for all 4 facades. It's not required. But what we do is, the other person is doing, I'm also, let me do. as architects, as designers, as facade consultants, or any of them, or even the contractors, everyone put together, what they have to say is, like, whether this building where you are building, does it require it or not? First define it. So I can take n number of buildings in Hyderabad itself where it's entirely glass with only lures.
So the need has to be clear.
Exactly. And what is the requirement? See, as a designer, you require only 55% as a glass area. Rest of it can be opaque. Design it. So what happens here is the need is met, the requirements are seen, your cost is also equally reduced. You don't have to do entire glass. Come on, it's not necessary. That's the reason why I was just explaining, I was discussing with Rohan also, like, one of the best buildings still I have to say is Tishman Spire's building, Wave Rock. See the nice fenestration, it has really given a value. You show me one blinds over there. But I can show n number of buildings in Hyderabad where they're entirely filled with blinds. It's additional cost you are giving to the client here, come on. So be realistic, provide detail which is required, and make sure you are able to adhere to. So when the code comes in, it is the necessity of every individual, understand the code, what is the need of it. When we are talking about sustainability, this is where the sustainability lies. We are not just here designing things, right? We have to give back to the environment. We are talking about biophilic, we are talking about green, LEED, everything over there. But eventually you end up covering it with glass.
Correct.
So code gives you answers for it. It's all coming on it all comes on the experience. The code also comes on the people, whoever is rating the code, it's all based on their own experiences, which they have seen abroad, what they are following, ASTM, UL, IS, BS, whichever is there. It's all collected and come to a single document where the people are supposed to read it properly, understand it properly, and make use of the code in such a way that you give a proper building back to the community. But eventually what we are doing, we are failing it. You have seen buildings in UK where they have built a building which is in a curve format, and because of the light and sun ray angle, the Ferrari car which was parked down was burnt out.
Yeah.
Architect wants design, it has to be curved. But eventually now they have done lures for it, just to avoid sun rays coming down. It was funny. That's what I meant to say is, make use of the code, give a design which is need-based rather than just going for architectural aesthetics alone. You can add later.
You can very well add. Take the mic.
You can then add.
So while largely I agree with you what you're saying, but I see it in a different perspective. Now, there are two aspects what we were discussing. One, I take your point when you're mentioning about aesthetics is something which has not been taken. I would rather keep aesthetics with the designer to function and take that in more functional aspect than getting it as a requirement from our side. That is one. Second, when I say building, the material choice, whether it is glass or whether it is any building, it primarily focuses on the orientation of the building and the way you're designing. Now, you can always have a glass building, complete glass building, but rightly ventilated, rightly put up in material choices will still give you the amount of energy saving which is needed, which is otherwise in the other building is still not achieved. Added to that, what I would say is today we are in a state where circular economy is something what we have to see, where the material choice have to be seen in such a way what material we can have the lesser carbon footprint onto it. So that is also sometimes a choice which comes in. But I still agree with you, in Hyderabad or for that matter in India, 100% glass buildings are not something like that. But then when we force ourselves to do something like that for various reasons, not limiting to in terms of the location of the building, what you want to see and what you don't want to see. There are other things which comes in about the timeline. Now today, time is the essence which drives the material choice of the building, what we take. I'm sure a lot of times in terms of the construction technology also what we choose is primarily adapting in terms of the timelines what we are looking at. And the larger the time, the larger the cost which is involved and larger the labor which is involved. Today getting labor is such a critical aspect. I think getting modular is becoming like a mandate for everyone. And that's when.
Let us all go for
But I also agree with you on the thing that our friend Mr. Rohan has done, even that he has done along with the stone clad also onto the thing. That's a project what you are referring to. And that is something is really good. That's where I was saying the more choices of material combination have to get into the code where we should be able to adapt it. We know that code is existing and we know this is how it can be done, but still can be achieved in terms of the parameters what we need. I think that's something which I just want. But I largely agree with you on the point. Right?
Yeah. Practically speaking, when you talk about architecture or aesthetics, and so aesthetics in the sense which looks good, जो अच्छा दिखता है वो बिकता है, जो नहीं दिखता है वो ऐसा नहीं है. But इसपे एक सर I will talk to a little in a different way. In 2017, in Park Hyatt, when Zak was conducting one edition, I think many of us were part of that. This is about 5th edition, and I'm 100% attendance in all the, what's the conference. Today they said, you can come for the panel discussion. I said, no, I will come in the beginning and I will also be the panel. But what happened is in 2017, they never allowed to ask the questions from the audience because like today it went on. So last last panel discussion, they were talking about the energy efficiency and this and that. And I was a little nervous and I said, I want to comment. Then he said, no. But I said, no, without mic also I will comment. Then he said, why? Then he gave the mic. It was 2017 in the beginning. And 2017 we got that ECBC implementation also. And I said, Hyderabad is going to be implementing this kind of code. They said, code kabhi, and the speaker was a little vague. Then I said, no, we are going to implement this because I am an architect and structural engineer. We work in a multidisciplinary thing and we will bring it on. And believe it or not, we started working on that. And in 2017 started, some people are here, those who took training of ECBC along with me. And then we started, see, it's not like other codes. And please, those who are coming from outside, our skyline is different. You know, somebody said, अरे यार, जब आप क्या बोलते हैं, शमशाबाद से आते हैं, even आपकी city भी बेकार हो गई. I don't want to say take the other metro's name, but they said these are all glass boxes. I said no, these are not only these are glass boxes, but it's a rated glass boxes. See, I don't have the same glass on the same all sides. We people are discussing like that, but see, one side, north side, I have a single one, and TG on the other side, 3G and 3. So this we try to market because see, we are architects. The people they come to us in the initial stage. We have the 5 phases, planning, designing, execution, operation, and maintenance, and we come in the first. When they come with the paper or the space and the budget, I think we are the people, those who influence and specify in the initial stages. So we are into residences, whatever. Independent house we can talk, but as a group. And these boxes, so-called boxes, they are all efficient because I'm the first in the country to get ECBC third-party assessor certificate. And I know that how these are implemented. And Telangana is the first in the country to implement ECBC successfully. And then above that, in 2007, when I asked that gentleman laughed at me. No, ये होता ही नहीं. मतलब करके दिखाएंगे हम. और हमने करके दिखाया. 2023, that was in this place, same place. I was sitting there, and I said, we have implemented about 100 projects. Me, in the sense, Telangana has implemented about 100 projects compliant through ECBC. We have reached up to 6-star rating, and then. Next edition will show you that about 30-40 occupancy stage certificates will be issued. And today I'm saying in this forum, in the same platform that 2025 Zak, that we have issued, as a collectively, Sita Mahalakshmi is there from Administrative Staff College of India. We struggled a lot. We have issued collectively about 25 five-star rated occupancy certificates, including the things which are completed. For example, I'm openly saying IKEA got the permission before ECBC implementation, but we requested them that we wanted to go through and simulate that. They got five-star rated ECBC certificate. They were happy, and our cycle in the government completed. Not only that, facade, it is not only envelope. We have on the top, no, topi to hai. See, when you see from the top, the flights se aoge, nothing is white. Then we are transforming our city into white by bringing cool roof policy, first time of that scale in the world. So our earlier government, they started, this government is also very keen to implement it, and it's compulsory, sir. It's not by option like Terry, Griha or IGBC. It's by default. If you want to apply for even permission, if your building is 1,000 square meters plus, there is no alternative. You need to go for ECBC certification. You need to have cool roof coating or cool roof policy has come, and we are also instrumental to bring in that. As an implementer, as a specifier, I'm proud that the team which is working for these things is working out, and I'm happy that all the product, specifiers or manufacturers, they are the people, they are the specifications for us. See, we are giving our requirements, you people are making it. So it's a good industry, and here, a professor is sitting, academia connect is required. Otherwise, this will not work. The people, those who are working, those who are, artificial intelligence is not important. The people, those who know artificial intelligence, they are important, isn't it? So new generation, they should know. Collectively, I feel next edition, we will be having some other policy which will be implemented first in the country. I think this is what we have to, sir, to conclude, when I came to Hyderabad from Bombay, because there the tall building sector was there, when I came, 5 stories building was the tallest here. Today 50 stories are common within a span of 25. But there is a sea change in the mindset of the people. At that time, jean pant बहुत अच्छा पहनते थे. आज जितना ज़्यादा फटा होगा, जितना ज़्यादा ripped jean है, that's a costly. That's the mindset of the people. When I came here, I was just 25. My client was 50 plus. But today I am 50 plus. My client is 25. See, that is the mindset, because we need to satisfy those people. They are accepting. Down the line, about 20 years back, there were only 4 cars or 4 products. Today we have about 600 products. You can see aluminum product, UPVC, and these things, we were not using it. But today everything is there. People are accepting it. I think technology, 3D printing, and without formwork, that is going to come. So it's not only glass. In fact, in my house, it was a net zero at that time. And today we are not talking about net zero. It's a carbon neutral. So we need to be, and sir, architecture, engineering should come together, because architect, when they struggle for 5 years, all these things, and today they are having interns, today they are struggling a lot, and we are the practitioners, we are going to the college and teaching. They are industry ready, no doubt about that. The number of people may not be, but they are industry ready. And my research in this is, we need of the hour is regenerative architecture with generative engineering. See, both the things can bring it. And one step ahead, that time I was working in isolation. Then with the situation came, I am into multidisciplinary, but today multidisciplinary is not going to work, because we need transdisciplinary concepts. And that is the next, what we need. So resilience and future ready buildings we need to do. So we are all working for that, and this practice will go on. Thank you.
Good to have the insight from you, because you already implemented GCBC and cool roof policy that you were talking about.
Yeah.
I'm sure you would have gone through multiple issues during the implementation, yes, right? And this is what actually we wanted to discuss here. Can you share some thoughts?
Sir, यहाँ पे ना code काम करता है, या rules law काम करेगा on the mindset. But those who are from Telugu speaking states, we have a very good Vastu Shastra. People, they like it to discuss or not, but I am so confident, because I came from western side. I was not knowing what is this Vastu and all. But when you've gone through that, the same thing what we learned in the climatology, isn't it? Sir, when I said single glass on the north side, DZ on this side, because thickness varies. You know what my client said? Arey, isme bhi Vastu hai. बोले क्यों? Thicker glass on the southern side and western side. I said yes. Then he said no compromise, go ahead. So luckily, if the mindset of the user, if that comes from the end user, I think this is going to change. And in fact, somebody called me yesterday that, sir, ECOS new and ENS, is there any ENS rated building? You know, they know it. And today it's a very, very educated client. And we need to understand that. I think we faced a lot of problem, but we need to go with the industry as a collective efforts, and it will come, sir. But we face a lot of problem. But many times people say that the government is not supportive, but the government is bringing the policy and they are making a lot of change. In fact, today we talk about the EV policy. And what is the role of architect in EV policy? Why? It's getting blasted. You know, we are talking about the safety of the building, but if my car is getting blasted in the cellar, then it's a problem. So infrastructure. So everybody has to come together. It's not only facade. For me, it's an enclosure which really matters and which will be making the life in the indoors safety. So education to the end user is first, and then हेलमेट मैं पहन रहा हूँ मेरे लिए पहन रहा हूँ पुलिस के लिए या किसी को फाइन से बचने के लिए नहीं है. I need to understand that I am safe. मेरा सीट बेल्ट मेरे लिए कर रहा हूँ, मास्क मेरे लिए पहन रहा हूँ, वो सिचुएशन आना चाहिए. And one more thing, sir. I mean, I'm taking a little more time, but we had earthquake here. We had earthquake here. Third day I spoke. कब आएंगे यहाँ? Earthquake था यहाँ पे. मैंने तो कहीं experience ही नहीं करा. बोला करेगा. अगर वो 7 आएगा ना, तो सब लोग करेगा. But 5.2 आया, तो कोई करा नहीं. But no one is bothered about that. Nearby, just 1 kilometer, one building got blasted. So we need to create a lot of awareness in the user of that occupant. So why you see when you are going, I mean, अगर आप कार में जाते हो तो कार को ब्रेक है या नहीं देखते हो, वैसे ही अगर किसी माल में जाते हो तो अगर सेफ्टी मेजर्स है उसका सब जो बिल्डिंग सर्विसेज अगर सही है नहीं है, सर वी आर कमिंग अप. आई मीन लास्ट वन, वी आर कमिंग अप. आई मीन वी आर वर्किंग विद द गवर्नमेंट. वी आर कमिंग अप विद वन बार कोड और व्हाट यू से दैट क्या बोलते हैं QR code that will be placed on the entry of your parking, and you have to scan that. Whatever updated certificates, whatever they have used, entire story is going to come into your thing. Whether it's a safe, whether it was renewed, whether it's not renewed, what are the safety measures available, what is the exit, what is in, everything is going to come up. Because of the new startups, Hyderabad is very good in startups. People are, youngsters are working, and soon you will see everything done. Right from the facade to the foundation, all details are going to come up from the scan, and people are working on that. Thank you.
Thank you, Dr. Ashwanii. Gaurav, any last words?
Yeah, I think it's more of a capex and opex kind of cost, right? So every decision is placed into these two baskets when you're developing something, capex and opex, right? And I think a lot of things when are in the capex basket kind of start getting reduced, right? And that is where I think the challenge in terms of design, challenge in terms of compromising on codes, challenge in terms of, diluting a lot of specifications, kind of play that role, right? So I feel that policy should be kind of aligned. Incentivization at that level should kind of be there, where the capex cost can kind of come down, where developers can kind of put in the right energy into using the right specifications, using the right materials, and not compromising in terms of design. I think that is the entire story, right? So how the government can kind of help reduce the capex cost, right? So EV, which you see this, is because the government incentivized that with the 2.5 lakh rupees rebate,
correct,
right? Which kind of catapulted that, and it started becoming, if I have to take a car, why not this? I'm getting a capex reduction, right? So you need to kind of understand the Indian mentality, right? And if you really want that change to happen, incentivization is the only way where you can kind of do that. Use it in the right way, reduce the capex, and then I don't think you'll have this panel required then.
Very valid point, very valid point. I completely agree with you. So what I can summarize from this next round of discussion.
One thing I would like to tell, or as a friend of the second part and the construction and all, when as a doctor I prescribe the medicine, the medical shop, that's he will see and then give it, isn't it? It's not like koi bhi aa gaya kaise bhi, aisa nahi hai. See, these tall buildings and these important sectors, building services, don't sell like that. See, we are issuing the design stage certificate with entire document. When I'm saying that, I'm talking about the commercial buildings or tall buildings, which is a major building. When we are issuing the certificate to any developer or contractor or building owner, those who are constructing these all tall buildings, they have the document. Okay? That document gives you entire thing. What are the U values, what are to be taken, because we are interacting with the MVP designers, facade consultants, everything. It's a very, very comprehensive, detailed document. When you are selling that, see, people are thinking that disaster first mission aa gaya, dekh lenge. Kuch bhi nahi kar sakte. Because once you are doing as a prescriptive type, okay, so 1-star rating, you will be getting 1-star rating at the end of the, because occupancy certificate is very important. But the other way around, so what is happening is they are taking 5-star rated, 6-star rated, and when the third-party assessor goes after the occupation, that is not even 1-star. So it's going to be a hell of a problem to get the occupancy certificate, even if he has done entire thing proper. If he has not used glass properly, if he has not used the materials properly, then he will be in a soup.
Correct.
So what I suggest is all the manufacturers don't supply like that. You take their document, at least if it's 1-star, you apply 2-star. If you are at least 2-star, and jo chahiye wo to dekhiye na. So that is a good USB for industry also, to tell them that if your document says that this U value particular classes or whatever it is. So you don't compromise there. Got it? No. So
correct. I would still put this in the bucket of awareness, education.
Yes.
They have to be aware.
Yes.
They have to use the right thing, what is specified.
Yeah.
So it goes into the same bucket.
Exactly.
So just to summarize this discussion, awareness, of course, education, and implementation from the government side. Very valid point from Gaurav. Incentivize it, because we Indians, we like incentives, right? So this is the way to take it forward. And I personally think with these aspects keeping in mind, it will be much easier to push the code into the industry, and I'll wish all the success for the new code implementation in all aspects. And and maybe the next time when we are sitting here, we are talking about the success story of this code, right?
Yes.
So thank you, everyone.
Concluding remark for the Jack.
Yeah.
That we are doing this much efforts, but this is not to the other sectors like end users or the builders and all. When that exhibition is there, I think there should be some 1 hour or 1.5 hours or 2 hours session open to everybody. Those who can come, they can interact, they can specify, they can connect, so that they will also demand their perspective. They can demand their specifiers that this is available, because this technology should be going to.
Unfortunately, I actually planned for a 5 minutes, discussion, but we are already 6 minutes above time. Yeah, it's already in minus, so I would like to just end it up here. So thank you everyone for taking the time out and making this a really interesting panel discussion. Thank you.
Thank you, everyone. Well, what an information-rich session to end today's program. Well, we had a total of 26 speakers today who gave their insights and expertise about the industry and the evolving aspects of our industry. We deeply thank everyone for their contribution today. Thank you, everyone. With this, we come to the end of today's session. Looking forward to seeing you all for the next Zak, which is in Pune on the 25th of April. Thank you.